Isn't that funny? And so if you last year were to say NASA's a military intelligence outfit, always has been. Look at their founding documents. Oh, you are a conspiracy theorist. And now everyone's like, yeah, of course they were. Of course they had to be, due to the rivalry with the Russian space program, due to all of that.
Man, you haven't. It's like, fuck. That is for me. That is the worst part of being a person that's in the know about things. Is the way the average person just fucking slithers into the new narrative, you know, and just they get a mind wipe about all their previous statements and ideas, you know.
Right. Happens with political agendas a lot.
Yeah.
Guys, are all of you flat earthers?
I think most of us in here are. Yeah, plenty more where we came from too.
Okay. If you don't mind, I'm just gonna add you to my block list. I never want to talk to you again. Thank you. Yeah. Take care.
Okay. Take care.
Right. Not that I would seek out talking to you.
Fucking weirdo, man.
You've got millions and millions of more people to block, dude.
Yeah, he's gonna be busy. What were we saying? Yeah, you know, like them. Oh, we knew it all along. Yeah, you know, I always knew that was what was going on. Blah blah blah.
Yeah,
that's the response you get.
Very slimy.
I think that attitude, that behavior, is like the de facto crux of the fucking human condition. I think it's everything that holds us back. That little fucking psychological behavior right there, because it's essentially just the refusal to admit you were wrong or completely clowned or totally out of the loop, you know?
Yeah, there's a lot wrapped up in this. There's lack of discernment, there's lack of integrity.
Yeah, and how do you begin your journey of discernment in your life? You first have to admit that you failed in discernment at some point.
Yeah. So now they're coming into the knowledge of things that we had prior for all the wrong reasons, which means they'll just as easily abandon this when something else comes along to grab their attention, when a new narrative resonates with the rest of the world. They look to the world and other people for their moral compass, their guidance and direction in life. You know? What is the government saying is true, so I know what to believe. What are all the people at work thinking are true, so I know what I believe.
Yeah, just consensus-based reality.
Yeah. And
sometimes I wonder if it has to be that way. There's a certain
kind of self-defense mechanism for that. Well, going with the consensus is kind of like a way to protect yourself. You know, it's a herd-like instinct.
It's the least amount of effort, first of all.
Yeah.
So it's energy conservation. Yeah, if they were free thinkers, maybe they won't be as fat. I mean, could the American obesity condition be somewhat caused by this mentality of going with the herd? Well, I mean, you don't just wake up 300 pounds, you know what I mean? So, yeah, it requires some
Here's
level of
social media
zombification,
chat.
and usually that begins with just following what's going on around you, you know?
Yeah.
It's other aspects, of course, you know, the kind of the work environment of the world. People not, you know, same way people don't have time to research into topics, they don't have time to care for themselves in the right ways. It's all fucking half-assed, you know. Switching on CNN's a half-assed way of getting information, and eating a lettuce once every eating a salad once every 2 weeks is a half-assed way of being healthy.
Right on.
It's something to do with the human spirit as well, right? I mean, when you're pumped, when you're all about life, right, and you see the beauty in it, you know, you see the creation, you see all the wonder of the world, right, and all the potential in it in yourself. You know, you naturally desire to be healthy. You naturally do healthy things. You know, it just being healthy just comes as a natural byproduct. But of course, we know we're fighting this epidemic of apathy and nihilism, right? So their bodies reflect that.
Right.
Yeah, their bodies are just an immediate reflection of their inner mentality / soul. They're ground down. They think they're worthless. They have no position of authority in this world, no say, you know. So their bodies reflect that.
Yeah.
That makes sense.
Is it bad that I kind of want something to come out of this 3 Atlas interstellar visitor to our solar system? Is it bad that I'm desiring some kind of upheaval,
What is that?
some
You have to
catalyst?
fill me in. Is that one of these weird fucking objects that they're
Yeah.
going on about, or
Yeah, one of many.
is it a new mission from NASA
Yeah.
or something?
No, it's one of those objects. It's one of many now that people are wondering if are aliens.
Well, we know something will come out of it then.
I mean, but all too often, narratives like this that have such long runway in the media have such a slow gaslighting are usually just nothing burgers. They turn out to be nothing. They serve a purpose to keep people distracted on,
Yeah.
and then they fizzle out.
Yeah. Part of it's just the natural news cycle, you know, they cycle back to some wild fucking space claim and then they forget about it and go on to North Korea, yada yada.
I would love for the government to announce it is freaking aliens and they're here. I think that'd be exciting. It'd be exciting for Flat Earth.
I think they like to dance with the idea that they know, but they know very well the population is far too fragile to have, you know, to initiate that. I can only imagine they would do that when they want to push the big red button. You know what I mean?
Yeah.
Can you see it going any other way?
Not really. Not really. There's no coming back from a deception that big. A moon landing hoax, they can admit to, they've got an out, they've got an exit strategy for the moon landing and for a lot of their space missions. Absolutely. They've got an escape hatch, but if they announce that aliens are here, they're coming to visit us, that's pretty.
There's no such thing as a flat Earth.
Mission.
We might give them far more credit than they're worth on this one, we might be falling into their scare tactics. Because, like, I don't know, what the fuck are they gonna, what's the narrative gonna be? Aliens are here, right? But, they've established their Federation fucking outpost around Jupiter and they'll communicate with us from there. And that's all you're ever going to know about them. You know what I mean?
I think it's Project Bluebeam.
Was that Melvin?
I think it's Project Bluebeam. Have you ever heard about it?
Oh yeah, that's the idea. Yeah.
I think that's a pretty, it could be anything. I don't know. It's either or. But.
I was just saying that I almost hope that they do it, that they decide to go forward with this deception. It'd be exciting.
You're a watch the world burn type of guy, aren't you, Amish?
Yeah, well, it's going to happen anyway.
Yeah. I don't know if you know about a TV show called Three Body Problem.
No, a TV show called that? Funny.
Yeah, I know. Yeah, it's based on a book series. It's it's sci-fi. The premise of it is as a distant civilization of a distant solar system, they have a three-body problem. Like they have like two suns or something, and they get very frequent cataclysmic events that wipe out their civilization. So they need to rush between one of these cycles to basically develop themselves, and then they discovered Earth and then come and take over Earth basically. But they did this oh man, how am I going to go into this? So they did some really trippy super advanced shit, right, to basically weaponize like protons or something. They were able to send the protons in advance to Earth to basically destroy our science and keep us set back because like the time it would take them to arrive with their fleet would be like 300 years, but by that time we'd be advanced enough to ward them off essentially. So they need to get ahead of it. They need to get to us with this fucking shit that can get here quick, fuck up our science and kind of keep us held back. And it's basically what I'm getting at is, so the premise is like the aliens interact with us on a way that we can't tell they're here basically. And that might be some kind of narrative they might go with, Kind of like the way, you've heard them incidents where they're talking about, fucking ships were flying around and shutting down our nukes, But even more stealthy than that, right? I don't know. Probably just fucking waffling there on a pointless tangent, but...
So a couple of days ago, I don't know if you heard me talk about this, but I was doing some research on the early rocket program in the United States, and also reaching back into Germany and Russia's. And so when they first started putting scientific instrumentation to collect data on these rockets, called sounding rockets, firing them up as high as they could go to study the environment up there. What was taking place up there is freaking weird and mysterious.
Cutting in and out a wee bit, man.
So I'm reading like these reports, like, oh, okay. Funny thing. Testing.
Yeah, I'm
back.
kind of losing every other word.
All right, is this any better?
Yeah, well, you're louder. So I followed you up to the point
Right,
where
so
saying
they're sending these rockets up to study the environment. And weird things were happening, specifically to the electronics. So telemetry data was getting wrecked. Like what the sensors were reporting via telemetry down to the ground stations was different than what was retrieved after the rocket had come back down or sent its payload out for retrieval. Things like this were going on. Electrical systems would experience problems, and they would go like shield it, and it'd send the rocket up again, and then those same systems would experience problems that got through the shielding, so they would shield it again and send it up. And it was almost like they were being screwed with.
Yeah, interesting.
Yeah.
It's like something grabs hold of it, fiddles around the data and the circuitry, and sends it back.
Yeah. Yeah.
But
I'm telling you,
completely
this is
stealthy. Yeah.
It's freaking weird, dude.
Certainly is. When you read into this type of stuff, it really feels like it's hard to deny that we're fucking dealing with, something way beyond us, just at these extended heights, I don't know how to say it. We're getting into the realm of metaphysics and fucking shit we probably will never comprehend in the physical form, in the three-dimensional mind and all that. I saw a clip of some supposed explorers of the North Pole, and they were talking about decline in mental state, basically, on these expeditions. And you know how you get you've got many kind of shows that show like people in groups starving to death, and that slow decline into like cannibalism, and start talking to themselves and shit, and that type of decline. They're describing something similar, and I'm thinking like, okay, you're in a really harsh environment. I don't think the North Pole is claimed to be even as remotely close to as harsh as Antarctica, but
totally.
Still, admittedly, a harsh environment, right? But people have done this before you. You're well prepared. Surely you're not running out of food. There's different. Your I forget your what's your sleep cycle called? Circadian. The circadian cycle gets all out of whack up there, because of course different lengths of day and night. So, like, admittedly, this is all happening, but they're describing like a mental decline that it doesn't really follow, and it made me think like what if it's like a broadcast range, like humans are venturing too far, and our minds start to actually fail us, because we're venturing beyond where we're supposed to.
Yeah, kind of like the movie The Thing in Antarctica, serving as an allegory for this.
Lost you again, or was that it? Just the movie, The Thing? I haven't seen it, so I don't know of it.
It's good. It's good, and researchers in Antarctica huddling up for a long winter. It's dark. They lose their minds. Kind of like The Abyss. The explorers take a submarine really deep and they lose their minds.
But I can understand. You've got like Admiral Byrd's testimonies of being in Antarctica for extended times, and he's like, he's in a wood cabin, like fucking snowed in for 6 months. Is like in that type of solitude, and like on the edge of death every moment of every day. I can understand it, But expedition into the North Pole, it's like that's you're constantly on the go. You get there and then you turn back, right? No. But they were describing in their testimony, like, again, one of them was plotting to kill his partner and shit,
Wow.
And I'm like, does it really get that bad so quickly? But then again, it could just be my own personal incredulity, like massive incredulity. I just have no idea what it is to experience these conditions.
Right.
You are from Australia?
I am not. In fact, I'm gonna. Yeah. He sounds like he's from Poland, Czechoslovakia. Just kidding. I'm gonna go check out 24/7 Flat Earth back home base and see what's happening there. There's some folks hanging out.
Yeah, I was gonna jump over there. Yeah. Melvin, okay. I didn't actually hear what you asked.
Well, I was just going to ask if you were Australian or something. Because if you never said you never really experienced Scottish. Oh, now you've experienced the cold. Come on, man, the winters in Northern Europe are pretty bad.
Yeah, it gets cold. It gets cold here, but I think people have an exaggerated idea of how cold, And I'm in the more, I'm central east, so definitely not the coldest part. Don't get like Siberian cold here at all.
Oh, no, I can get that up here. Actually, we do get Siberian winds.
Well, then you'll have better experience of it than me. The stuff we're talking about.
I'm a Nord man, of course, Viking. So gotta get used to it, I guess. But it was nice having summer here now, but it's so brief, and now it's October, and
prediction. There was no prediction.
No. So the prediction is the calculus, like the actual formula to do the thing. You need to go out in the field, actually measure the conditions, and then you plug it into the calculator. Then you take the picture and see if it matches.
Yeah, nobody's done
what
that.
The calculator predicted. Well, you're saying nobody's done it. You can do it yourself and disprove this. Have you done that?
I don't need to disprove it. Y'all need to come up with. Listen, y'all, you or whoever. I'd read the literature. Y'all need to come with the actual experimental justification for including this in anything. Because I, despite looking at lots and lots of literature and talking to thousands of freaking globies, haven't seen any prediction yet. Any. Zero. Zip. Nada. Nothing. I've seen lots of post-dictions.
Okay.
I've seen a lot of cherry picking. I've seen a lot of confirmation bias. I haven't seen anybody, with the exception of FE Core, ironically. So that took meteorological stations out to the environment, made measurements, made a prediction, shot the laser, right? Used the WGS-84 reference ellipsoid. Yeah, laser beam. Laser.
You wouldn't use a laser for this. That doesn't make sense.
Why?
It's not emitting like it's shooting electrons as well as photons.
Lasers don't shoot electrons, bro.
What's it called?
Lasers don't shoot electrons, man.
Have you ever seen
electrons? You're saying lasers shoot electrons?
Yeah, like have you seen the what's it called? It's not diffractive effect, where it actually will spread across the surface instead of just like normal light where it will hit the spot where it's aimed.
What are you talking about?
Like if you aim a light, like have you seen the?
Are you talking about the photoelectric effect?
Sounds like he's talking about Fresnel diffraction.
I don't know what he's talking about.
Yeah, diffraction over like a knife edge.
Yeah, it'll cross across an edge instead of just staying in the one spot that it's aimed at. It'll follow along the edge. Like, why wouldn't you just use a single source of light at your target?
It only does that for a period. It only does that for a distance. It's some fraction of the wavelength. Like, well, yeah, a sixth of the wavelength, and we're talking like fucking 450 nanometer. So it goes 100 nanometers. So what?
But I guess so. Would you have an issue with how I described it if you went out, got all the data first, made your prediction, and took your picture? Would that be a valid experiment to you at that point?
Yeah, I'd freaking probably die of shock if someone actually did it.
Okay, so what if I provided you one right now?
Yeah, go for it.
Well, I'm driving.
Prediction, yeah, sure. Okay. Prediction, you know what a prediction is. We already went over it. Prediction, meaning all the meteorological conditions are measured before the event, and then you do the experiment, meaning you actually write them down, and you don't post it, right? You don't have a refraction slider that you can move around to match any image.
Sure. I just don't see why you're like holding to this idea that it's always a post-diction. I would think that at some point somebody would have done a prediction and then seen, oh no, it's not actually matching the conditions that I'm measuring.
Yeah, you'd think that.
Like essentially you're accusing them of dishonesty, that they're manipulating the data that they're feeding into the model.
This is a common thing in modern science is to do post-dictions.
No, it's always predictions. They understand that it's invalid if it's a post-diction.
Oh, do they? So, where's all the predictions then?
I'm telling you, like, surveyors do it all the time. Like, you can do this yourself. You don't have to rely on anybody. You can get a theodolite.
You don't know anything about surveying, dude.
What?
You don't know anything about. Okay, what's reduction of the horizontal direction? Why they do that?
Deduction?
Reduction of the horizontal direction.
I have no idea what that even means.
Exactly. Yeah, exactly.
I mean, do you know how a theodolite works?
Yeah, I know exactly. Jesus fucking Christ, dude. Yeah, I know.
Holy shit.
You're in the pros. This is an amateur hour at the Apollo. Okay.
So how does it get?
I know how a theodolite works.
Yep. How does it get the horizontal?
Well, you find plumb.
Yeah, it's 90 degrees from plumb, right?
Yeah. Do you know that plumb lines curve in the globe? Did you know that?
Plumb lines don't curve on a globe. No, that's false.
It's getting better.
Yeah, read your own surveying manuals.
Yeah, so in the globe geodetic surveying, plumb lines are curved, dude.
That's entirely false. Why would they curve? They're pointed
That's
towards
entirely false. Okay, just remember what you're saying. Oh, okay, hold on. It's entirely true.
Sometimes there's deflections in a plumb line, but that doesn't mean the plumb line is actually curved.
No,
It's
they
still
say
straight.
it's curved. They say it's curved.
Why would a line pointing to the center of something deflect or be curved?
You tell me. Lumpy
You're the
gravity.
one making the claim. Why would I tell you?
It's not my model, dude.
They don't, like, a plumb line can deflect. That's different from it being curved.
No,
yeah, it's lumpy spherical harmonics of the gravity field that's contributing to the curve.
There's actually a published paper from. Hold on, let me find it.
Is that what you're talking about, though? The deflection of the vertical vector from, like, masses proportionate to it?
Well, that would be the measurement. But the plumb line itself, it's not just deflected. That's an indication of the plumb line curving.
Because, I mean, I know that that's a thing that, like mountains, when you're doing surveying, can cause the vertical vector to diverge slightly.
Okay.
Is that what you're trying to say?
This paper was called Evaluation of the Plumb Line Curvature Effect on Deflection of the Vertical, published 1999, 1986, Geodesy and Geomatics. Geodesy and Geomatics Engineering, University of New Brunswick.
Yeah, you're saying it's a deflection of the vertical, yeah.
Yeah, but it's interpreted as curvature of the plumb line.
But clearly you don't believe this paper because you don't think the downward vector shifts at all.
Said who? How do you know what I think?
How would it change on a flat Earth?
Well, what do you mean how would it change? Lumpy gravity.
You believe in gravity?
It depends on what you mean by gravity. But if you things fall, oh, what even is that, dude?
What's mass?
No, I don't believe. What's a mass?
Kilograms.
That's not a definition. That's a unit.
Yeah. That's how you measure mass. It's a number.
It's just
like
a number. So numbers attract numbers?
What? No, mass attracts mass.
Yeah, what's
like
mass?
Saying,
what's attracting
what's
what?
Length? And I tell you feet. Mass.
You said feet run up a hill.
Measurable quantity.
You said feet run up a hill. I say what's feet, and you say size 7.
No, I'm saying 7 miles.
Yeah, dude, that's exactly what you did, dude. It's what you gave me the units.
Yeah, I'm naming the unit of measurement. Yeah, I gave you the unit of measurement.
What are you measuring? What are you measuring?
You're asking for the measurement. I'm saying it's
the measurement of what?
Is a unit of measure.
What are you measuring? What are you measuring? Oh, mass is a unit of measure? Mass itself is a unit of measure.
Mass is a unit of measure.
Okay, units of measure attract units of measure.
This particular unit of measure, yes.
Did you just really say that? Think about what you just said.
So do you believe in gravity or not? Like, this is all just deflection.
It's not deflection. Things fall.
Do you believe mass attracts mass?
Things fall.
Or are you just pretending like you don't understand what mass is?
Mass is poorly defined.
Okay, so you don't believe in gravity. That's fine. No. Obviously you don't believe in gravity.
No, this is a retort. No. Depends on what you mean by gravity. If I ask 10 people what they mean by gravity, they mean a whole bunch of different shit.
It means space-time. Yeah, it means space-time.
Well, I mean, it could be.
No.
It's poorly defined.
What do you mean,
known in science itself that gravity is just poorly defined, that the cause is the effect at the same time, and that's what you're trying to do. And I'm trying to differentiate them.
No.
Hey, you don't believe in gravity, which is like implies, oh, you don't believe things fall? No, things fall. That's the effect. You want to call that gravity? That's fine.
Yeah, you have no idea why it falls.
Why is that? Why does that happen? Why do things fall?
Mass is attracting mass.
How do you know that?
We've measured it.
You measured mass attracting mass between the Earth and some object.
Yeah, you can do that with a scale, like stand on a scale, or you can do it with mass attracting mass directly. You can measure them with a...
None of that determines the cause. None of that determines the cause of why something falls. None of it. Not Cavendish, not a scale, none of that. We want the causal mechanism.
Like, you can do a bunch of experiments on why water boils at a given temperature and pressure. Doesn't mean that you're determining the cause. You're just saying that this is what happens when this happens.
No, we have a phase diagram, okay? We know that a certain excitation energy in the molecules will make the substance change phase, okay? That's what called boiling water is. I mean, you can put it in simplistic
what causes
terms.
That? Why does it change phase?
Because the thermal the kinetic energy imparted, okay, on the molecules, it can no longer maintain a bound structure, okay.
Yeah, but
so
why?
You have a number of degrees. What do you mean why? Because it has energy.
Why? It's not explaining a causal mechanism why these bonds are breaking.
Yeah, it is.
Just stating that it is breaking.
Because it takes so much. Look, it takes so much energy to break them. Okay, and once that threshold is reached, they're broken.
Yeah, but why? Why?
I mean, why? Don't act like a 2-year-old.
That's all you're doing with gravity.
No, I'm not.
You can measure this thing, mass attracting mass, and you're saying, well, it doesn't explain why.
You can't measure it in relation to a falling object, though.
What?
You cannot measure it in relation to a falling object.
Why does that matter? If you can measure mass attracting mass, why would you think mass would?
Why would you apply it to a falling object?
Well, you're going to say if you don't apply it.
Why? How do you know it isn't some other cause, dude? How do you know it isn't something else?
Because you can try it in a variety of conditions and see how if your predictions are coming correct.
Your predictive you can try something else and see whether your predictive predictions are coming correct.
No, to see if your predictions are coming correct.
Okay, that's fantastic, but we don't use the universal law of gravitation to predict how something falls.
Yeah, we do all the time. What are you talking about?
We use little g. We use little g. We use little g. We don't use big G.
You're talking about what? You can use both. You can use either.
Really?
Yeah.
Go ahead, calculate how far a cannonball flies by using big G.
I'm driving.
So that's how Napoleon did it. You need a priori knowledge of the mass of the Earth. Okay, where would you get that?
Okay, like clearly you don't like the idea of gravity. So what do you think?
No, I know.
To go down?
Like I have no idea. I don't know. Nobody's done it. No one's done the experiment required to do that, to determine that.
Well, you're saying
no one has done the experiment. You don't know.
You're saying because I haven't done a particular experiment myself, I can't say that it's been done?
No, not because nobody has.
Well, I mean, that's another assertion. You're saying that nobody's ever done a Cavendish experiment?
Nothing falls in the Cavendish experiment. That doesn't tell us why something falls.
No, it's showing you that mass attracts mass.
Yeah, how did you get to that's the reason something falls?
Because you do it again and again and again. Multiple environments controlling for variables.
Fantastic.
And if you get correct predictions back, that's a very strong indication that you're...
That's okay to leap logic and apply one thing to another thing, which isn't the same?
You need to go from describing what is happening to why and how.
Works?
No, listen, you can keep doing this again and again.
No, if you have a predictive model,
and you can see what is happening, but you don't know why or how it's happening.
Listen, you guys have him down. He doesn't know how anything works now. Listen to him. He's asking a question now. How does science work? How does the letter S work? How do letters get formed? He's getting down to the nitty gritty because he doesn't know shit now.
Okay.
No, I know how science works. It's predictions, novel testable predictions. And if your predictions come true, that's evidence that you are correct about your hypothesis.
All
You're
right,
saying
dude.
that these
Apple cycles forever, brother.
are there novel testable predictions are not actually evidence for the claim in the hypothesis.
Yeah, homie. No, homie, you're missing a very key point. Yeah, dude, you're missing a very key. You're missing a very key point about your predictions. You have to manipulate an independent variable to get the prediction you predicted. If you just make a prediction, and, oh, look it, today is Taco Tuesday, and you go to the cafeteria, today is Taco Tuesday. Bang, nailed it. That doesn't count. That's just truth seeing.
Did you miss the part about novel testable prediction?
Yeah, you'd have to manipulate variables to get your predicted outcome at your predicted results. It's not just like, I'm making predictions.
Change the mass and the distance. Are you saying that that's not manipulating independent variables?
No, that's not changing any variable.
That's not manipulating a variable, the mass and the distance between the masses?
You can't manipulate the mass directly, right?
You're saying you can't add or subtract mass from something?
Mass itself is what needs to be manipulated. If you were just moderating the amount of mass or moderating the distance between objects, at best you have what's called a moderator variable, which links whatever the independent variable is to the dependent variable.
I'm not understanding what you're saying. If you're changing the mass, you're changing a variable. This sounds like semantics.
It's not the independent variable. It's not semantics. This is part of what goes into scientific experimental design.
How do you identify what the independent variable is?
Sometimes that's the hardest part about setting up an experiment. You don't know, and you go on a hunt for it.
So if I tell you the mass and the distance are the independent variables, what's your issue?
That would be your dependent variables.
No, there's the independent.
Isn't your independent variable, isn't that gravity itself? Or is gravity the dependent variable?
No, the dependent variable would be the force of the attraction.
Which is you're putting a sticker on that, calling it gravity.
I mean, you can call it whatever you want. Sure, yes. The force of attraction between these two objects. That's
okay. So where did you see that happen?
Well, you measure it.
Where did you see it? Where did you see that happen? That happened where? You observed
in the
that
experiment.
No, before your experiment, you observed this happening where?
You're saying like your initial observation. You can see things falling down.
Okay, so you saw it's like an apple or something like that fall on your head?
No, that would hit me in the eyeball. I wasn't looking up when it hit.
Can you see things fall down in Cavendish?
No, mass attracts mass in Cavendish.
Yeah, but can you see things fall down? That's your claim, dude.
No, my claim is mass attracts mass.
Is that the prediction or the evaluation?
The prediction is mass attracts mass.
Prediction was Cavendish was trying to determine the density of the Earth, so that was not the prediction.
Doesn't matter. I mean, it predicts mass attracts mass, and then you measure if mass attracts mass, and it measures it.
No, it doesn't, dude.
Predicts mass attracts mass. Okay.
Okay, let me ask you this.
What's wrong with the experiment?
I don't want to you don't even know what's observed in the experiment. And I'm going to demonstrate that right now. What is observed in the Cavendish experiment exactly? They set up the whole contraption, then what happens?
Mass.
No, physically, what do you see?
Mass.
Mass. Can't see mass, dude.
Mass.
Hold on, you're breaking up. Oh, lucky for you.
Okay.
Hold on, wait till you got a signal. And you get out from under that bridge or wherever you are. Or is it me? Mic check.
No, it's him. He's all legged out.
Can you hear me any better now?
Yeah, that's good. That's good. So, what do the balls do? Yeah, what do the balls
ask
do?
Your question again?
Yeah, what do the balls do in the Cavendish experiment? Can you relate to me like exactly what's observed? Where you deduce that math attracts mass?
Yeah, they're attracting each other.
No.
Yeah, because they move closer towards each other.
And then what?
No.
And then what? That's
you
part
can
of
measure
it.
that force. You measure the force.
No, that's okay. What do they measure it with, dude? You have no idea what's observed. You don't have no idea what happens in the Cavendish experiment. None of you do.
The torsion bar.
I'll give 100. They're not measuring it with a torsion bar. So what happens
What do you
is
measure it with then?
they time a clock. They measure with a telescope.
A clock? You can't measure force with a clock. What are you talking about?
No. So
why would a clock measure force?
Yeah, good question.
How does that work?
Yeah, good question. They don't measure a force.
Can you answer
They infer a force. They infer a force from the force mass equation, right? So what happens is the ball rotates on a thing, right? They measure the rate of rotation and then it oscillates back and forth, back and forth, back and forth. They measure the rate of change of the oscillation and the angular change. And they do the force mass equation, Newton's second law, on how much force it takes to cause that acceleration. That's where they get big G from.
No.
Yeah.
No. That's not how that works.
I'll post a video of a fucking child in high school doing it, okay? Yeah, that's exactly how it works.
Why would I listen to a child in high school when there's actual scientists who have done this? What's happening is
actual scientists. This is how the actual scientists actually do it.
You said it was a kid in high school. The way the experiment is done is you have two sets of masses, each suspended opposite from each other. Then you move the two set fixed masses, closer to the opposite two that can oscillate on the torsion bar. You let them oscillate back and forth until they actually stop moving entirely, and you can use that to measure how much that torsion bar has twisted from introducing the masses, which you can then calculate the force, the attraction.
Okay.
It has nothing to do with time.
That's nonsense, dude. Everything you said is nonsense. How are they measuring the force on the torsion bar? How did they get that?
Yeah, they measure how much force it takes prior to the experiment to bend the torsion bar any given distance.
Good.
Then they place the mass a given distance away, and they see how much that torsion bar has been moved.
Tell us what a torsion bar is.
It's a bar that's incredibly sensitive. It doesn't take very much force to actually twist it.
Oh,
and it's got a very specific given value.
This is amazing. This is absolutely amazing.
Thank you.
I know it is. So it's just a bar that hangs. It's suspended from
I'm not the person who thinks that you measure force with a watch.
That's how it's done. They don't measure it. They don't measure force. They calculate it.
Well, I mean, you do calculate it, but you don't measure it with a watch.
The only measurements done is they measure the weight of the balls. Okay? Yep. And they measure the time it takes for the shit to move. And they do the force mass equation to infer a force.
No.
It's really simple.
Because it's on a pendulum, it'll oscillate the same amount of time back and forth every time. Like, you know how pendulums work,
eventually it comes to an equilibrium.
What?
Eventually it'll come to an equilibrium point.
Yeah, it'll stop moving, and that's when you measure it. You measure how much it's displaced from initial position A to the secondary position B.
They're making shit up, dude. That's not how it's actually done, though. That's how you imagined it was done, but that's not how it's done.
If I give you a paper, an actual scientific citation, so I'm going to be done driving in 5, that states that they measure the force through the torsion bar, will you concede the point? He muted himself. I don't even see how this.
Sorry, I was talking. No, because how do we get from that to that's why things fall? If you don't understand what we're talking about, how do you get from that the logical connection between I set up Cavendish and now I'm going to say this is why things fall? How do you get to that? The logic.
Sure. So
the logical steps.
You need to go with my understanding of the Cavendish experiment. Do you agree that?
I want the logic.
Yeah, I'm getting there. I need more than the sentence. So, if you agree with my understanding of the Cavendish experiment, would you also agree that if that torsion bar does twist, you can measure the force that's causing that torsion bar to twist?
Yeah, I'll grant you all that. Go ahead.
And calculate the force.
Yeah, great.
Sorry,
there's a force between the balls. Yeah, there's a force between the balls. Great.
Yeah. So if you can demonstrate that consistently using multiple different materials and changing conditions appropriately, then you can demonstrate that there is a force being exerted when you get two masses, you introduce two masses close to each other, that masses do attract each other.
How?
Do you agree with that conclusion?
Yeah, in that setup, let's say, yes, in that setup that happens. Everything you dream of, it all happens. How do you get logically from that to an object falling?
Yeah. So you see mass attracting mass, you can measure it, you can predict it and measure it.
Yeah, in that situation, yes, yes, you do.
Yep.
How do you get to a falling object?
Yeah. So obviously there's a lot more mass in the world than just those two balls. There's a whole lot of mass underneath your feet. And presumably that's causing a similar force.
Presumably, and there we have it.
Yeah. Do you have an experiment that shows otherwise?
I don't need to. You just presume the whole thing.
Well, I mean, all of science is done through induction. You see, gray goose, gray goose, gray goose. You're going to assume the next one's gray goose, not purple goose.
That's all fantastic, but you're saying that this is a universal property, right? That applies to all things.
As far as we can tell, it is. Yeah.
As far as we can tell, it is. I don't think so.
Yeah. Do you have an instance where this doesn't happen?
How come I have to disprove your baseless claims?
Because there's evidence for my claims. They're not baseless.
Yeah, but no, they're baseless. Okay. They're literally baseless.
You just said that if you do everything in the experiment, it does measure force.
That was a hypothetical.
Force between. Yeah, in the hypothetical. Okay. Yeah, of course.
Hypothetically, let's say that would happen.
Yeah.
First of all, I'm not even getting into all the problems with Cavendish. How it works when it shouldn't. There's no generated p-value. How you don't know that whether the effect is greater than chance. How if you change the orientation of the masses, you'll get different measurements. How things that aren't supposed to attract each other because they don't have enough mass to attract each other. How things that sometimes it just doesn't work at all. Like all the problems with the Cavendish. Tons and tons and tons of them. Okay, in the actual experiment itself. Then there's the problem of you're inferring from a rotation that somehow mass attracts mass, and then you make the gigantic leap of logic that's why things fall. That is a gigantic leap of logic. Okay, the observed natural phenomenon, you're not observing a natural phenomenon. We want to know the natural phenomenon that we observe. I drop something, it falls to the ground.
Yep.
Okay, that was observation. That's your claim, right? And you don't have an experiment, which actually, I don't need one. You haven't demonstrated yours. You haven't demonstrated yours.
Sure. So I think it really
you haven't even shown the association, the logical association, even between Cavendish, in which nothing falls at all.
What?
We want to know why things fall. Why do they fall? That observation, that natural phenomenon. So to demonstrate why a natural phenomenon happens, you make a man-made contraption and then say, "Oh, this is why." Just like our man-made contraption, this is what nature is doing over here.
Okay, so are you saying that you have that for like the flat Earth? Because this is like a pretty high standard. I don't see like how you would do this.
Dude, it's well known. It's well known in science itself that there's a problem. It's well known.
Yeah, I mean,
I can play a video right now of them talking about a bunch of scientists talking about.
But
No,
Like,
they've known this. This is why Newton repudiated his own theory.
No, he didn't.
No, he didn't.
Warren, yeah, block cost down.
Do you have a source that states he did?
I'll just read it to
I'm
you.
just ahead of the crew a little bit.
I mean, it doesn't even matter because you can go out yourself, do the calculations, and see if the predictions are correct, and they are.
Which prediction?
His field equations.
Newton's field equations?
I'm sorry, not field equations, but his gravitational attraction equations. Yes.
You guys can just back there.
Okay.
Like you can literally
maybe we will
measure
come through the back door. It might just be easier.
Hold on a second. What's with the verbal diarrhea right now?
What's that?
Hold on a second. Yeah, the people chiming in, do you have something to contribute, or you just chatter? Go chatter somewhere else.
Yeah, someone was home miking.
Oh, okay. Okay, I can make a prediction.
Yeah, you can go out and make a prediction with the gravitational attraction if you calculate the centrifugal force at the equator compared to somewhere else, like the North or South Pole, something like that. And you can actually measure what the delta would be. Go out and measure it, and it's been done hundreds of thousands of times. It's
hundreds of thousands of times. It's getting better, dude.
Yeah. It makes predictions about what the downward acceleration will be.
Yeah, you're full of shit, dude. Okay, I'm gonna tell you, you're full of shit. So there was
I mean, that's a real.
There's a scale company called Kern Scientific.
How that addresses what I said.
Yeah, I'm gonna address what you said. You're full of shit, dude. Your claims are not evidence. You realize that, right? The claims are not evidence.
Is this you refuting my claim? Well, I mean, you can go out and look at the measurements yourself, or just make them yourself.
What can be asserted without evidence can be dismissed without evidence.
Well, I do have evidence. You just refuse to say that it is evidence. Are you saying that people haven't gone out and measured the difference of the downward acceleration at the North Pole compared to the equator? Because it has been done.
Okay, and I'm going to ask you to post it, and you're going to say you can't.
I am driving for another minute. I can post that for you, though. I mean, they did it on the final experiment when they were at what's the place?
They were at the North Pole,
the southern hemisphere. No, they were at the.
They weren't even at a pole.
Yeah, but there's a difference between the equator and the North and South Pole, and then there's a whole spectrum of difference between those 2 points or 3 points.
Yeah, I know. I know there's a difference.
If those predictions come true, then that's evidence that your claim is correct.
Okay, first of all, they don't match the prediction. Okay, so we know this from the Kern. Kern did a test where they had a scale in a garden gnome, and they sent it to scientists all over the world. 21 data points, CERN, South Pole Station even. They sent them all over the world. And the measurements don't match prediction. They're not even close. In fact, it's just a random freaking variation. Okay, it's called Kern Scale Precision, a scientific equipment company. They took up one of their precision scales. They sent it to CERN. They sent it to South Pole Station. They sent it to Lawrence Livermore Labs. They sent it to Sandia National Labs. They sent it to different universities all over the world. And scientists there measured this gnome, wrote down the results. They pinned it on a Google frickin' map and generated all this data. Well, this data was taken off, it was put into a spreadsheet, and it was graphed. And that graph does not match the prediction even slightly. So you say people did it all over the world, hundreds of thousands of times. Ridiculous, dude.
And also, too, this guy's like all messed up. I mean, people have done things where they replaced a bar with like a piece of wood, or they replace weights with chicken nuggets in soda. Like, what the hell, man? You know?
There's one I was gonna. If he wasn't driving, I would post it. There's one where they use like a stack of washers that are metal washers that are all glued together, and they have them so that the holes are vertical, and then they flip it so that the holes are horizontal, and do the test 2 different ways and get different results, but depending on the orientation of the washers. So I didn't know that flipping the orientation of a washer changed its mass. So I don't know. Call me crazy. This is the second time in 2 days someone's. Well, when you get on wherever you're going, it's fine.
I did hear a lot of what you had to say, though. So, like, if I gave these,
you heard about the gnome experiment? The gnome experiment.
No, I didn't hear that.
Okay, so there's a scale company that makes scientific grade scales. So they had part of an ad campaign. They took one of their scales and a garden gnome, because garden gnomes were like in fashion back then or something. It was like a meme. And they shipped them to scientists all over the world and had the same one, the exact same one, same garden gnome, shipped them to scientists all over the world. And they measured this garden gnome. And they all got different results, but it doesn't match the prediction, even a little bit. South Pole Station, Lawrence Livermore Labs, Indiana National Labs, CERN, i.e. the Large Hadron Collider. So I think they know how to do measurements there in all those places. They took the measurements and it doesn't match the latitude change, the latitude weight adjustment that should be predicted. And these also wouldn't be predictions.
Sorry, go ahead.
I was going to just say these wouldn't even be predictions; they'd be postdictions. By the way, they'd have to do a calculation for it. Well, I mean, I'm just saying they're not predictions, but it doesn't even match anyway, so it's irrelevant, kind of.
Well, what if I gave you
in the chat?
Sure.
You're going to give me some anti-flat earther and doing some test? Great. Yeah, let's go with that. Sorry, I'll defer to CERN scientists using an actual precision scale company. Okay, a precision scale. So I had somebody, who was it yesterday, saying, yeah, they did this. Wolfie did this, but he didn't calibrate it. That if you calibrate it, you're doing it wrong.
Yeah, that's correct. If you calibrate at the particular place that you're at by putting like 100-gram test mass on it, if you recalibrate it when you're in your new location, it'll know that you have 100 grams and actually change what its output, like it'll change the calculation so that it shows 100 grams. Because it knows that there are variations on the surface of the Earth for the downward acceleration.
Is that why you calibrate a scale?
I mean, there's a good few reasons, because it does get out of true after a while, so you want to calibrate it for more than just that reason. Although, if you do move latitudes significantly, you do want to recalibrate, unless that's explicitly what you're trying to measure.
Digital scale calibration, they get out of calibration in minutes. Minutes, dude. I know, because I weighed a whole bunch of shit. You can weigh the same thing over and over and over and over and over and over and over again. And you'll get a fucked up result. And any digital scale, triple beam scale, they need to be calibrated. They're not accurate. You're getting a garbage measurement. But that ain't the point. Yeah. The point is that they've done this test and it doesn't match prediction. Point blank.
What's that?
they've done this test. Professional experimenters. That's what they do for a living. Is they do experiments.
Mm-hmm. Did you post it in chat?
Oh, I will. Yeah, hold on.
I'd appreciate it.
I didn't know if you were going to be.
Yeah, I parked. I'm waiting for my crew to show up.
Just had to post this last night. This is crazy.
Which, I'm not in here very often. Which one did you post it in?
It's going to be in live stream voice text.
There we go.
So, this is a Google. This is a spreadsheet with all the data put into it. It's a video going over all the different environmental variables, pressure, temperature, elevation, all that crap. Corrected for all that. Oh,
it's the Google Doc spreadsheet?
Yes. Yeah. You don't have to watch the video. I'm just posting that just for ha-has.
Yeah, where do you get the data from?
From their website.
Whose website?
Kern.
Kern or CERN?
Kern Precision Scale Company. KEERN.
Alright.
Here's a graph of the data output. So on the right is the data, on the left is the prediction. Variation by latitude. As you can see, they're not even remotely close. There's no correlation there in any way, shape, or form. Other people have done this too. Mr. Thrive and Survive did this at 3 locations. He's a trained meteorologist. A master's degree in meteorology. He's done this. There's a lot of fairy tales out there.
Sure. I'm just trying to find the data that he actually pulled from.
The data originally was on. You remember how Google Maps had pins? Like you could pin stuff on a Google Map.
Sure.
Years ago.
Yeah.
That web page is defunct. Okay, that's why I posted the video, because you can watch him go through Google Maps, go through all the data points, and put it into a spreadsheet. Because that website no longer exists. Served its purpose.
Oh, the data itself? Is it on the Wayback Machine?
The link works on the Wayback Machine, but the Google Maps feature doesn't work.
Wait, so like people just... Sorry, go ahead.
Because they just scrape the page. Google doesn't offer that function anymore.
No, I understand that. My question was, like, so where he got this data from is from pin drops that people left on Google Maps about these scales.
Am I understanding that? That's how Kern. That's how Kern put it on their website. It was Kern's website. So after they did the measurement, they submitted the data to Kern, and Kern added them to the pin onto the Google Maps on their website.
Google Maps.
So right, they ship the scale. They ship the scale to CERN. CERN does the test. They call Kern and say, "Hey, this is our result." Kern says, "Okay, we're going to put a pin on Google Maps with your results."
Sure. Yeah, and you're saying this is actually Kern and Son? Is that the company that you're talking about?
No, Kern and Son. I don't even know it was in Son.
SOHN. That's got to be it. If that's not it.
Oh, Kern and Son. Oh, yes, it's Son. It's German. Or Swiss or something.
Mm-hmm.
Yeah, so they make scientific equipment. This was part of an ad campaign. They actually won an award for this. for the ad part. Innovation in advertising or something.
I'm trying to. I just want to validate the data.
Yeah. So, mind you, I don't know if you know who Matthew Ernst is, but I showed him this, and he said, despite the data, what are you going to believe, the model or the data? He said, I'll believe the model. So that kind of tells me everything I need to know. Though that don't really apply to you. I just think it's hilarious.
Sure. Yeah. You should always go with the data. I'm with you on that.
But back to this model thing, because I take severe umbrance, like you have a model that makes a prediction, and if the prediction comes true, your hypothesis is correct. What about epicycles?
Are you talking about from the geocentric model?
Yeah. What about those?
Well, we don't use the geocentric model anymore, so there's no more epicycles.
Well, so you can't use it anymore to predict where you're going to see a planet?
Yeah, that's why we don't. Cause that I agree with you. That's a really bad. Epicycles are a terrible idea. No, because you got to adjust it every year. So it's not. So it's only predicting a very limited amount of time. The further out you can predict, the more accurate your model is likely to be.
How far does Newton's work for?
It depends on what you're measuring. Sorry, what was that?
How often does JPL update their ephemeris?
I don't know. I would think they would update it somewhat often. I have no idea.
Yeah. So what is the bitch exactly?
What's that?
So what is the bitch exactly? What are you bitching about? They have to update epicycles. They have to update Newtonian, Keplerian orbits. They have to update everything.
Well, I mean, you get more accurate information, and you want to update your model with more accurate information, right? You don't want it to just stay static, because a measurement between us and Mars or us and Jupiter, these things they're not exact. There's a for any measurement, there's a margin of error range, and if you can bring that margin of error down, then obviously you're going to have a more accurate description.
These aren't measurements, margins of error. It's model error. There's a residual error. So the point is that why don't we just go with epicycles? Because if it's a model and it works, let's use it, right? The reason we don't use it is philosophical. It has nothing to do with.
No, it's because it can't predict eclipses. It can't. There's a ton of stuff that it can't do.
We don't predict eclipses with a Newtonian model.
I mean, I'm not sure if that's actually correct, but I mean, if it is correct, we can definitely predict it now.
Right? No, it doesn't work.
Isn't there supposed to be an eclipse in 2026 in
and they don't predict it. They don't predict it with a Newtonian model. They don't.
Yeah, but they do predict it.
Not with Newtonian gravity or Keplerian freaking orbits.
Yeah, so you use a different model, but if you do predict it and your prediction comes true, that's evidence that your hypothesis is. Do you disagree with that statement that I just made? If you make a prediction and your prediction becomes true,
I don't understand what you mean by hypothesis. Like, what is your definition of hypothesis?
So it's just an idea about the conception of the real world. So I could have a hypothesis that God exists, and if God Bob exists and I pray to Bob, I will get a gold brick in my hands. If a gold brick shows up in my hands, that's evidence for Bob. And if I change the variables a bunch, I tried to pray to Bob in a submarine or secluded on top of a mountain, and every time the gold brick appears, that's evidence that Bob exists. Would you disagree with that?
No, I guess that would be evidence that Bob exists, but I don't know how it applies to this. This is a mathematical model.
Well,
this isn't existence or non-existence.
Mathematics is just a language.
Yeah, that's why. How are you getting from? I don't understand how you compared something concrete to something that's abstract.
I mean, you use an abstract model to predict the concrete future. So if you're predicting eclipses 10, 30, 40 years in advance and they're all coming true, that's really good evidence that your model is accurately reflecting or describing reality. Do you disagree with that idea?
Yes, there we go. Actually describing some future event, right? That you'll see something in reality. Yeah, great. But the underlying model itself isn't true or false or anything. It's just a model. Just data fitting, right? Because we have kinematic versus dynamic models. And the way we predict eclipses is a kinematic model. It's called the solar cycle. So eclipses happen with a regularity.
No, like the difference between kinematics is you're not predicting. Dynamic, you are predicting. You're describing.
No, you predicted kinematics. You just says no forces.
Well, clearly we're predicting eclipses. You agree with that?
We've been predicting them since like at least freaking
like 100
BC.
Let's just say
longer than that.
Oh,
way longer. First eclipse prediction with Thales the Miletus, like in 300 BC.
No, I
mean
a
flat earther, by the way.
The date, location, the size, the totality of the eclipse. More specific predictions than just an eclipse will happen on this day. We've only been doing that for, let's say, 200 years. Would you be okay with granting that?
I don't know when it started. I know that they used Baselian projection or something to get the location.
I cannot find where this guy got this data from.
It's in the video. You can watch him do it. Unless you think he faked an entire web page back in 2017.
You can trust, but you always want to validate, of course, right?
No, exactly.
I mean, the ultimate validation would. Okay.
Never trust anything. Validate it. That's how science is built. The power of science is that you immediately distrust it. As soon as you add the variable of trust, you've destroyed science. It's no longer science.
So if you can't validate it, then don't trust it. So if I can't validate these numbers that he's inputting, then I can't trust it.
No, you'd have to do it. You'd validate it by doing it.
Yeah, that's my point. You have to, there are other experiments where people do it. Well, you don't have to do it personally. I don't subscribe to that, do you?
Yeah, you'd have to do it.
You're saying you have to do it personally to subscribe to the belief of it.
No, you can believe whatever you
believe. Yeah. If you just want to slap a belief sticker on it, you can just believe in Bob. You just said, "Oh, old boy did it. He came down the mountain with a brick in 10 Commandments." Sounds good to me. I don't need to do it myself. Why would I have to do it? Bob did it. You can just throw belief on anything and just go. You'll be fine. The Western culture was built on Bob going up to the mountain and bringing back 2 stone tablets. You'll be just fine. Now, if you want to test it yourself and go up there and is there a burning bush with a bunch of golden bricks, that would be for you to do, not for someone else.
Sure, but if thousands of people have been to Australia, I can have strong confidence that there is evidence. I know that there is evidence for Australia. I don't need to go myself to prove that Australia or New Zealand exists, right?
Yeah, if that's what you want your worldview to be, that people can say they're from Australia, you've got evidence Australia exists, you no longer believe Australia exists, you know it does. Then follow that logic.
Justification.
Yeah, then follow that logic.
Yeah, so I don't have to personally witness or do a thing. If there's enough independent verification, especially if it's quantified and peer-reviewed, I think that's justification for holding a belief. Do you think it's not justification?
Now you're back to belief again. You can believe whatever you want to believe, whatever framework you want to believe it on. It's not about belief. It's do you know?
Unfortunately, I got to go. It was nice talking to you guys. I appreciate it.
All right. Have a good one, man.
That's really the heart of the issue right there. He doesn't really know things. He only believes things.
Whole shitload of things.
Because, like, even at the beginning, it's like, so do you know Australia exists based on all the evidence you have? No, I just believe it.
Well, like you said, like I said, he can believe whatever the hell he wants, but that's not what he's doing. He's running around saying, the shit I believe is true. I know it's true. Everybody believes it as with me, so you should believe it too.
Yeah, no thank
you. I was surprised he proved Gary exists. Yeah, so every time you pray to Bob, Gary makes gold bars appear because he wants you to believe Bob exists. And my claim fits the evidence, so I'm correct.
Yeah, there it is.
Now, what about Steve, though? Steve has hypnotically made Gary want to make dude think Bob exists. So he gave Gary the gold bar. So also fits my hypothesis.
Yep.
Were you listening on YouTube, AI?
Yeah.
Did you hear some of the shit he said? It was pretty outlandish. Who was that, though? I recognize that voice. I don't remember who it was. Just alt account.
I didn't recognize his voice.
I've talked to him before. I think it might have been in politics. Yeah, a lot of that was painful.
Oh, what was I thinking? Oh, mass attracts mass isn't a description of the cause. That's a description of the effect. Just said it a different way.
Yeah. It's actually true. Well, I mean, he defined mass. Dude, did you hear what he said about? What was it? He said units of measure. I said, so you're saying units of measure attracts units of measure? And he said, yeah.
Wow.
Yeah, he was, I'm glad he didn't spiral out, though. No, because I thought, like, after he said that, this dude's going. He's about to hit the wall and spiral out of here. But Alpha actually, taught me something the other day. Sometimes you can actually reel them back before they completely go off the deep end. I think I succeeded in doing that. Sometimes their ego can't recover from saying something that stupid.
Yeah. Yeah, you got to hit them before their self-preservation thing kicks in. Otherwise, they're just, it's a battle then. I don't know, dude. I feel like I feel like a fresh breeze of of intelligence float over my mind when I was hearing that guy say you don't know the cause, and you say, okay, what's the cause? And he's like, mass attracts mass. That's the same thing. So he's saying mass attracts mass because mass attracts mass. He's not saying the cause. He's describing mass moving towards a mass as mass attracting mass, and then saying the cause is mass attracts mass. Even after you told him that people don't know the cause, they just end up with the effect and the cause being confused, and then he just exemplified it. And I'm like, yeah, mass attracts mass that's not a cause. That's what you're claiming is going on. That's the effect.
Didn't he say the attract part is the cause?
I mean, he was trying to say that, but it's like, that's like saying a magnet attracting another magnet is the cause of magnets attracting magnets. Do you see how stupid it sounds now?
Oh, yeah. Yeah.
Like that literally, now that I just said what I just said, it sounds even stupider.
I know. I gotta put that one in my Batman utility belt.
Yeah, what's the cause of a magnet attracting another magnet? Oh, a magnet attract magnet. That's what the cause is.
No, it's magnetism.
It's Bob.
It's a Bob. Yeah.
Speaking of that, I gotta buy a bunch of magnetic levitation devices. Those are awesome.
He's obviously debated this topic before, but he was stuck in his little rhetorical script that probably works on TikTok.
Yeah. But yeah, I'm gonna buy a magnetic levitation clock. So it's basically a wall clock where the hand of the clock is a ball floating in front of the clock, locked in a they got a magnet within a magnet, and the poles are reversed or whatever, and so it's attracting and repelling simultaneously. So you put the little ball, and it just like floats about a half inch or an inch away from the surface, and you can turn it sideways and put it on the wall, and then you got a clock.
Does it actually tell time?
Yeah, they have them. You can buy them like legit, where they rotate, tell the time. Yeah. I want it because I want something that I can have a fully mechanical motion that I can pass my hand in between. So hopefully the hand being in between won't disrupt the field in enough so where the ball would fall. So another thing with the gravity thing, someone mentioned in the comments, if you put two balls on a table, and the table's flat and level, and the balls are separated from each other, they won't roll towards each other. Now our intuition is friction. Yeah, but our intuition is of course not, because the table's level, so it's not sloped. You know, if it was sloped, the balls would run down the slope. Why would the balls run down the slope? Well, because we know things roll down slopes. So when they do their little space-time demonstration where they take a bed sheet and they put balls in a bed sheet, which depresses the bed sheet and creates a slope, the balls then roll down a slope. And a lot of people don't catch that they're trying to explain to you a mechanism for gravity being the space-time bed sheet, when they're appealing to down, separate as the moving force. So they're already assuming there's going to be a downward vector, and then they're putting the balls on an inclined plane, the downward vector. So this isn't addressing how space-time functions at all. It's definitely not addressing any cause, because the cause of the motion there is something else, which is down, which we all experience. Which is a severe problem with these guys that can't think, is that they don't realize that when you tell them that Newton and Einsteinian versions of gravity are incompatible, it's not because they're not kinematically equivalent in the way that the motion is, right? It's that their causes are different. Nothing in Einstein moves without already being in motion. If it's not already in motion, it can't be affected to travel through a geodesic in space-time, because it's not traveling. The geodesic in space-time doesn't move the object that's not already moving. So there's no cause of motion in Einsteinian. So they have to set you up with the mass attracts mass canard to make you think that that's how things work, and then make you think that down isn't down, but it's actually inwards to a giant ball, and then do a bait and switch after you're convinced of all that space-time bed sheets is actually how gravity works. We actually have three competing ideas that can't actually be synergized. They can only be addressed separately. And each example relies on the assumptions that you carried over from the previous example. It's one of the reasons why they can't have a static universe. Everything has to be moving. Otherwise, Einstein's stuff doesn't work.
Well, I mean, his psychological escape was it works, therefore it must be true. But he made a lot of crazy freaking claims. Thousands of people, hundreds of thousands of people. There's lots of people that have done it. Like, I can't show you because I'm driving. Oh, now I'm at work. Bye. Yeah, you're never going to show us.
Oh man, thanks for reminding me. I gotta switch out my expensive eyeglasses to my cheap as heck contacts before I ruin them on the job site.
Yeah, I bought an Apple Watch, I don't know, a couple months ago. The face is fucking destroyed, like the glass thing, the bezel thing. Just scratches all over it and shit, and getting fucking trenches with a pickaxe. I've been doing in real life Minecraft.
Nice.
Still no diamond.
Great. I gotta find my contact solution. Good grief. Man, I should just rip my organic eyes out and just go with my red ocular implants. Dang it.
Go with the LASIX. Laser your eyes.
Dude, when I was in the Army, I could have got LASIK. Whichever one. So they offer you
the PRK,
all of that, but I didn't really know about it. It's the one where they, instead of the standard one was where they kind of like slice your eye like a garbage can lid, and then they flap it over. Then they do their thing, and then they flap the flap back, and then it heals. But you always have a weakness on that plane that they sliced it. And then the other one, oh, sorry, real quick. That one you can go back to work in like a day or two. So the other one is they essentially take a cheese grater and they cheese grate your eye down, right? And then they zap you. but that takes I can't remember if it's 3 weeks or 6 weeks, and you're blind for weeks until it heals. But it's super strong and durable and doesn't have the problems that the other one has, like with your eyes hurting, or a trauma can make your scar line sever, so your flap can come loose. So it's way better, but you have to be blind for a while.
Yeah, except it does have more complications too. Like it can have things go wrong with the way the lens heals, and can kind of create multiple vision and.
Yeah. So there's a third one, which is they scratch your eye around, and then they put a constricting silicone ring in it, right? And so they never actually touch any of the optical parts of your eye. So all that stays good, and they can actually, if they screw it up, they can redo it the same day. So those are the 3 eye surgeries, and I kind of never really bought into any of them. I was kind of too scared for any of them. And then I didn't know that the Army would have paid for it for free while I was in. Because I probably would have had it done then. But who remembers corrective lenses? Does anybody remember that?
Eyeglasses?
No, not eyeglasses. Corrective lenses.
The glass? Are you talking about the glass contacts that they had before they were plastic?
The gas.
No, what I'm talking about is what I'm talking about is a design philosophy. So there was back in the day. I remember when I was a kid. You go to the eye doctor. They say, "Hey, your eyes suck. Here's corrective lenses. Here's also a list of eye exercises. Do these exercises. Come back. Then we'll alter your corrective lenses, and eventually you'll see normal again." Versus nowadays, where you show up to the eye doctor and they're like, "Oh, I'm about to make money on you, buddy, for life." And so every time you go, they're not trying to correct your eyes at all. They're just trying to fix the current symptom that you're dealing with. So every time you go, your prescription gets worse and worse and worse and worse. Whereas in the old philosophy it gets better and better and better till you don't need them.
My ex, I think she did that. I think she had something wrong with her eyes. She had to wear correcting lenses. For astigmatism or something?
Yeah.
And then, yeah. And she stopped wearing them and they got worse and worse. I gotta say, now, you said the military was offering eye correction surgery. Now, the first thing I think of, why aren't they offering eye augmentation surgery? Shouldn't the military be like, "Oh, dude, we want super soldiers that can see 40 fucking miles"? Why haven't they tried that?
They did try it, and then they all went crazy and essentially turned into zombies. And then they're like, "Oh man, let's just turn this into a plot of a movie instead."
They did try it. Then they realized all their girlfriends are ugly. Now that their eyes are fixed, they went from being a 5 to now they're 2. Because now you can see every freaking blemish in their face, every freaking stretch mark in 3D freaking high resolution detail.
Yeah. Dude, you know what came across my feed the other day? Is these girls lauding over Taylor Swift about how immaculate her stage presence is with her gorgeous legs, and her legs are just so smooth, and they don't have any blemishes. They're like, "Oh, wait, she's wearing tights. And I'm like, you're a girl and you don't know about tights? And it's like, you're so dumb that you think Taylor Swift's legs are perfect and she's not wearing tights? It's like, holy crap, dude. Girls don't even know that girls are nowhere near the appearance that they should be. I'm like, what is going on here? When girls don't know that other girls fake their appearance, that's a really turn in culture, man.
Yeah, man. Yeah, I guess. Yeah. Good. We're complaining now, dude. Wait, in 5 years with AI, it's going to be ridiculous.
Yeah, go into a store in the men's grooming section, then go into the women's grooming section. The men's grooming section is a portion of an aisle. The women's grooming section is the rest of the real estate of that corner of the store.
Big money maker.
Yeah, especially since a lot of that stuff you got to use daily. So it's like, you know, you put it on, take it off, put it on, take it off, put it on, take it off. And it's like $15 a jar, you know. Well, some of it's cheap. I guess you can get the cheap junk, but you know how it is.
Jalen was talking about that his wife and I think he said his daughter used like an anti-aging cream, and then they wash it off and it clogs his sink.
Oh, that's a good one, dude.
Yeah, and they're putting it on their face, man. Like, come on, man.
I know. I heard they're using AI algorithms to crack the stem cell code where they inject your cells and reboot them and turn them back into stem cells or something to reverse aging. So I can't wait to see all the test subjects that sign up for that to be done in their face, and then their face ends up like hanging down like Snoopy, or not Snoopy. Who's that one? You know what I'm talking about? Where a bulldog, where all the Droopy the dog.
Well, what if their face turns back to a baby face, and they're like grown adults?
That'd be popular among the Democrats. Be like Darkman, where after 2 hours your face melts off and you have to put the cream on all the time.
Dude, baby-faced human, like adult humans, is like nightmare fuel.
Dude, do you remember the Catwoman movie where the one with the villain? Yeah, the one where the villain was like a makeup conglomerate, and her makeup turns your face into stone, and so she was like had super armor.
As long as it doesn't turn other people into stone.
Hey, Dio, did you see my shoe rock observation?
No.
Crap.
Where'd you post it?
Check 1 second, but I think, you know what, dude? I think I never put my contact in my case. It's gonna suck. Oh, here it is. You ever put in your contacts, and you know they have a left and right, and then you put one in, and then you accidentally turn it around, and then you're like, "Where's my other contact? It's not in here." So the whole reason they have a left and right is because some people have left and right prescriptions, but it's also supposed to be you're not supposed to switch. You're not supposed to switch your contacts, even if they're not different from eye to eye, because you could cross infect. But I'm like,
I just
screw it,
assume
bro.
people are just dumb, dude, and that don't put the contact and the two contacts in the same eye.
Dude, when I was in Iraq for 2015, I wore my contacts for like, without even taking them out of my eyes for like a couple of months. Just kept dousing them with a solution all the time. Then they banned him. Some kid had a melt to his eyes because he was stuck in a Humvee that was on fire, and he was close enough to the heat to where they like melted to his eye. And they said, no, you can't wear contacts in the field anymore. You got to wear your glasses, which sucks, dude, because your glasses fog and sweat and all that heat.
Yeah, back in the days of yore, it'd be like some of the combat arms. You'd have to have a medical waiver to get in with if you didn't have at least like something like 20/40 or something like that. Like you're expected to be able to function even without glasses on. Oh no, like some.
Yeah, I thought there was an eyesight cutoff. I thought you couldn't have.
Yeah, for certain MOSs, like combat, like a clerk or supply, it didn't matter. You qualify for those jobs, or radio operator. Yeah, but if you were some sort of combat arms, that required like you have to be able to see to some sort of standard without corrective lenses on.
Posted it. All right, look at those.
They still prove nothing, flat earther. Yeah, that's good. See. Is that Windsor Lake, dude? What clear mirage going on?
Oh man, was I on mute that whole time? Holy crap. Yeah, so who can pass my quiz that I put in the chat there? So there's an image, there's a blue streak in the middle surrounded by green. You got to tell me what object that blue streak is.
Canoe.
What color is it?
Blue.
Wrong. It's yellow. Let me show you. Good guess though. Blue was a good guess since it clearly looks blue. All right, here it is, bro. Man, did it go through? What the heck? Oh, there we go. Check it out.
Not bad.
Now, somebody guessed that what's occurring there is you may notice that there's a blue barrel in the bottom picture up high there. They said maybe it's the reflection of that barrel on the water. That might be where the blue color is coming from.
Nah. It's too close to the center reflection of the dock, where the dock meets the water. It's on the same line.
So this is about 1,000 feet. Google Maps. Well, actually, not Google Maps. The lake profile, but also Google Maps says it's like 330 to 333 meters to that little pier from the observer location.
How's it going, guys?
Horrible.
Sorry to hear that. What makes your day horrible?
I'm trying to listen to some flat smack and listen, but instead of setting up work.
So you can't really.
Set up tools.
Sorry, go on.
I'm just setting up tools.
What do you do?
Build things. Houses. Repairs. Stuff. Objects.
Nouns, even?
What's that?
Even nouns?
Do I
you
build
do verbs
nouns?
to these nouns? Yeah.
Yeah. I verb some nouns. I verb them real good.
Fuck yeah, man. That's what I'm all about. That sounds like a good day. Why is it bad then?
Because all my helpers are on drugs or in jail, bro.
Oh. That does suck.
What's the culture coming to? Yeah, exactly.
You want to discuss the flat earth at all?
Sure.
Are you busy?
Loosely. Kind of busy. Yeah.
Why? What's your proof of flat Earth?
Oh, I don't have any proof of flat earth. I think it's a globe.
Prove it.
Sure. Do you agree that you can determine your place on whatever surface this is by local solar noon? You can determine north, south, east, west, and latitude, longitude?
Sure.
Cool. Yeah, if you measure the distances between those measurements past the equator, they get smaller either direction, north or south. And at the equator, they're the longest. The only shape that I know that can do this in the proportions that it does happen is a globe or a sphere.
And so what? Still not curved.
Did you understand my argument, or?
Yeah. But so what? There's still no curve measured.
Well, I mean, if you can measure that the lines of longitude are converging north and south,
I don't care.
that is a compelling argument. I don't know what to say to that.
Well, measure the curve of the Earth, and that is the one that you'll win with.
Well, I mean, I could present that to you. I just don't think you would accept it as evidence. But what's wrong with the idea of converging? Well, I'd rather talk about the thing that I brought up because you wanted to talk about my proof.
Because that doesn't matter. It still doesn't make the Earth drop down away from you anywhere.
Well, I mean, geometrically, if there's two central points where all longitude lines converge, it would have to be some three-dimensional object. It can't be a two-dimensional flat sphere or a flat disc or square or any other shape.
Well, it's not curved, so you can throw that out.
So you think it's like a rectangular Earth?
Oh, I don't really care.
The measurements.
Yeah, it doesn't matter to me. It's flat.
It really doesn't matter to you that there's two.
No, I live in Ohio. I don't go anywhere. If I go anywhere, I'm heading to Vegas or going on cruises.
That sounds terrible. Well, I guess you enjoy it. Sorry, that's my own opinion. But how could it be any other shape if all lines of longitude converge at some kind of northern and central southern points? It can't be a two-dimensional object. Would you agree with that statement?
Nobody says two-dimensional.
Flat earthers do.
No, it's flat and stationary. And contained.
Like there's...
And we have air pressure, so that's another problem for you.
Not really, but what's wrong with my...
How do converging lines make air pressure?
No. Do convergent lines make the Earth flat?
Sure.
No, they're impossible. It's impossible to have two central points on a flat Earth.
Why?
How are the lines of...
So if the ground is flat, when you walk from north to south, when you measure from north to south and it's flat, and you have a point of rotation in the north and one in the south, and that's all done in the sky, what does that have to do with the non-curving ground?
No, I'm talking about measuring the distance between lines of longitude on the ground. You can measure them getting shorter.
Yeah, you use the sky for that.
Equator. No, you don't. You don't use the sky at all.
What do you use?
You measure lines of latitude.
Where are they? Are they drawn on the ground? Are they drawn on the ground somewhere?
Well, you can measure them. Yeah, you measure them on the ground.
Oh, where's mine at?
You said you're in Ohio?
Yeah. Yeah, so where's my... I want to see the one that's the closest one to me so I can see where it's drawn on the ground.
No, you can determine these things yourself. You don't have to trust other people. I mean, earlier you agreed with the premise that they're...
No, I want to trust that somebody knows where these markings are at. You said they're done from... You do this on the ground. That's how you figure out by looking... by measuring... your globe, by using your globe, you look at the ground, so you prove it.
Yeah. You use local solar noon to figure out what your longitude and latitude are on, and you can measure the distance between them. South and north of the equator, the lines converge.
Whoa, brother! Whoa! I thought you said it was on the ground, though. So I'm just critiquing from an outside observer in your conversation. No, I'm just saying, like, if you said solar noon, all right, let's just pretend you can't see the sun at all. Okay, what's your latitude?
I mean, I guess you could use the moon. I'm not sure how you do it without the sun. Like, at least in a rudimentary way. Are you saying that the sun isn't a reliable way to figure out what longitude you're on?
No, what I'm saying is the sun is the source of the latitudes and longitudes. The sky, it's not the ground, right? So it's your observer's location where the sun is in the angles where you're at. That's all it is. So the other guy was saying they're not on the ground.
You're saying the ground is dependent on the sky?
No, the opposite. The ground is not dependent on the sky.
Yeah, I agree.
So if you create a matrix of grid lines that you think are coordinated with a celestial object, that's not going to change the shape of the ground. So if you measure the ground and the ground measures flat, then it's flat. It's that simple.
Yeah, but if the ground that you're measuring, that you're saying you measure flat, is converging at two different points, north and south, it can't be a flat thing.
Yeah, but you didn't say that the ground was doing that. You said that lines that you interpret from the celestial positions is doing that.
Yeah, so what's the issue with using the sun to determine the distance between lines of longitude?
Because there's no triangulation of the sun. You can't do any like geometry with it in that sense.
Why would you need to triangulate the sun? All you're doing is at this given time is local solar noon here.
Right. So in order to take interpretation of your data and the other person's data, you have to put them into some kind of matrix or model, right, relative to each other. And then you have to assume geometric locations based on the observer's location relative to where the sun is. So you have to synergize these into one idea. Yeah,
you could say I have no idea. You could say the sun is an infinite distance away, and it would make no difference to what I'm proposing.
Yeah, you're proposing that when people are looking at the sun in their different locations, they're in a specific geometrical relationship relative to the angle that they're looking at the sun. That's your claim.
No, my claim is the sun can provide definitive evidence what longitude line you're on. And I thought you agreed with that. Do you disagree with that now?
Dude, that's circular. Your observer's location, the degrees to the sun, that is defined as that. So, like, what does that have to do with the ground, though? All right, sorry, I'm not supposed to be interrupted.
That doesn't
Go
make sense.
ahead.
The sun.
Makes sense.
Well, it was a question. I did want you to answer it. Do you disagree with the idea that you can use local solar noon to figure out what longitude line you're at?
Link up with the satellite's computer. We will only have 20 seconds to reprogram the satellite. Beyond that, and they will be too far apart. Okay. You're reaching 3, 2.
Do you agree with that? I want to know.
So you're using the sky then?
Does that answer my question?
Well, I'm just confirming that you want to use the sky, not the ground, to determine where you're at, right?
I want to confirm that we both agree on the same thing. So do you disagree or agree with my statement? Because if we both agree with it, then it's irrelevant.
I can figure out where I'm at using the stars.
What about the sun, which was my question?
Maybe. What does that have to do with the ground not curving, though?
I mean, it demonstrates my point that there are two central points.
I didn't say there wasn't.
Where lines. Okay, so how is that? That's impossible on a flat Earth. There's no geometry that makes that work.
Right. It's on flat. The Earth is flat. Right. It's in the sky. It's correct. It's impossible on the ground. It's in the sky.
What? I'm talking about the ground. Can you determine your are you not tracking the conversation? You can determine your longitude based on the timing of local solar noon. Do you agree or disagree with that statement?
So what?
So that's a yes?
Sure.
Awesome. Then you can figure out, if you go to point A and point B, and you figure out the difference in timing for a local solar noon, and you measure that distance, you can actually measure the distance between for a given length of latitude. Would you agree with that as well?
How are you going to measure it?
There's a ton of different ways. You can use a measuring wheel, car with an odometer, plane.
Is that linear?
You can do linear, sure.
That's a
you can
straight
use a
line.
surveyor.
That's a straight line.
Okay, that doesn't matter at all to my question.
It does. You're trying to. You're not telling me how the Earth is curving, though. Using all these methods.
I mean, that's exactly what I am proposing. Because if they're all converging at north and south,
then why can't we measure the Earth curve?
You can. You just reject the evidence for it. But
okay, what's the evidence for it? If I just reject the evidence, what's the evidence for it?
surveying.
Those are straight lines and triangles, and you can't have those on the surface of a ball.
No, that's not true. So, do you know what reciprocal zenith angles are?
Do you know what a triangle is?
Yes. Can you answer my question?
Yeah, I do. But we're going to take my test first.
Oh, so you don't like answering questions? I mean, that's been clear.
Oh yeah.
Go ahead.
Now I answered questions. Now it's time for you. So now we'll look in the live stream.
Go ahead.
Look in the live stream and answer this NASA IQ test question. Which of the figures below are not triangles?
I'm driving. I can't see it.
Oh well.
What, you trust NASA or something? Why would you want me to take a NASA IQ test? What does that demonstrate?
See how smart you are.
Dude, the title NASA IQ test is clearly sarcastic, right?
Sure, yes.
They never take the test.
So
yeah, keep in mind, Don Pettit. Hold on, friend. Don Pettit failed the test because when presented with the document, he just started to eat it.
Okay, I don't care. So if lines of longitude are converging at some kind of central point north and south, that demonstrates that they converge, that there's one central point for both set ends, but you can't have that on a flat object.
So you can only have angles. You can only have angles on flat objects. You can't have any angles on curved objects. So you lost again.
Could I throw two balls on the ground and measure the angle between them?
No.
What? No?
What are you going to measure from? What's your point of reference?
You measure from wherever you have your theodolite or whatever instrument that you're using to measure angles to the central point of each sphere or the edge of each sphere that are closest to each other.
So you're using straight lines then?
You can use straight line. Yeah, of course you use straight lines for that.
You have to use straight lines.
But the objects themselves aren't made straight by using straight lines to measure.
If I had two basketballs touching each other, what's the angle they're touching each other at?
That's an incoherent question.
Oh, so you can't have... All right, if I had a basketball sitting on a table, what angle is it sitting on the table at?
That's an incoherent question.
There you go. You can't have angles on a curved surface. So all of your curving measurements that you think are curving are just straight angled measurements. You can't take any of those measurements without it being a flat surface. You can't do it on a ball. So there you go.
Sure. So if I take a ball, basketball, and throw it in front of me.
No,
throw it in front of me.
No, that the basketball
you don't want me to talk.
No, you were talking about the basketball surface and you sitting it on a table. What's the angle that you measure between the ball and the table?
That's an incoherent question. I already answered this.
That's right.
All right, so let me demonstrate the idiocy of this point. You take a ball and you throw it in front of you. Then you have a theodolite, which measures 90 degrees from the downward vector, right? Do we agree on this so far?
You don't have downward on a ball. You only have in or out.
No, I'm talking about on the physical whatever thing that we live on. A theodolite
down can only be on a down is only on a flat surface. 90 degrees can only happen to the flat surface, not on a ball.
That's an excellent assertion. So let's say you do this. You throw the ball. You have the theodolite. You measure 90 degrees. That's your
why am I throwing the ball? Why am I throwing the ball and then measuring it with a theodolite? Why am I throwing it?
For the sake of the hypothetical. Holy shit, dude.
The basketball's sitting on my table.
Emotional control?
Yeah, the basketball's sitting on my table.
The basketball's sitting at the table. Yes, you have a theodolite out. You measure it.
Or what? Where's the theodolite
Wow,
setting?
holy shit. If I need to finish my sentence before you ask questions about the
Where
setup,
are you setting up the theodolite?
200 feet away. Does it fucking matter? No, it doesn't.
Why?
What's the goat doing in New Jersey?
You need
There's no relevance
it
to the
needs to be put
hypothetical.
on the surface of the ball so you can make angles to things from the surface of a ball like you would Earth. So you said you can't do that. It's incoherent.
So I'm going to take a ball, I'm going to put it directly below the theodolite. I'm using the center of the ball and the downward vector to position my theodolite. Now I have a second ball.
You don't have a sensor of a ball.
I have a second ball in the hypothetical. Do you really struggle this hard with hypotheticals?
Yeah, I'm not going to let you have this hypothetical because you can't have the center of your Earth ball. You don't have a measured curve.
I can't imagine things. They hurt my balls.
Why would I have to? I used to be a glober like you and imagine those things, but you don't have to anymore because the Earth is flat. You don't know what triangles are. You don't know what triangles are. You freaked out when I asked you what triangles are. You said it's incoherent to make an angle from a curved surface. That's incoherent. And
you know what
so now you're telling us to measure angles to the sun from a ball. That's incoherent.
All right, so are you going to let me finish the hypothetical now, or are you just going to keep interrupting?
Go ahead and finish all you want, but you know it's incoherent.
Sure. Your question was incoherent. Mine is not. There's clearly an answer. You put a ball on the ground, then you set a theodolite directly above it. So you're using a ball to situate your theodolite. You then take a second ball, throw it 10 yards, 20 yards away. It doesn't matter. You use the theodolite to measure the angle to the upwardmost portion of that ball. Can you measure an angle from either the horizon or from directly situated above that ball to get a second angle to the other surface of that ball? It was a question.
So they're both sitting on a basketball court?
It's in a field.
Why does it have to be a field?
It doesn't have to be. That's just my hypothetical.
Is it a flat field?
Sure.
Oh, so they're the same height?
I didn't say that. One's a yoga ball, one's a basketball. It doesn't matter.
I said two basketballs before. Now you change the size of them.
It doesn't matter. It makes that variable doesn't
so from the basketball. So now we need to set your theodolite up onto the basketball and somehow level it to the center of the basketball, right? But you can't do that because you don't have a center to work from on an Earth.
You don't have a center on a basketball?
No, you don't have a center to work from.
On a basketball?
You just can't set it on there and then turn it about 30 degrees and say, now that's centered on a basketball.
You really think you can't use the downward vector to point directly through the center of a basketball?
You can't do what you want to do, no. There's no downward on a ball.
I just said.
It's only inward on a ball.
You can't use the downward vector.
Down is only on a horizontal plane.
That's fascinating. You can't use the downward vector to pass directly through the center of the basketball. Is that your statement?
Where are you getting the horizontal plane from?
The downward vector. It doesn't matter. You can use the downward vector. You don't have to reference the horizontal vector at all. There's clearly the downward vector. You can clearly set it up.
Down is in relation to horizontal.
Through the center of the basketball.
So those are straight lines. You can't have that on a ball. No straight lines on the surface of a ball, remember?
You can do a tangent on a ball.
What's the angle between the tangent line plane and the ball touching it?
What's the taste of blue?
So you can't answer that question, can you?
No, I'm demonstrating that it's an incoherent question.
Yeah, so you just said I can measure a tangent though. So measure a tangent point for me.
No, I didn't say you can measure a tangent. I'm saying you can place a tangent on a ball.
And what does that do for you? What's the angle between the line that's sitting out 1 foot from the tangent point and the ball? What's that angle?
It depends on how far away you're measuring.
Dude, you just said it's incoherent to have any angles when the ball's touching a table.
No, I said your question is incoherent.
Mine is incoherent, but yours is coherent. Yours makes sense, but mine doesn't, right?
Yeah, exactly. Yeah, you're getting there. So you're saying you can't measure from the downward vector through a ball to the topmost part of another ball. You're saying that that's impossible.
You're not going to be able to do that on Earth.
It's a law of identity. It's a law of identity violation. Like, you're already saying that you can do that on a ball. How do you know what you're standing on is a ball?
Where am I saying P and not P at the same time?
Yeah, you're saying you can do this on a ball. Isn't that correct? You stated that over and over again. But how do you know you're standing on one?
Yeah. The converging lines of longitude.
Yeah, what is longitude based on?
Local solar noon.
He said angles, and I told him you can't have angles on the surface of a ball. He said, yes, you can. I said, put a basketball on a table. What's the angle between the ball and the table? That's incoherent. So now he's using something incoherent as his proof.
It's just interesting.
So you don't think you know what longitude you're on from local solar noon. Now you're changing your position?
Yeah, wait a minute. Yeah, but where are you deriving longitude from? What is longitude derived from? See, this is the part you're not understanding. Local solar noon. So when you say that, are you thinking that that's happening on a surface that's curved?
It can be, or it could be on a flat.
No. It's not. It can be.
Data, and then
it either is. No, sir. It either is or is not. It either is or is not a curved surface.
Yeah. So we've done the measurements, and yes, because this particular experiment that I'm talking about has happened.
Wait! Stop! You're jumping. You're jumping through. Hold on, sir. You're jumping through too many hoops. Right now you're saying because of solar noon. Yes, you are. Because of solar noon. Okay, latitude or longitude is being derived.
Yeah, you can know. Do you disagree that you can know what line of longitude you're on based on local solar noon?
So what we're trying to figure out is what is longitude and latitude derived from. And you keep it's local like circular. You said local solar noon, right? Is that happening on the surface that's curved or a horizontal plane?
You can make the hypothesis either way. I know
so
that
then
it's
inconclusive. So that's inconclusive then. It's inconclusive.
No, it's not inconclusive once you get the data. The data is how you demonstrate which one is correct.
McFinlan, you give two options. It either could be one or the other. It's inconclusive in your worldview.
No.
So you don't know.
So the way that I compare ideas is I take one, see what predictions arise naturally from it, and compare it to predictions made from the second hypothesis. So if the North Pole is the center of flat Earth, all
That's
lines
incorrect.
of latitude will spread out.
Hold on a second.
He's making up stories.
Yeah, hold on a second.
Oh, so you don't think the North?
Wait. Hold on, McFinlan. You just made up what you think flat Earth is. Do you think flat Earth is what you just described? No, hold on a second. You just described what you think. Yeah, well, you didn't give anyone a chance to do that because you've already made up in your mind what you think flat Earth is. I think this is where you're going wrong already. So you strawman.
What's your map?
You strawman the position of flat Earth, and then you started kind of wailing on that strawman. So you don't.
So you don't hold to the Gleason's map. What is your map?
There you go. See, this is the issue. So now you don't have a position to argue against if you don't know what we're saying. Isn't that
everybody has a vastly different position in flat Earth. So just stop crying and tell me what your position is.
No. It's not about crying, sir. It's about you being concise in your proposition. So if you're not doing so, it's an injustice to like the argument. So what you're doing right now is you're creating a whole narrative. You're creating a narrative about the argument. So the argument to you is about maybe flat Earth that's like akin to the Gleason's map. or AE.
Yeah, so the Gleason's map is disproved. I'm glad you agree. What's the correct?
Hold on a second. Wait a minute. Wait. But you don't know where those
complaining. I really don't want to hear it. Just tell me what your idea is.
This is correcting you on your assumption that you think that we're.
I already admitted. If you don't hold to the Gleason's map, that's fine. I'm not trying to force you to take a position that you don't hold.
So we don't.
Just tell me what your position is.
Let's say this. We don't hold to the Gleason's map. What would be your argument then?
That you have no idea what the shape of the Earth is.
So what does that have to do with you trying to rebut our position?
Sure. If you don't have a model, and I have a model that makes very good predictions,
there it is.
Then my model is far more likely to be correct.
There it is.
In fact, yours doesn't even make predictions.
Yeah, because
do you have a model that makes predictions?
Yeah, hold on, sir. You need us to have a model in order for you to have a position to argue against. Because we didn't present one, and at least now you're finding out we don't have that position, which would be the Gleasons. Now you can't find a way to combat what we're saying. You need something. You need for us to have a model in order for you to take a stance because you think you have one. And that's the reason why you come in here probably arguing about tangent planes. Because for you, it makes more sense, according to what you're saying. I'm drawing.
Okay, so what's your position on the shape of the Earth? Do you think it's flat?
Yeah, the shape is not what's in contention. This is the whole wrong way to look at what we're talking about here. We're not talking about shape. Flat is not a shape, sir. Do you know that? Or do you not know that?
Sure, it's a two-dimensional description. It's not three-dimensional.
Okay,
but I think we all understand what's being communicated when somebody says flat Earth.
Right,
You're saying you don't have a map? I don't want to misrepresent you. Just tell me what your position is.
Listen, first of all, sir, it's not about a map and it's not about a model. You got to remove that from the position you think you're going to argue against.
If you don't have a model, then you have no evidence for your position.
No, this is a problem for you coming in here thinking that this would be a better way to argue for this, and you don't have a position right now. If I was to tell you, how could you verify any model or map? Go ahead and tell me how you verify that.
Makes.
No, okay, predictions. What predictions? Name one.
Reciprocal zenith angles.
From what?
From 90 degrees.
Horizontal.
Yeah,
not to a ball. Not to a ball, remember? Because that's incoherent.
But we're back to Professor Triangle's point, right? You said 90 degrees. That's what he was saying, right? So we're back to now that you know we don't have the map and model argument, and we're back to what you're talking about, reciprocal zenith angles, and you need a 90 degree. What do you need to have 90 degrees? There's two things.
The downward vector.
Well, what's the other thing you're going to need?
Some kind of instrument to measure the downward vector?
No, I mean, like, what's the intersect? How do you have a 90 degree? What is 90 degrees?
From the downward vector.
Now, I know that, but what is it intersecting with?
It's not intersecting with anything. You're establishing the downward vector, and then you measure 90 degrees up from that.
He won't say it because it's detrimental to his position. This is the reason why he won't say it.
What do you think my position is?
Yeah.
See how you were just describing and saying you can't tell the other person what their position is, and now you're telling me what my position is?
Yeah. No, what you're not. This is important. What you're not saying is what the reason why you. If you're not telling us the full scope of the argument, you're not going to be able to represent your position correctly. So if you're saying 90 degrees, and I'm telling you to go ahead and tell the audience what does that mean, and you're withholding the information.
90 degrees is from the downward vector. That is my honest position. I don't appreciate you telling me that I'm being dishonest. I haven't said that about you.
Yeah. So you need a horizontal plane.
No, right? You don't.
Yes, you do.
No. You establish horizontal from the downward.
Angle. Bro, listen. If you don't have two intersecting lines that meet at a vertex, then what are you gonna? How do you have an angle if that's not what it is?
Imagine this: you place a plumb bob in a in an area where the air is very still, so it doesn't move at all. Can you measure 90 degrees off of that plumb line?
You need a horizontal plane. If it's 90 degrees.
Horizontal plane would be the 90 degrees off of that plumb line.
Yeah.
Are you saying that you can't measure 90 degrees off the line?
So this was Professor Triangle's point. This is the reason why you're not realizing that you don't have a curved surface. Because if you did, then you'd realize that doesn't work on a globe, what you're describing.
So Do you disagree that you can? Do you agree that you can do 90 degrees off of a plumb line? Because that's essentially what a theodolite is doing.
Sure.
Yeah, nobody's disagreeing that point.
So you can measure whether it's curved or flat. You can measure that angle.
No, wait. But what I'm trying to tell you is, like, if you're using this information, how does this help the globe in any way? That's what I'm trying to ask you. How does
I didn't agree that it works on a ball. I just said you can do it because the Earth is flat. That's all.
Everybody knows this. Everybody knows this, McFinlan. But I think you're not getting it for your position. It doesn't help you for the Earth being a globe.
So the reason I brought it up was reciprocal zenith angles. You remember this, correct?
Then you need a flat surface for that.
Yeah, you need a horizontal plane, bro. We're trying to tell you that it doesn't work for a globe.
What you need to do is compare the two hypotheses, right?
You said it was incoherent. You said it was incoherent, and now you're trying to make your incoherent shit actually be coherent. So what are you trying to do here? Is it incoherent or not?
What you were saying is incoherent. What I'm saying is not incoherent, because we both agree that whether the Earth is a globe or the Earth is flat, you have a downward vector.
So you're telling me you can't measure any angles when I put the basketball on the table, but you're telling me there's 90 degrees on that ball.
I'm telling you there's a downward vector, and we can measure 90 degrees off the downward vector. And we all agree with this.
You need a horizontal plane to do that, dude.
Why?
Even in your basketball example, you used a tangent plane. Did I not hear you say that?
No, I'm saying you could use a tangent. You could just measure center.
No. It's not a could.
In this example I posted, where's down on the example I posted? Where's down for that?
I'm driving. I can't look at what you're doing. Down is towards the center on a massive object.
Yeah, but first of all, you have to describe you're begging the question. You're already saying that you're standing on the ball. You're standing on the ball, and the ball, while you're standing on it, the downward vector is when you're standing on the surface of that ball. You're already begging the question. You're on a ball. Like, the problem is you don't know that.
When you compare hypotheses, you take both ideas and you see what both ideas predict.
It's not about an idea.
If you're on a flat Earth, there's going to be a downward vector.
McFinlan, flat Earth is an observation. It's not an idea. It's what the physical world displays itself as. You, on the other hand, do have an idea. But the idea that you have that the Earth is a globe doesn't compare to the physical world. When you go outside and you do field tests, it doesn't appear outside in any form of test, whether long distance observations or laser tests or any other way that we can test and measure. There's nothing you can do to manifest your idea into the physical world. However, flat Earth is.
Nope.
Yeah, no, it's
you're
not
saying
false.
that you're saying simultaneously that we don't have a model, we don't make predictions, and that the globe Earth does make predictions, but it gets some of those, at least some of those, wrong. And it sounds like you're saying all of them are wrong.
What is the prediction useful for? What is the prediction useful for, McFinlan?
It's used for a ton of things, for practical life.
Or
like if you want to know the distance between,
name one, dude. Stop being ambiguous.
Surveying.
Name one.
Surveying.
In what? What do they use it in surveying for predictions?
Yeah, like, so if you want to try to get two tunnels to meet, you need to be able to predict what angles you need to be.
You can't do angles from the surface of a ball, so you're screwed there. It must be flat then. There you go, sea level.
Like, I don't understand why is this like a religious chant kind of thing?
No.
Like, let's go from a spot that we all agree on, and then move into whether the Earth.
Dude, you said I can't set a basketball on a table and get an angle between the ball and the plane.
Yes,
so
somehow
now,
question.
Wherever you stand on a ball, you're able to get an angle from that surface of a ball, but not the opposite.
If the Earth is a globe or flat, there will be a downward vector. Do we all agree on this?
No, if you can't start a statement that is a truth statement with if. It's not logical, sir. A truth statement doesn't start with no. You don't understand logic, number one. And when you're going into it, you're saying if is subjective.
Why do you guys struggle with goes forward. If the Earth is flat from the downward vector, whatever you say, this is an idea. What's that?
Hold on, your internet was wonky. You have to restate the last 30 seconds.
Oh, really?
Yeah.
Looks like it was fine. Whether the Earth is flat or a globe, there's a downward vector. Do we agree?
No. Because something is
on a flat Earth. There's not a downward vector. There's things.
Yes, there has to be. Yes, there has to be because Earth is flat.
You're starting off with either this or that. You have to provide
both
evidence. Of them. Dude, listen to me when I'm speaking. You have to provide evidence when you're saying it could be this other thing. What evidence do you have to provide that it's this other thing that we're saying it's not? We're saying it's not a globe. You're saying it is. What evidence do you have to provide?
And it's a multi-step process. I have to explain all the steps. And if we disagree on any particular step, we can discuss it and see if we actually disagree. That's
you
how
haven't produced anything so far. So
how a syllogism works.
I went ahead and posted our flat Earth model, but since he's driving, he'll lose out. But that's our flat Earth model right there.
Is it a map or like a?
No, it's a
model.
Diagram. It's a diagram showing a guy standing in the middle of a north, south, east, and west cardinal direction with a circular tangent plane, and he's got like an angle to the sun, where it's got vertical, horizontal, and then the angle to the sun. So it's just a diagram showing that.
Yeah.
But you're gonna need it.
But if south converges at all points and north converges,
wait a minute,
all
dude.
northern lines.
No. That's something else. That you're going off something. We're not going there. I was asking you something very specific. Is there any way that you can? Because you said it was either this or that. Okay, so if you're going to produce something that's in the way of evidence, what do you have for it being a globe?
Data, reciprocal zenith angles.
Okay,
these are measured.
Dude, wait a minute. No. What things can you produce as evidence that gives properties of a geometric shape such as a sphere? We need something tangible.
Reciprocal zenith angles are measurements. They're tangible. You can do them yourself.
Plane for that. You need a horizontal plane. So that doesn't describe a curving surface. I've already said that multiple times.
No, it does, because those planes
it doesn't, brother.
Don't actually match each other. They actually diverge from each other when you measure them over any kind of notable distance.
What are you talking about?
Do you know what a reciprocal zenith angle is?
Yeah. When you said that the horizontal plane is different than the one where you take it at the other spot, how do you know that's true?
Because you can measure it. You can measure the deflection. So if
the deflection,
one theodolite is actually going over top of the second theodolite, but the second theodolite is also going over the first theodolite.
Wait a minute.
And obviously those horizontal planes aren't matching. They're
what
diverging.
Is the distance between the theodolites?
Wow, holy shit, man. It's like I'm in the middle of a sentence, and you're like, I can't let him finish this sentence. I don't want to actually engage with what he's thinking and saying. I can't do that. I need to interrupt.
Can you tell us the distance between the theodolites?
I mean, yeah, you can do it yourself because you won't trust anything.
Are the distances between the theodolites, sir?
Are you saying a particular measurement that's been done is like 3.1 mile?
Okay, so one is at 3 miles away from the other?
Yeah. One of them I looked at was 3.1 mile.
Okay, what is the maximum effective range of the theodolite used for that viewing distance?
There's no maximum range. It measures angles, not distance.
What? So it's not going to be inaccurate. Hold on. It's not going to be inaccurate at a certain distance?
No, it measures angles, not distances. Why would a distance affect an angle measurement?
Because if you're going to use
simple.
Go ahead.
Very simple. If I'm at gunnery, right, and I'm trying to hit my target on the zero target, and I have a slight deviation in my barrel attitude, it's going to be a major deviation at range. So my gun doesn't actually measure distance between me and the target, but my angle and especially my sight picture, which is how I'm looking through the sight to put the crosshairs on the target, if those aren't aligned, there's going to be a major error at range. So it's not an irrelevant question.
Well, that's for an object that's moving through the two space, like from point A to point B. We're just talking about measuring angles between.
Oh, you mean light? You mean light? So light's not moving between point A and point B?
I mean, it does move, but it's not affected by any of the things that artillery are affected by.
Listen, I didn't say artillery. I said a gunnery range. So if you're looking through a sight, right, you have the forepost and the back post, and they have to be lined up. And then that really attitude has to be lined up. That attitude. Hold on, brother. You didn't, dude. You were wondering why his question was relevant, so I'm letting everybody know why it's relevant.
Oh, so this does have to do with reciprocal zoom. Okay.
The idea that in a device is going to be the same accuracy at close range versus long range isn't a fair assumption. So it's fair for him to critique you, and maybe the device isn't accurate at those ranges, and the reasons why it would be inaccurate might be relevant, and that is true.
Sure. Do you have any evidence that a theodolite is less accurate at measuring angles at a distance?
Yeah.
Excellent. Could you provide that?
Yeah, it's called everybody who has any sense in their head understands that if I take I have an 8-inch level in my hand right now. Literally picked it up off my table. It's 8 inches long. Now, if I take this level and I level it on the side of my wall here, and then I try to draw from that level across the entire way, it's going to be a different line than if I take my 8-foot level. Now, theodolites don't have 8-foot levels in them. They have very small bubble levels, right? So the idea that that machine is going to be as precise at longer ranges as it is at closer ranges is absurd. Absurd, sir.
You don't think that they can make very accurately calibrated theodolites? That like the downward vector is always going to be correct.
You can make a finely calibrated. Yes, you can make a finely calibrated machine within the tolerances for the machine at the ranges which it's intended for, which is why he asked you, this machine that was used, what range is its maximum effective range? That's a fair question.
Well, I also posted the issue with that is why the theodolite doesn't work over.
It's measuring angles. Well, the issue is
listen. Very simple. How does it measure? How does it measure? How does it measure the angles? How does it measure the angles?
From the downward vector.
Wrong.
How does it do
it? You can't complete a measurement of an angle by just saying from the downward vector.
I don't want to hear about how it can't be done. I want to hear how it is
done. No, dude. You haven't told me how it is done. So, for example, if you tell me how do you get the pitch of the roof, I might say, well,
you're saying to make.
No, wrong. I'm wrong. I can get a pitch of a roof without appealing to a downward vector at all. I can measure the horizontal run, which is just assumed, right? And then I can measure the vertical run, and then I can get the pitch from a math equation. I don't need to appeal to a downward vector instrument at all. I can use a carpenter's square to get the pitch of a roof.
Okay, but you're saying.
But in order to do that, and so on my carpenter's square, friend, check this out. Check this out, brother. Yeah, it does. I'll explain. So my square here, which is actually a triangle, it's blue in the shape of a triangle, it has degree measurements on it. So I put one of the degrees on one line, and then I move the edge by rotating the square to where it meets the surface of the board, and then I read the other degree. So one of the marks is on one physical portion of the board. The other mark is on a second physical portion of the board. So to analogize what you're saying, what is the second point of reference when it's doing an angle? How does it tell an angle?
It just does it up and downward.
Okay, so let me help you out since you're clearly struggling. No worries.
You're saying that it is a particular other way.
No. I'll help you since you clearly are struggling.
So what's the issue?
So what you do is you put the reticle. You put the reticle onto.
Let me explain my confusion.
No, dude. No. You had multiple chances. Notice how I could explain my tools immediately and precisely, but you couldn't. Dude, I gave you 2 chances. What, do you want me to give you 3 chances so you're not up to bat anymore? 3 strikes, you're out?
Yeah. That would be...
Okay, fair. Go ahead and take your 3rd crack at telling me how a theodolite obtains an angle. Go ahead.
No, I want you to answer a particular question, because this is my only question that I want to explain. Because
No, dude. No. Okay, so we're gonna bench you. Since you're not answering the question. Since you're not answering the question. Oh no, because you started it with "I want a question answered" rather than saying "I'm about to explain how a theodolite gets an angle." So just explain the theodolite getting the angle. Okay.
Well, I think you're misunderstanding me. That's a sexton, but.
No, the misunderstanding here is why you don't understand. The misunderstanding here, friend, is that you need to drop out.
From the downward.
Friend, you need to drop out. You need to drop out and come right back. Go ahead. Your connection is crap.
McFingley,
your connection sucks. So just try to reset your connection. Man, I gave him a chance to talk about the theodolite making an angle, bro. I don't know.
Once, twice, 3 times a charm. Mic check. Try again.
Listen, he blew it when I when I said this to him, but I'm about to post. When I said that to him, it was over. He knew it.
Hey, hold on. Try again, McFingley.
Hello?
Ooh.
Can you hear me?
You're coming in real rough, man. Like it's choppy and sporadic.
The satellite's not working today.
Wait for the next Starlink to fly over.
That was good. I mean, AI
how about take a break? Take a break. Yeah, take a break and listen for a second since your connection's crap. And when you come back, we'll let you talk. So
he dropped out.
The reason why I was asking you how it happens, dude, was because when you level an instrument, like you said, you're relying on down. But we all know that instruments don't necessarily make a perfect calibration of the down relative to the plane of the instrument. Like anybody who builds anything knows this. There's error. And we also all know that error extrapolates out more and more the further away you get from the device. So when Homeboy asked you how far and was the device capable of being accurate at that distance, you scoffed it off like it doesn't matter. When anybody who has any practical real-world experience knows that level isn't going to transpose itself out indefinitely. Like I can literally demonstrate this with my levels that I own. I could take all my levels and the lines will be different. The bigger I go, the more straight the line will be. The smaller, the less straight it'll be as it gets further away from the device. I mean, this is so obvious. Listen, friends, this is so obvious. The idea that someone would critique you for asking that question is in itself an absurdity. Like it can't even be taken seriously. To even countenance it as a serious retort is silly. That would be like me. This is how it is, friends. That guy just saved me a lot of money. I'll explain. So my levels cost hundreds and hundreds of dollars for the whole kit. Hundreds upon hundreds. What he's telling me is I could have just bought a level from the dollar store that's only 3 inches long, and I would have been good for the rest of my life, no matter what I'm building. Do you see how absurd that is?
I should have done that. Could have saved some money.
That's why they have the different types of theodolites and total stations that are being used that have different ranges that they're effective as. But most of these guys that come into this discussion don't really know that. They just He's repeating. I think it's McToon's argument. I don't know who's actually championing the argument, but I think it's McToon.
Now, there's another factor of this called the sight picture. You have to know how the theodolite acquires the sighting, the target, like how it locks into, this is my initial target, and then it rotates on an axis to the next target, and then assumes that the rotation amount between those two targets is the degrees. Okay? Now, if there's any discrepancies at range, those degrees that the machine is telling you are not going to be the actual degrees, especially if you're assuming they're off a level plane or a horizontal plane that's teeter-tottering on a giant ball. Like, the fact that he doesn't get why these questions are relevant is just, it's mind-boggling. It's like he forgot to do his own thinking or something.
Hey, following a script, that's why.
It's a bit scripted, yep.
Let me ask you this question. If you put listen, if I give you my weapon and you put the reticle onto the target, are you going to hit the target?
What's the distance?
No. It's a very simple question. If I give you my weapon right now that has a scope on it, and you put the reticle on the target, will you hit the target?
Not necessarily.
Yes, or another good answer would be, I don't know. Both would be legitimate answers.
Okay.
Because there's so many factors involved. So, for example,
correct.
What is my sight picture? I'm taller than you. My eye to my cheek is different. Did you maintain a good sight picture? Is the weapon even zeroed? Etc., 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 etc.
Contributing factors, yeah. Was the gun clean? Because, from where the bullet comes out of the chamber, like that could cause it to spin differently when it's coming out. I don't know. There's many different things that could happen. But you being a weapons expert, I mean, you probably know that.
Right, so the optical device axis would have to be absolutely perfectly parallel to the plane that they're leveling. So if you have a level that's on the theodolite, right? Let's say it's one that has 3 bubble levels, right? And so you have to keep wiggling the thing till it's leveled. Guess what that's relying on? What is that level relying on? Do you know? What's the arbitrational factor of whether that level will be accurate if there's 3 bubble levels that you can see and you have to then level the device? What would be it would be your eyeballs, wouldn't it? Your ability to decide when that bubble is in the middle of the 2 black lines. Good luck with that.
Yep.
Now, maybe you have one that's auto-leveling. Okay, then you have the calibration errors of the auto-leveling plane versus the optical axis plane, and how those two are congruent with each other to how far they're making an accurate reading, which would be in what? The manufacturer's specs for the range of the device. So the idea that, hey, bro, how far was the observation? Was the piece of equipment able to make an accurate reading at that distance? In order for you to say that this thing proves anything, the correct answer to that can only be yes. It is able to make an accurate reading at that distance. And then you demonstrate how. I mean, sometimes the manufacturer is saying, hey, this theodolite is designed to get accurate readings at 10 miles for these reasons. You'd be like, here's some evidence that this device might be able to accomplish that. Because it's a claim by the manufacturer that it's accurate to 10 miles. At least that's something, instead of just dismissing it like your question was irrelevant.
Yeah.
So he's basically saying, oh, theodolites work forever. They never are inaccurate. They just keep going and going and going. It's like you could just buy the cheapest theodolite. Yeah, so instead of buying a $10,000 theodolite, just buy a $10 theodolite. They're all the same.
Yep.
Hey, dude, don't even get a theodolite. Don't even get a theodolite. Just go to Home Depot, buy the budget 8-inch bubble level, tape 2 toothpicks that you put together with super glue on the end as your crosshair, and then just guess what the angle is.
Who was that guy? I haven't heard him around here before. Was he new to the VC?
Don't know.
Yeah, you pretty much had him on the ropes there, Radwin.
Yeah, he's a piece of cake.
I just thought I'd scoop in on some of that light work. He was already struggling with your.
That's fine. I'm working anyway. I don't mind listening to. I just have to laugh at people sometimes, and I really have to just say. I had to go back to say, listen, dude. Now you're saying you can't get an angle if I put a basketball on a table because he was.
Yeah. I really like that point because he was struggling at that point. He didn't know which way to go. But I already knew that he had something in mind. He had a straw man idea of what flat Earth is, and I kind of coaxed it out of him because that's exactly what I was like. Yeah, I think I know where this guy's going. I just want him to say it because I can't have confirmation unless he's able to tell me exactly what it is, and then I'll be able to say, okay, now I know it's a straw man because he went with Gleason's.
Why assume that the North Pole? Let's just assume the North Pole is a point that exists on the ground, and that there are radials that come out from it that you could draw on a piece of paper. So you look at that just on a piece of paper. Now, technically, if you don't know the overall territory of the Earth, you could place that dot anywhere on the Earth, right?
Yeah.
And I don't mean anywhere on the known continents. I mean anywhere on the Earth. So if it's the case, let's just say that the North Pole is in the Arctic perimeter, above Nova Scotia, above Canada, whatever. It's always going to be above Canada. It's like not going to be in the middle of Canada. But how do you know that what's above Canada is the center of the Earth? Well, the only way you even assume that is because you say, oh, well, that's where the North Pole is, because that's where our coordinate reference system is pointing to, because that's where there's sky phenomena that we used as the base for our coordinate reference system. And there's also maybe a magnetic system that is similar. So basically all of you said is, this is the center of the synergy of the magnetic system and the sky map system. Not that it's the center of the Earth.
Yeah. Good point. A good point. That often is not being brought up, but that should be. Yeah, it's a good point. It's ways to think about the argument, like the way you just constructed it, is another reason why I think being let loose from certain argument constraints have given us the ability to like deconstruct the opposition the way that we have. In my opinion, I mean, I've been listening to many people talk about these arguments in the way that you have, and me and Radwin and all the other guys who come forward. And yeah, that's another way to look at it right there, because they're basing it off of, magnetic north and, where the stars are. But then how do they know their geographic position is in reference to like a specific type of map system? Yeah,
a lot of people did that. So they're like, okay, the Earth is flat, but we got the North Pole and we got these splayed out radials from the North Pole. Therefore, the North Pole is the center of the Earth. That doesn't follow.
It doesn't. Yeah, doesn't. Yeah, good point, man. Shit. You had a good night's rest at a Holiday Inn or what, bro? Like what the? It's a damn good point. I had to pocket that one.
I had a Red Bull.
Ah, yeah.
I got a joke for you. Why is drinking Red Bulls dangerous for flat earthers?
Shit, I don't know.
Because if he drinks too many, he'll fly so high that he'll see the Earth as a globe.
Oh my god!
Wah 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 wah.
That's a dad joke, bro. You should slap your thigh when you say that one.
Dude, I got my dad joke shirt, dude. It's got who's that guy? He's got Yogi Bear on it, and it says "Dad jokes. It's how I roll," but I is spelled E-Y-E.
That is so you. That for some reason I don't know why. That's because I've never seen. Have you ever showed a picture? Is that the avatar's not half a picture of you? Is it? I think I've asked you that before. Like maybe in your young military.
I'll let you decide which half. I'll let you decide which half. So I actually listen, dude. Listen, bro. In all seriousness, so dad jokes are actually very important because it creates the synergy between the children and the father with humor, which breaks some of the seriousness of life. You know, like some of these existential angsty questions, and they have this grounding. You know that their dad is kind of just loose and not taking it super serious, and so then they are not afraid. Now, there's fundamental psychological reasons for this. They did this extensive study, and I'll post why in the chat for you so you can see it.
Oh, our boy's back.
Hold on, bro. I'll post why in the chat. Don't worry. Here it is. Look it up. Look right there, bro. There's why.
I'll post why. Oh God, another thigh slapper. I got 1 million of them. You better watch out, man. You're gonna roll off that roof.
McFinglin made it back.
McFinglin.
Hello. How's it going, guys?
You want to pick up
a little bit better?
Off?
Yeah, now we can hear him clear as day.
There we go. Fucking NASA, right?
I'm not sure how far you think you can see on a clear day anyway.
Ooh. Right in the gut. All right, so going back to what you were just talking about, you can pick up where you left off. AI was actually asking you a question, not unless you want to go ahead and finish. I think you were going on the third explanation of how the autolites work. I think that's what it was.
Yeah, whatever. I don't care. We can pick up wherever.
Yeah, well, I mean, we have to.
Sure.
I mean, the base question is really boiled down to this: should I return all my levels to Home Depot and Lowe's and Menards and whatever other place I bought them from, and just go to the dollar store and buy a 1-inch cube level? Because I can level all buildings, all sites, and no matter the size of the foundation, I can just do it with a 1-inch level. I don't need my bigger levels at all. Should I do that?
No, the margin of error on a 1-inch level is terrible.
Okay.
Oh, so for longer ranges, you need more accurate devices. I rest my case.
I'm gonna leave the room
and
now.
the theodolite is that purpose-built instrument.
Job. Really?
Yeah.
All right.
Do you disagree that surveyors use it to accurately?
No, I mean, further solidifying the point that I was bringing up to you earlier, which is why it's important to know what they were using. It wasn't an unfair question. It was legitimate, and you just went all over the place because you heard me actually questioning what they were using.
And you said you can't get that from a ball, so you said the Earth has to be flat. I said if you put a ball on a table, remember? You were like, no, that's incoherent. So you can't put a theodolite on an incoherent surface and start shooting angles off of it. There you go.
Well, I mean, you can put a theodolite in a valley surrounded by mountains. Obviously, it's not using the horizon to determine what the horizon is. It's using.
I didn't say use the horizon.
Downward.
I didn't say use the horizon.
You're saying horizontal plane? Is that the correct term that you use?
No, when I set a basketball on a table, I set my basketball on a horizontal plane. So that became my theodolite. Now that I set the basketball in my hand and I'm balancing the table on it, now that's my theodolite balancing on the ball. And you said you can't make angles that way.
Well, I mean, you're making.
But now you can't. No, you said it was incoherent, but now it's not incoherent.
Well, a theodolite isn't measuring the contact point between a circle and a straight line. I don't even get what you're trying to demonstrate with this.
You're right, because the Earth is flat. It's between two straight lines.
So if the Earth was curved, if it was a giant sphere,
it's not.
What would you think? Yeah, sure. I understand you think that. What would be the best way of doing an experiment that would demonstrate the difference between the two measurements that you would get?
We would see curved Earth dropping at 1 mile, 2 miles, 10 miles. We would see that drop, especially over the ocean.
Yeah, and you don't think that like objects being hidden, like the Chicago skyline being hidden.
Oh, that's
by
52
what seems
miles.
like flat water.
52 or 58 miles. Yeah, that's not that's not an illusion just flying up in the sky. No, you're seeing it.
Well, yeah, but you can't see the bottom of the buildings. Why can't you see the bottom of the buildings?
Because of your angular resolution, so close to the ground. Waves are in the way.
What?
Waves are in the way. Yeah, all that shit's in the way. Heat waves are in the way. Yes, dude, it's just getting distorted right there. That's all. That's why you don't see your buddy waving to you. It's too small at that distance.
Well, obviously, angular resolution isn't an issue because you can see the buildings.
Okay, somebody posted it for you.
But
yeah, so tell me what the guy
was
looks
actually
like
saying
in the
something.
window in that building. What is he waving with one finger? Is he giving you the middle finger, or is he holding up a peace sign in that window from the 52-mile away skyline?
I can't look at.
Or are those buildings just floating in the sky?
I would like to be able to finish my thought. I can't look at it because I'm driving, but if you can clearly, it's not an angular resolution issue because you can see the building.
1,800 feet of curvature should be hiding the tallest building completely.
Do you have Tourette's? Like I was trying to finish like 2 or 3 sentences. I don't want to be like dogging on you if you got a medical condition, but it is very rude.
I have the I'm always right condition.
Okay, so it's not a medical issue, it's just a manners thing.
1,800 feet. Where's it at? The only other choices are floating in the sky, or the Earth is flat, one or the other. Floating in the sky or the Earth is flat. That's why you see them. How come? You brought up the skyline, not me. Wah, 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 wah.
Is that it? You gave up? Earth's flat?
Yeah. He said it's incoherent to get the angle between a ball and a horizontal plane.
Bro. He still hasn't explained how a theodolite gets an angle.
Nick Singleton, how does a theodolite get an angle?
Crash. He's mad at me.
Back and forth. And you can describe that goes to one direction, and then the further it goes the other direction as the angle separates. How do you know what the angle separations? Right, so you got the axis, which is rotation.
I think you're fucking.
That's 3 points. Canadians, what can you do?
Yes, I am Canadian. Sorry, guys, I had a work.
How does a theodolite measure?
Do we want to keep talking about?
Yeah, how does it measure an angle?
Yeah, from the downward, from the vertical.
But where's the 90?
How does it measure an angle? It measures it from the downward. The 90 is 90 from the downward. Do you think it measures something else?
Holy crap, dude. You're really struggling with this, aren't you?
Well, I'm struggling to understand what you think it is measuring from. What is it? If it's not the vertical vector that it's measuring
I asked you a question. I said, how does it measure an angle?
What was my answer?
So you said it measures an angle. You said it measures an angle from the downward vector. So notice how you said it measures an angle from, then you explained from, but you didn't explain the it measures an angle, which is the angle measuring part.
Oh, like the mechanics that it uses to measure angles?
Oh my goodness, dude. Dude,
is that what
I have a theodolite. I have a theodolite. I set it up. I want to get an angle of something. How do I do it?
Sure, you set it up, make sure that it's properly leveled, pointing directly down, and then it'll measure up from that downward.
Holy shit. Do you guys see where he's going wrong? Does anybody else see it?
Can you tell me what it is measuring from?
Dude, you are repeating the same thing. Listen, friend, you're repeating the exact same thing over and over. When I parse it out for you, that's not what I'm asking for. And indicating to you, you probably shouldn't repeat the same thing. And then I'm focusing on the measure of an angle part. You still go back to where it's measuring from, not the actual conclusion of measuring an angle at all.
Sure. So are you asking me how it's measuring an angle? Like the mechanism?
Real quick. No, real quick, dude, real quick. You're the equivalent of a guy on a job site where I say, go measure the angle to the roof from the floor. You come back and say, I measured an angle from the floor. And I say, okay, what's the angle? And you're like, I measured from the floor. And then I say, yeah, but what's the angle? And then you say, I measured from the floor. And then you get fired.
No, I'd give you a number of degrees. So that's
okay. Okay. So you go and you go to measure from the floor. Then what happens? Because you can't get that measurement of degrees without other steps happening first, right?
Yeah, you get the downward vector, and then you measure up from the downward vector.
So, to what? To what?
A ball in this case? Basketball?
Right, and how do you know you're measuring to anything? You have to see it in the sight picture of the scope, correct?
Yeah.
Right. So you have some kind of reticle that you assume the optical axis of that scope is horizontal, parallel with the surface of the Earth, or parallel with a tangent plane you imagine is teetering on a giant ball. And then from that axis, you assume that that is horizontal or a baseline of 0, right? And then the instrument rotates as you're attempting, the instrument rotates as you're attempting to then put the reticle onto another object, right? Or a object as a target object. The amount of rotation is measured in degrees. And so you say, okay, the object is now in the center of my reticle, and the device has moved this many degrees. And so I'm going to say it moved 27 degrees because that's what the reading is. Wow, that was so hard, dude.
Yeah, it's measuring angles. I don't. How does that instantiate? Like, can you explain the first part of what you said? Because you set it up, and then you immediately said it measures from like a horizontal plane. That horizontal plane is established from the vertical. Do you disagree with that statement?
No, I said you assume it. You could actually assume anything, but if you're
vertical.
Oh, I'll tell you why you have to assume it, because you didn't perfectly level the device, so you're assuming that it's horizontal.
You think you can perfectly level anything? Think you can perfectly do anything at all? It's all
no. That's why you. No, duh. But you're telling us that theodolites work indefinitely at all ranges.
They all have a margin of error. Like, are you denying that they have a margin of error, whether the thing's close or far?
Dude, it's not
the
just
margin
a margin of error.
Is
maximum
degrees.
Effective range. There's a maximum effective range, dude, for theodolites. You didn't know that?
No, there's not. It's measuring degrees, so the margin of error is in degrees.
Never mind.
Do you disagree with that? We're talking about like arc seconds. It's gonna I think it is like an arc second, or really good theodolites can measure within 1 arc second. Or are you saying that if the object is further away,
so
arc second?
Right. So tell us the evidence. Tell us the evidence that you were asked, which is the device used in the measurement you presented as your evidence for the reciprocal zenith angles. Was that device capable of being accurate at that distance, or was it beyond its maximum effective range?
No, it's accurate at that distance because the angle that it's measuring was like 3-something degrees. It's been a little while since I read it, but it's multiple degrees second.
You think it's 3 degrees?
Or the margin. I can't remember what exactly it is. So let's just say it's 1 degree.
Dude, there's supposedly only 3 degrees of drop in the horizon when you're in the stratosphere.
Okay, that's fine. I'm saying if it's measuring like a degree or a minute, and its margin of error is a second of angle, then it's within its margin of error. Are you saying that it's that 1 second margin of error actually grows to minutes or even full degrees when it's miles out? Is that your position?
Bro, I can't hear you anymore. I'm using power tools. I'm using power tools now, so someone else will have to answer that for you.
Okay. Was nice talking to you.
You're the one who brought up the Chicago skyline, 52 miles away, and 1,800 feet of curve is not there, and you never gave us a reason why.
Oh, I mean, there is curve there because you can clearly not see the bottom of the buildings. It's not an angular resolution issue because you can see the top of the building.
The building should be covered all building, not the bottom. All buildings should be covered.
Yeah, but what's if in that particular, in one of the most all of the photos, they're on top of dunes that are several hundred feet high, like 300-400 feet high. So there's no way that a wave is blocking stories of building. It's mathematically, it doesn't make any sense. The fact that any of it's blocked on a flat Earth, I'm unaware of any mechanism that explains that.
Oh, here, yeah. So you can use your refraction for that. I'll show you what it looks like since you don't understand. You've never seen it. You've never seen this happening before in your life. So, but
yeah, I'd love to see a demonstration.
That explains it. That explains it. See how that.
Brad, when I put it in the chat for you. Oh, you got it too.
Yeah, so
I'll be able to
that's
look at
happening.
it in a couple minutes.
In a couple of minutes, fine. That's happening when he snapshotted that one picture.
But you're saying you have a demonstration of a flat surface obstructing the line of sight between two taller points.
Yeah, look in the chat. I know you say you can't, but you need to.
I am driving, so this is very risky.
Well, then you should probably pull over because it's pretty important at this point.
The laser thing?
Both things, the skunk bay, the laser. I've got more.
Skunk Bay is good because all you do is blink your eyes and pick one of those spots, and that's what that is when you take a photograph of Chicago across the lake like that. That's a snapshot. And it could be any of those that you see in that time lapse happening to those buildings. It's still flat.
I'm not sure how this demonstrates that a flat, because both of these are talking about in-field measurements. Was anybody able to confirm that the floor of that surface where the laser is actually flat? And it's much better to not use a laser.
Dude, it's like you don't even understand. You were talking about earlier. With Indio upward refraction, which would be called looming, and it's like you're forgetting the opposite of that, which would be called sinking. Right, something that would normally be visible, right above the horizon, apparently sinks beneath it. It's like you forgot about the opposite effect when you have an inverted temperature gradient.
Yeah, I mean, I know that that's
demonstrating here.
That it's downward refraction, that it's upward refraction?
Well, it's not called upward refraction.
Yes, it is. The opposite of downward is upward.
It really isn't. No, it's literally not called that. It's called sinking or looming, which are versions of mirages, right? Inferior and superior mirages, but lesser versions
where the sky is reflected on the ground.
No, dude, right? That would be total internal reflection, which is one of the properties of an inferior or superior mirage, not looming or sinking. Okay, so you're forgetting about sinking. Like, you want me to read you out some citations? Okay.
No, not really.
Not really.
I mean, I understand the concept of downward refraction and upward refraction. You're saying there's a third type of refraction?
No, I didn't say that, right? They're all under the category of deviating light, right? Due to temperature, mostly due to temperature, right? Which will change the refractive index. It's like you haven't really researched this. Really. You haven't really researched this at all. Like, it's like you've listened to some MC Toon videos or something like that, and that's your whole understanding of what refraction is, and you completely butchered it, the entire conversation with Indio earlier, and you're doing it again now.
McFindler, how you distinguish the refracted surface from the real surface?
You'd measure the atmospheric conditions of the places.
Okay, if you see the real physical water, can you say, I see the physical water, or you will say that's maybe some atmospheric conditions?
I mean, you see the photons, right? So
no, I'm speaking about the ocean. If you see the ocean in a distance, you will say, I see the ocean, or you will say, I see some kind of phenomena happening that's not ocean.
If I'm standing on the beach and I can see the ocean, I'll say I see the ocean. I'm not understanding your question,
okay.
David.
We have observation. It's called black swan. You see the ocean behind the oil rigs. That means no refraction required. There is an ocean.
What? Refraction doesn't require an ocean.
Yeah, there is a physical water behind the oil rigs. That means ocean. There is no light doing anything. You see the surface of the earth.
What?
Anyway,
Like, I can see
anyway,
refraction without
the
water.
buildings that we were talking about in the first place, we see them. That's not an illusion. So how do you explain that? Because you said it doesn't make sense. So since it doesn't make sense, how do you explain it?
I mean, obviously, you went out and measured the atmospheric conditions because we all agree that refraction's a thing, right?
Yeah, it has nothing to do with the surface.
Yeah, so it
The
can make it look
refraction
like
has
they're
nothing
being.
to do
Hold
with
on a
what you
second, dude.
see.
One
When you
second.
see the when you
Hold on
see
a
the
second,
physical
Sasha. 1 second, dude.
Sorry.
1 second, sorry. Look, so it can make it look like things are sinking behind the horizon, right?
That's your claim, sure.
No, that's the claim by the mainstream. I'm just parroting the mainstream right now.
No, no. Not
Okay, so let's go. So Andrew Thomas Young, right? Optics of the Atmosphere, Reports in Progress in Physics. Okay, page 307 and 377. Atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. Right, I can give you citations and I could go on for days with citations because I got them all right here. So
Would you mind sending that to me?
Yeah, I'll pop some in the side chat.
Yeah, I appreciate it. So if I look up your citation and it says the Earth is a globe, would you agree with your citation anymore?
No, because what I was talking about here has nothing to do with a globe, right? This can happen on a small scale or a large scale, on a flat surface or on a bumpy surface. It doesn't really make a difference. It's the mechanism that's at play here. It's got nothing to do with a globe Earth.
Yeah, but if those conditions aren't found in typical atmospheric conditions on the Earth.
They are, though.
They are.
He just said that, and we have countless observations of this happening that actually fit the definition of sinking, which is a type of miraging effect that's common when you have a layer of warm air closer to the surface, and then it gets cooler as you go upward. Okay, the opposite of looming, which you call upward refraction, which is like newspeak or something like that, I'm guessing.
What?
But yeah.
Upward refraction makes things that are high up appear lower. Downward refraction makes things lower appear higher.
No, look, dude, I can post you the actual citations of what these things are really called from the American Meteorological Society. Okay, it's called sinking, looming, which are forms of inferior and superior mirages. Right? They're not called upward refraction or downward refraction. You're not going to be able to find me citations that say those words. Right? But that's kind of what's going on.
Let me ask you this, McMillan.
If I do find citations that say exactly that,
ask you,
would you agree
McMillan.
with me?
No, it's called a hostile witness. So let me ask you this, McFinlan. Do you understand what sinking is? It has nothing to do with things in the sky. It's things that are literally level with you, and they appear to be sunk into the ground or behind the curve.
What if they're slightly above or below you?
What if there's these are things we're looking at level to a flat surface? I don't understand what you don't understand about that.
Yeah, like if you're in a valley and you see sinking refraction, is that object going to appear higher than it actually is or lower than it actually is?
We're not looking in a valley.
Correct?
We're not looking in a valley.
Yeah, I know hypotheticals are hard. I'm just asking you to engage.
I know you want to stay in imaginary land. That's the whole point of this whole thing for you is we need to imagine everything, right? We can't go out and do a real world observation.
No, I'm saying imagine the consequences of the thing. Make sure that you understand it well, then go out in the real world and actually confirm whether your idea is correct.
We've done that, and this is mainstream. I'm just parroting mainstream stuff right now. So sinking obviously is when something appears to be sinking. Okay, and then looming would be the opposite of that, where it appears to be looming.
Yeah, upward and downward refraction. Yep.
Yeah, it's called sinking or looming, dude.
I mean, you can use whatever words you want. That's fine.
Yeah, but that's the actual terminology that's used in the mainstream.
But we have example where refraction does
I'm
not do
a
any.
scientist or something, so I don't particularly care.
But yeah, we have observation showing that a refraction, whatever light is doing, does not influence the surface in any case.
It affects how you see the surface.
That thing's what is real. Do you understand me? There is no phenomena. You see what it is.
Yeah, like I can see upward refraction where the sky is apparently
no, man. If you see the water in a distance, man. Simple question. If you see the ocean in a distance, can you say I see the ocean, or you're saying like this? I see something what is similar to ocean, but it looks because of the sun or the light. It looks that it's ocean.
I would typically say I see the ocean because that's a very silly way of talking.
Yeah, that means there is no refraction. You see the ocean, everything is fine. You have that observation, and you say, "I see the ocean."
That doesn't imply. We all agree that there is refraction, so I don't know why you would.
Man, but what if you see the surface of the earth? That means water in a distance. Why are you invoking any word?
Because we know that refraction happens. Like the video that you guys are posting literally show like the horizon moving up and down.
Okay, let's put it like this. You and me never was in the school. We don't know what that word means. We are on the beach, and I'm showing you on 10 miles. Look, there is the ocean. And you're saying, yeah, I see the ocean. Now, it's coming some person and saying, but you didn't account on refraction. And I say, for what?
Yeah, that would be silly.
Yeah.
Why would somebody say that when you're not trying to measure anything?
No, man. You are seeing the ocean, the water in a distance.
Yeah.
And
yeah, the
water,
purpose of you looking at the ocean is because you want to look at the ocean. You're not trying to measure anything.
Yeah, but look at the devil.
Refraction's only helpful when you're measuring stuff.
Yeah, but you have some marked distances. Like in this case, oil rigs for the Black Swan. That means the platforms are in the water, and behind them you see that water. What is real?
I mean, clearly, you should play the Invincible Ignorance song.
Man, there is a real water. There is no light doing anything. You see that what you see, that what is real. That is surface.
Well, I mean, you see photons, and photons are real.
No, man, you see the ocean, the platform. Man, the platforms are taking the oil from the sea behind 10 meters behind that platform. It's an ocean, and you see that.
It's like if you had a blue ball in front of you, and I feel like what you're doing is saying you see the ball. I'm saying yeah, but you also see blue, and you're saying no, I just see a ball. It's like. You can see both things simultaneously. One doesn't preclude the other.
In this case,
you can see the observable effects of refraction and the ocean.
Because of that, I'm asking you: is that water real water, physical water, or that is something light is doing that you only perceiving it like a water?
I mean, technically, you're only seeing photons, but the photons accurately represent water, just not their position.
Hey, Sasha,
Jesus Christ. Okay, I'm done.
So back to your whole theodolite thing, right? You're on a hill, you're doing a theodolite measurement, you look out over the hill, you've leveled your theodolite, you're looking out over the hill, you're doing this Jesse path of light observation, and the hill that's across from you that should be level with you or higher to you, it appears lower to you. Yeah,
sure.
That's sinking. That's downward or upward refraction. That the path of light deflects upward, sinking the thing off into the distance downward. Yeah, let's go with that.
Sure. Do you know how common that kind of refraction is?
Very common
on the in fairly stable conditions at high altitude.
All you need is a temperature inversion. It happens all the time in valleys.
/ pressure inversion, but you're saying on top of a mountain.
It happens all the time in valleys.
They're pretty normally pretty well moderated in temperature. They're not because they're not getting a ton of direct
you should look
sunlight.
at the temperature inversion.
Yeah, I know what you can see it on a like hot day when the surface of the pavement is miraging the sun or miraging the sky on the ground.
Most descriptions of temperature inversion happens in between mountains.
Between mountains, not high up
between
on
mountains.
The there's not a lot of
right. There's valleys, and what happens is cold air gets trapped under warm air in valleys, and you get your temperature inversions. It creates a lensing effect.
Well, if it's down in the valley, how's that cold air gonna get up to the path of the light reflecting from the mountain that's opposite you?
It doesn't have to be deep down in the valley, bro. It could be sitting right at like up to the high level of the valley, like kind of like how water sits over the top of a cup and bulges a little bit. Your temperature inversion can do the same thing, bro.
Well,
Look up temperature inversion. You know nothing about this, and you're arguing against it.
No, I'm saying I do know about this. That like if you're on mountain peaks, generally they're a lot higher than the valleys or even the ridge lines between them. So like I don't know why you would think that the temperature differential in a valley would hold up all the way up to the peak and actually interrupt the line of sight between you and that other valley. It's generally like those are pretty good conditions for sighting between long distances because there is a large pressure and temperature differential between the two locations.
Right, but that's what happens, right?
That there's a large temperature and pressure differential between the two locations?
Yeah.
No. It's normally not a large pressure and temperature differential between the two locations because there's active airflow at such high altitudes.
Did you measure the airflow between the two mountains? Yeah.
People have done. Yeah.
Did you?
Did I? Do I have to do everything personally?
Well, I mean, if you're making that observation, right, you're the one making the claim that all these things are going on, and then like you hold us to that kind of scrutiny, right? You sit there and say,
I don't
you need to measure every inch of air from between you and the object 10 miles away. We need to know the temperature variance all the way across.
No, I'm saying if you want to disprove the idea, then you'd have to do the same rigorous testing that people who have proved it.
They didn't prove it, bro. They didn't do the measurements. They're not accounting for everything.
Well, you say they don't, but when we do these and we make predictions, those predictions come true.
I mean, all it takes is a little bit of refraction, bro. You're asking for a lot of refraction. You're asking all it takes is like a small angle, like 1.33 degrees, and that angle over a large distance will push things off in the distance further down.
I mean, I agree that things further in the distance are angled further down, but I don't see how you could instantiate that happens consistently between mountain peaks or high altitude observations.
I'm not saying it happens consistently. I'm saying that temperature inversions happen most frequently in between mountains, down in valleys. In between those mountains. In between hills,
but if the valleys, but if the valley is like well below the mountain peak, because the valley is between the ridge lines,
right?
Not between the peaks of the mountain.
Did you account for temperature?
Yeah, they do.
Did the person? Okay, show me the video where they account for temperature inversions in between two mountains.
Well, I'm driving. I can't actually send you anything right now. But are you saying that if they did do this, because I will provide this to you if this would actually change your mind, if they did do this, they measured the areas between. Oh, so the evidence doesn't matter to you.
First you have an invincible ignorance issue where no matter what evidence is presented to you, there's got to be some globe explanation for it. We can demonstrate flat Earth refraction, right? We can demonstrate how temperature inversions give the illusion of things disappearing behind the curve, even though it's on a flat surface. You don't have anything demonstrating things popping up behind a curve using refraction, except a magnifying glass, which is something we don't observe. We don't have a giant magnifying glass out in nature, but we can use heat and temperature and pressure and create those temperature inversions and create those sinking effects that DJ was talking about.
Sure. Would you agree that the majority of the time this is not the case, that it's more common to see downward refraction than upward refraction?
Are you saying that all this refracted, which refracted observation showing the curved surface?
You're begging the question on downward refraction.
Well, yeah, I'm not sure I understand the question. All observations have some degree of refraction, whether it's
holy crap.
And it's showing all the time the flat surface.
Hey, Sasha, hold on a second. Hey, friends. If you guys aren't going to let him answer Sasha's question, if he asks a question, there's a question on the table, then how about I just ban Sasha, and that way we don't have to listen to him. Okay, Sasha asked a question to the guest. Hold on, friend. Sasha asked a question to the guest. It's his turn to answer the question that Sasha asked. Sasha, ask your question again.
Yeah, in which case, because you're saying everything is refracted, in which case it's showing refracted surface that it's curved?
In which case does it show? Like, you can see the Chicago skyline. That's a really good one.
That flat horizon without obstructing 1,800 feet showing the curved surface.
No, it shows that the surface is curved because in that photo, it's downward refraction, but for some reason, the water is actually blocking the skyline, the bottom portion of the skyline.
That's ridiculous because I posted that like a flat earth proof, not like a globe earth proof.
I mean, data's data. It's not one sides or the others. And I think it demonstrates my point very well.
The data it's showing there is no 1,800 foot of the drop. That's data showing. And you can see the flat, and you are saying there is refraction, and you see flat horizon. That means how you come to the conclusion that refracted flat horizon with that data, it's curved.
So you'd have to measure the left to right curvature, because I don't know how much like linear feet that surface is showing, because if you're talking about it's 60 miles across, that's definitely not, then you would see 1 degree, not even 1 degree of deflection on that surface. So you're saying it's flat, but you'd have to measure and see what it would actually have to be.
Do you know what is 1 degree on the sphere?
69 miles.
Yeah. Do you know what's that? That's 8 inches per mile squared.
Okay.
The only thing what you said, it's 1 degree. I can agree with that, but that is 8 inches per mile squared. That is 1,800 feet on that observation for the Chicago skylines missing of the drop, and plus you have the flat horizon from the left to the right.
I already showed you why. I showed you a picture of Skunk Bay. Say, all that picture was one snapshot of that. If you look at the Skunk Bay time lapse and you took a snapshot of that, you'll get one funky picture too. So that picture of Chicago, you don't see the bottom because it was taken at that time of day. That's why. It's all there.
Because of the time, so you're saying that there are pictures of the Chicago skyline where you can actually see the bottoms of the buildings?
I'm sure there's clearer pictures than that, yeah.
Not only that, we have a guy on the boat going from another to another part, from the one part of the lake to another part of the lake, recording everything with the video.
He just goes across the lake, one side to the other. You see it in view the whole time. When does it refract up? When he's driving from one side of the lake to the other, just like the picture, and you can still see the city. When does it start floating in the sky?
Is that a question to me?
Yes.
I don't think that it would ever start floating in the sky. You would start to slowly see more and more of the buildings. The object would stop being obscured from top down. You'd see more of the top and more of the top until you can actually see the bottom. I don't think it would ever float.
That would happen if you didn't have the in observation the Chicago at all, and then in one moment, oh, I see the top of the building, oh, I see the middle of the building. Oh, that's never happened, man. Because you don't need to see anything of that Chicago, Then you start to see from some distance. You approach on 20 miles, and then you start to see.
I'm not sure I understand what you're saying. Like, you can clearly see part of the Chicago skyline from 52 miles away, but you can't see the bottom.
Man, do you know what is okay? Do you know what is?
Well, let me finish.
Man, you are speaking something. There is no bottom of the.
I got like
skyline.
I got like less than a sentence. I've been pretty polite about not interrupting you guys. Can I finish? Thank you. So you're looking at an observation that's 52 miles away. It's pretty late in the day. It's overcast, so you can tell that it's almost certainly downward refraction because the pressure differential goes high at a low elevation and it gets lower as you go up in elevation. So that would cause downward refraction. Distant objects appearing slightly higher, not where some object in the middle is actually appearing higher than the object.
Starting to float in the air like an imaginary object then.
No, that's not what I'm saying. I'm saying the refractive conditions are downward. So the distant object would appear slightly higher. It's not that there would be a gap in your vision between what you're seeing. So if it was a flat Earth, you'd be able to see all the way up to the shoreline. You could see the docks. There would be no obstruction between you and the dock. On a globe Earth, it makes sense because
man, that's not correct. What
you're able to see. All right, explain to me how the flat water, when you're 300 feet in elevation, is blocking you being able to see the bottom of those buildings. I'd really appreciate it.
Okay, distance is
300 feet high.
Let's put the distance 5,000 miles.
Oh my God.
5,000.
Oh my God! What? You said you are 300 feet, and I said, okay, 5,000 miles distance. Can you see the bottom of the object?
Is this you explaining how the water gets between you and the distant object that you're viewing?
Do you know what is angular resolution?
Yes, I know what angular resolution is, and you can clearly see the buildings on the opposite side, so it's not an issue about angular resolution.
Does angular resolution occur in reality?
Yeah, of course.
How?
You're talking about like Rayleigh criterion, right?
Yeah, how what's happening when that happened?
Yeah, things become kind of blurred and merged together. So if you have a window frame in a building and it's white and the wall is red, it's a brick building, then eventually that's going to become just a white blur in the distance, and eventually it'll even merge with the building where you can't even distinguish the window itself from the building, where that's clearly not happening because you can see the windows of the buildings that you're observing across the bay.
Okay, let's put it like this. You're on the flat highway, okay? And you put the brick on the highway, and you walk away 10 miles away from the highway. That brick you don't see because of the curvature or because of angular resolution you don't see?
You're saying on a flat Earth, if the conditions are calm, then you would be able to see the brick.
No, you will not ever see the brick from the 5 miles. Are you crazy?
Are you saying with a sufficiently powerful magnifying, like a telescope or something, you wouldn't be able to see the brick?
No.
What are you saying then?
That your angle of view will be small, that you will not resolve that. It depends on your height, of course. If you raise the height, you will see the brick.
Why would raising your height change angular resolution?
Because your angle of view will be larger.
What if it's a ball? Then the angle wouldn't change anything.
If it's a ball, there will be drop over distance in reality.
Wait a second. Now he's saying there's an angle if you use a ball. So you're saying if I set a basketball on a table, there's an angle between the ball and the table, right?
If you put a ball on the table, you can measure the angular size of that ball. Yes.
Can we do that with the air? Can we do that with the air? To the same thing.
Can I do that to the air? Measure the angular size of the air?
No, you use the one spherical things that the basketball because it's small. Can we do that with the earth?
Oh, with the earth. Like you're saying, figure out what the angular size of the earth is supposed to be?
But it's easy to take something spherical and to make an example. That I know that's a good example. But if sphere is so big, how we will make that example?
Right. Yeah, you're asking how would you predict the angular size of the earth? Am I understanding your question correctly?
No, I'm asking you that example. What are you using for the basketball? Can you use the same example for the earth? You cannot, of course, because you cannot put the earth on some flat surface. Is that correct?
Well, I mean, you could, if the ball was like hypothetically floating in midair somehow, like with a giant fan that's just blowing it up, you could still measure the angular size of it. I'm struggling to understand.
Ball, yes, of course, of the small ball, basketball, you can do that. Like the same thing. Yeah. Can you measure the drop over distance on the basketball?
Drop over distance on a bat? I don't understand what that question means.
Rate of change of slope. Drop over distance is another way to say a rate of change of slope. So can you measure curvature over a sphere, he's asking.
I mean, yeah, of course you can measure a curvature over a sphere.
Okay, can we measure that? Okay, can we put now the temperature around the basketball, the many lights around the candles, even more temperature, around. Does that will change the surface of that geometrical basketball?
Yeah, you could induce a very big difference in pressure and temperature around the ball, which would affect the path of light that gets to your receiver or your eyeball or whatever. I think we all agree on that.
Mm-hmm. And that will show you the flat surface when you do that.
Why would that? I mean, if you zoomed in enough on like the very edge of the ball, it would look flat, but I'm not certain what your point is.
But not like a 1000% off. You will get like a 10 centimeters on the basketball flat.
I mean, it would be a really small section. Like if you took a picture of a ball and you just zoomed in and zoomed in and zoomed in, at the very edge, it would look flat.
Like a small section on the earth, like a 10 miles on the earth.
Yeah. Are you asking like what would that be equivalent on a basketball? Because you're talking about 1/60th or 1/6 of a degree of the basketball, and if the basketball is like a foot in diameter, or you're talking about a couple millimeters, not even. But then at that point, like the topography of the basketball undulates more than what you're trying to predict because it's got those little divots in it.
And 10 miles on the earth is that small section for the earth?
I mean, if the circumference of the earth of 40,000 kilometers is correct, yes, it's a very small section.
Can you have a 10 mile, 16 kilometers? Can you have 16 kilometers of the flatness on that sphere with the 40,000 kilometers?
I mean, it will diverge somewhat from point A to point B, and you can measure that divergence.
Yeah, I'm asking you this. Can you have flatness of 16 kilometers on that sphere with the 40,000 kilometers?
I mean, it depends on how accurately you're measuring it. Like, if you just go out and nakedly eyeball it, it'll look pretty flat. But if you actually measure it, no.
If you measure no change, if you measure no change of slope in 16 kilometers.
Like, if you measure between point A and point B, and those two are 16 kilometers apart, you can measure the difference between their zenith angles. But there's a difference between those zenith angles.
Now you cannot measure anymore that change of the slope.
You're saying that you want me to prove reciprocal zenith angles do measure a difference?
Yes.
How you can measure the change of the slope in reality?
Reciprocal zenith angles. Yeah. Okay. So do you guys want me to provide you with reciprocal zenith angles?
Yep.
In reality?
Yeah. Of course, in reality, surveyors do them all the time.
Okay, that will
Are
be
there
like
any
this.
caveats to what I need to provide?
It will be like this. This is the valley. Let's say this is USA. This is the location. This is the distance, and this is the change of the slope.
And make sure the distance isn't over 1,000 meters.
Why does that matter?
Because theodolites won't work after that. They're inaccurate. And they're not even accurate to that. They're not even really accurate really well for that distance.
They measure angles, not distances.
So you don't know how they work, I guess. I just posted a picture of Skunk Bay when it's all wavy around because of the heat during the day. And if you look through a theodolite and you just say, "Go, there's the angle," what part of Skunk Bay is it taking any angle from? What time of day and where should that be? And what happens if you do it later on in the day and it's in a different location? Did the reciprocal angles change then? Did the Earth wobble?
Sorry, you mind saying that again? I'm trying to look up this information you're requesting.
Which information?
For reciprocal zenith angles.
Yeah, no, I'm not going to say it again.
Fair enough.
How we will measure? What you will measure angles? What you using for measuring angles? Sky and the sky, theodolite, and for the measuring the angles. Are you in the room? Are you outside? Where are you? Are you measuring angle of the swimming pool?
Sasha, he said before you can't get an angle from the surface of a ball, so he's not putting it on the Earth because that's a ball.
And where did you put where did you put theodolite? You put in the room theodolite? Where is that?
No, these are in-field measurements.
Where is theodolite? Outside?
Yeah, of course.
And it's using what for measuring angles? The buses, the trees?
No, one of them's from measuring over a lake. So he measured at a lake. A guy named Jesse Kozlowski measured over a lake.
Using what? The surface of the lake with what? For making angle?
A theodolite. Theodolites measure angles.
What time of day and what was the
angle of
temperature?
what, man? Jesus Christ.
The angle
of what? Day, what was the temperature?
Yeah, all that's in here. 1 second.
And what was the temperature 50 feet in front of him?
Yeah, he measured all that.
And then 100 feet in front of him?
I don't think he did that many.
How did he get all those temperature readings?
How many temperature readings do you think is necessary to have an accurate margin of error?
Do you think temperature fluctuates over a surface of water in the air?
I think it depends on the conditions in field. So if it's an overcast day, it won't vary very much at all.
Oh, so if it's overcast, nothing's going on?
No, I said it won't vary much.
So when it's overcast and Lake
the margin of error is tighter.
It's got 4-foot rolling waves banging up against the shore, and on a sunny, calm day, when it's all hot and like 100 degrees and it's just flat. So you're saying on an overcast day, it's calmer than it is on just a regular day?
Atmospherically, yes.
Gotcha.
Yeah, like, do you disagree with this?
Yeah.
Okay. So why would you think that?
Because when it's windy out and it's gray and cold over Lake Erie and the waves are just blowing the shit up on the shore, and then it's sunny on the next day and there's no wind and it's calm, I think, yeah, that makes a difference.
Why do you think that's going to affect optics more in situation A than situation B? Do you think light is affected by storms?
Because you're going to have more moisture in the air.
If it's cold, you'd probably have less moisture in the air.
No, dude, it depends because your water's always evaporating. So how fast is it evaporating is how much you're going to see that little wavy part. So
yeah,
that's what you're seeing happening, and that's continuously always happening. So how many measurements did he make from one location? Did he do it over 1 month, 6 months, and then each location he needed to do what? I would say 24 months or 36 months, and then you should get a good average, don't you think?
I mean, the guy's a surveyor, so he knows his business.
No, that's not being a surveyor. He should know you can't shoot that distance. I already talked to him, and he knows I'm right. Yes, I've talked to him. Yeah, go back to the live streams from this chat where I talked to him and told him, "Nuh-uh, see Skunk Bay?
Yeah.
What time of day were you taking the picture, and what did it look like?" And that was the end of his conversation. He gave up.
Yeah, because I mean, you're saying there's no.
Didn't he end up leaving the community altogether?
I actually.
Oh, you mean actual evidence? You mean the standard of actually having him provide his evidence? Is this too ridiculous? So yeah, you can trust theodolites because they're relying on an optical path from the target to the theodolite. That's your claim. But if I show you a laser debunking the geometry of the globe Earth, all of a sudden you'll say, "Oh, I can't trust the path of the light." It's funny how that works.
Isn't that double speaking?
Sasha, almost had to ban you there.
Sorry.
No.
I didn't say N-word. Oh, Jesus.
But then you went on to commit the same faux pas, Sasha. So if somebody asks a question, that's not your cue to immediately ask another question, right?
So
that means there's two questions on the table, and then it's like, which one are we going to get answered? You know what I'm saying?
Careful, Miles.
And likewise, if you ask a question, somebody comes in with just talking about a different point rather than allowing the guest who the question was asked to answer, that's also a faux pas. Right?
No.
The reason is we want questions answered, at least in some respect. Not just to, be over-talked and then we forget that there was a question on the table. The reason why, Sasha, is because if you just keep chiming in asking questions, so imagine that, right, which you do sometimes, and then nobody answers it. The flat earther who's speaking doesn't address the question. The globe earther who's speaking doesn't address the question. So it looks like maybe you have everyone everyone muted and you can't hear them, and so you're just talking through them. Or it makes it look like the flat earthers have you muted so they can't hear you because they don't want you to be around. So then the most rational thing is if nobody wants to actually answer your questions, then you shouldn't even be allowed to speak because they're just distracting everyone, which is why sometimes we just got to notice there's a question and be like, hey, there's a question. That question's got to be answered.
Waiting for.
But listen, I heard that Jesse Kozlowski boot scooted out of the community. Did I hear wrong? Like something happened. Either he was in a debate or presented some case, or he was presented a case, and then after that, he never was around anymore and didn't produce any new content or something. That's what I heard, but I didn't validate it.
How long ago? Estimated time? Because I saw him on where the heck was it? Land of Misfit Toys like 3 months ago. I think I left the server 2 months ago. So
yeah, it was somebody told me recently. It was Bev that actually told me. He said his prediction was Will Duffy is going to do this like last drop of this big fighters debate or whatever it was, and then after that he'll disappear, just like Kozlowski did after such and such event. I can't remember the event he said.
My combo was Jesse Path of Lies because I called him that and he knew it, and that was his name.
Bro, that's not the same dude. Kozlowski and Pathov are two different dudes.
And I was talking to Jesse Path of Lies.
Okay.
Path of Light. But I call him Path of Lies, and I say that to him every time I see him.
Dude, I've actually been making a good side hustle. I buy short range theodolites, and then I sell them to people for long range. I just change the sticker.
Man, stop scamming Globers.
Damn it, was that you?
So that dude took off,
no.
huh?
He bailed.
They love being scammed, Neil. You could have given them what they want.
Out.
Hey, just don't forget to
I'm
pay
out
your
without a doubt.
Don't forget to pay who?
Don't forget taxes, or you're not American apparently.
Yeah, I caught a little bit of that conversation. Are you talking about the guy that you were talking to that said the looming refraction and all that stuff? That guy? Or was there another guy? Or was there a girl?
Yeah, it was like hours.
What was like the final? Did you just instant transmission out of here? Or was there like a final message?
Basically, he kept on giving up and spazzing, and yeah, he didn't get anywhere on any fronts of like any of his conversation topics.
I did find it funny when he was like, I know you guys don't understand hypotheticals. Okay. All right, brother.
He was like begging. He's like, well, why can't we just use a hypothetical?
Because I was a Glober and I did all the hypotheticals, and he didn't like that.
Honestly, I missed a lot of it, so I don't know. Can't really comment too much, but it seemed like he wanted to be in a valley. It's like, well, if we're in a valley, like, what are you doing in valleys, dude? How are you proving anything from a valley? Or what are you doing up there? Down there.
He's a valley girl?
Yeah, I think you were talking to him, P-Dog. You're like, dude, valley, that's, I don't know, whatever.
Yeah, when you look up temperature inversions, that's the most common example that they give you is like in between two mountains. Cold air gets trapped under warm air, and that's when you get sinking effects.
And he was trying to prove curvature with that. How?
I have no idea.
Okay.
He was just looking for like a concession, right? Like he wanted, like, because we were using hostile witnesses, he was like, well, if I can get them saying it's a globe, where you concede it's a globe, it's like, bro.
Oh my god, that's so stupid. I heard you chime in. He was like, so like, then you believe it's a globe? Then you're like, it's called a hostile witness, bro. I don't know how that doesn't click for a lot of people. Well, if you're using their citation that says this, then you have to believe everything they say. It's like, no, dude, I'm using the citation to go against your dumbass who seems to think otherwise.
It's like if the criminal like slips up and tells a little piece of the operation that the criminal organization is going through. Like, there's your hostile witness, bro.
Anybody else? Anybody next? I'm not on my computer, but someone should copy and paste the event link in the lobby. I'm going to take a page out of my book. All right. Well, anybody want to report on the dumbest thing you've heard a Glober say this week? Go ahead. Only Thursday. We got a couple more days for them to think something stupid.
Chat.
Can you robot him? Am I roboting?
No, you're not.
Oh, okay.
Yeah. Yes.
AI drop at rejoin.
Sorry about that. Kind of phone call.
Bradwin, what's the dumbest thing you've heard a Glober say this week?
Actually, it was just like probably about an hour ago. Piper Australis was saying that he was banned from 24/7 for continuously asking for a flat Earth map.
Oh, Lord.
And then said that I told him in a back chat, which I asked him to produce evidence of, which he doesn't have evidence of, that I said that we don't talk about things that are easily disproven in 24/7. Not making it up.
If this Globers want a flat Earth map, are they going to fund it? Because it costs millions of dollars to make a good quality map.
I just use Google Maps.
I just use Google Maps too.
I always post a sky map of all the stars in the sky. That's my flat Earth map.
Yeah, but Google Maps works just fine.
Yeah, it gets me from point A to point B, no problem. Yeah, I like Google Maps. Sometimes I use Waze. Definitely not Apple Maps.
Sometimes. Apple Maps aren't. I use that too, especially.
Yeah.
It's if I'm driving, and I just have it on my dashboard that way. It's a lot easier because I'm usually listening to my phone then.
Nice. Yeah, if a shorty drops me her address, it automatically uses Apple Maps, so that's like the only time I use it. I'm driving to the shorty's place. But, otherwise.
So what are you saying? Your girlfriend's a midget?
What? No.
Boyfriend?
No.
Oh.
They're called little people.
You guys got to listen to that T-Pain song, Shoddy.
Oh, I know what it is. They're like 7.5 foot tall friend of yours.
Hey, man, that's a boss move right there to go out with a tall one. That's a boss player move right there. Anyway. Yeah, the maps thing, it's so annoying, though. And they're like, where's your map? Where's your map? Like, bro, dude. How many maps you want? We whip out that picture that's like, I got 75 maps on it. Like, which one do you want, dude? Here's a bunch of maps.
Why is the guy crying in text that he can't use emojis and he's not even in the live stream?
I'll get him in here. I'll fix it for him. Tell him CB will fix it. Where's your flat map? They actually think you can just go up in the sky and take a picture of the ground and then trace lines around the country and say, that's the map. That's not how it works. They have such the sloppiest, dumbest ideas of what they think flat Earth should be. It's so annoying. That's why I'm always using their own worldview as like a mirror. Because in their worldview, it's not possible to see the whole Earth in one shot. Even if it is a globe, right? You can't see the whole thing That's like saying I can see your whole head by looking at your face from no distance. Will you be able to do that? So, okay, so in their worldview, you can't see the whole earth in one shot. But for some reason, they think that we should be able to do that. Well, why not? Just go up. No, it doesn't work like that.
And spheres are the worst objects to see at a distance.
Oh, yeah, because it can look like a circle or something?
No, that's like a mirror ball, right? You get the hot spot in the middle, and everything else reflects off to the sides, not back to the observer.
Got it.
Like those people who say, "How come I can't see the Bahamas from Florida?" I said, "Are the Bahamas covered in green plants?" And they go, "Yes." Well, guess what? Plants are good at absorbing light waves and very poor at reflecting them.
There you go.
How big should the Bahamas look anyway? What's the height that they should be on the horizon?
I don't believe Bahamas have a very high elevation overall.
So then the answer is you won't see them.
That was easy.
The average elevation's only 5 to 10 meters, 16 to 33 feet above sea level.
Wait, 33?
Yeah. The highest point is 63 meters or 207 feet.
I still think somebody needs to go out there. I'm working on it. I want to go back to Key West, and it's only 90 miles to Cuba, man. Like that would be a great flat Earth observation.
Well, when I was in Cuba, I didn't see Key West.
No, I know, but I remember at night looking off in the direction of Cuba, and I could see like a bubble of lights, cities.
I can highlight another double standard that they have. They expect our reality, I guess everyone's reality, to have a edge, like an edge. But in their worldview, it doesn't matter if there's an edge, right? Like they don't even care about any edge. Right. There's a lot of ways to slice this up too, because they will say anything that's flat has to have an edge. Then you go, okay, well, NASA and all your scientists say the universe is flat, so where's the edge? Well, I don't know.
His sister don't have an edge.
But they won't let it go. I mean, I think that Ricardo, whatever, dude, I guess there was a day he just would not let it go. Where's the edge? Where's the edge? Where's the edge? Like answered 100 times. Nope. I need to know where the edge is. Like, dude, I would try to ask him, okay, so if you're so hung up on there being an edge, where's the edge of the universe? Where's the edge of that reality? Oh, well, we don't know. We're not able to know that.
Yeah, where's the edge of the solar system?
Yeah. Like, how come that doesn't apply? Like, having the ability to say, we don't know, it's not been explored, we have no idea, not really a concern of ours. How come that's not an answer you'll accept when the flat earthers say it? So I always use the universe as the example when it comes to this edge problem, because they don't know. I mean, for multiple reasons, it's not even been fully explored, quote unquote, even if it was real. We don't know where the boundaries of reality are.
I always ask them how things are supposed to look from that distance. When they say, how come I can't see Mount Everest? I say, how high is it supposed to look? I'm going to go outside and look for it. And that's the end of it, usually.
Well, it's even better when they're like, well, you shouldn't be able to see it. It's like, okay, great. Then why are you asking?
And it can't even see sunlight at 200 meters depth in the ocean. And they think you're going to see something that's thousands of miles away.
Yeah. Well, if it was flat, blah, 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 blah. That's like, I can automatically just mute. I might as well just like locally mute them on my end when they start saying, as soon as they say, if the earth is flat, I know almost for a fact, I can almost guarantee the words that will follow will automatically be incorrect. It's like extremely rare for them to start a sentence like that and then have something follow that's accurate. If the earth is flat, the sun would do this.
That's how you need to explain transmission factor.
Well, for the hypothetical, right, where they're like, well, if you imagine, oh my God, we got to imagine, man. We can't talk about reality.
If the earth was flat, you'd be able to see the Bahamas from blah, blah, blah. If it was flat, the sun would just disappear. If it was flat, you'd be able to have a map. Like, dude, they never know. I don't know what they're talking about.
Have you seen the video where you can see like Hawaii from like 2,500 miles away?
Well, that's got to be refraction, though.
It's a high altitude, but like there's absolutely zero curvature on the Z-axis.
I don't know. Ever since I heard them just parrot that this is the best assumptions we can make for the specific model, and those assumptions, predictions, like, are the assumptions, it's like their logic is just backwards from the very beginning. And I don't know how that's not like a glaring blunder in their world. Like, everyone agrees with that. Yeah, we just make assumptions, and then we come up to our best logical conclusions that it's a globe. It's like, that's how you live your life, off of assumptions? Like, yeah, that's what the penny dropped for me.
Yeah.
Check this observation in the chat.
I sometimes wonder if they really mean that, though. I don't know if they're just saying that because damn well they actually think that it's a globe and that cannot be refuted and all that stuff. So they'll say it's a guess and all this stuff to try to sound intellectual, but then deep down they're not really wavering on that. They cannot be presented with any evidence that would sway them in another direction. Like Matthew, for example, he'll say it. He's not going to change.
Yeah, exactly. You just got to be honest with yourself. At least, Matthew is an honest person to a certain degree, where he agrees. He's like, yeah, it's just a bunch of assumptions, but like that's the position I'm taking, and you can't really change my mind. And honestly, I like that, man. If you're gonna believe in something or go for something, just say that. Like, just say it out loud. Don't freaking try and fight. These other guys, they have a major problem saying that. And that just leads to a whole lot of cog deaths.
I need to re-add the sound. There's a sound clip from Sonny in Philadelphia where he's like, "I'm dug in, and I'll never change." I need to put that back on the board. That's a great clip. Genuinely, we're not alike. Like globetrotters and flat earthers, we are so far apart. I don't think you guys are really that dedicated to the idea of a flat earth. Like if we were able to validate a globe, I don't think anybody would truly have an issue with that. Like whatever reality is, that's what it is, and that's what I'm gonna go with. And I think a lot of you guys would probably agree with that. I don't think that's true for these other guys in here. The GTs, as JE would say, they're super dug in on this idea. They're not going anywhere. And
I was gonna say, you know what they would do. You ever see those videos of the slingshot where they go on the ride and the people pass out?
Yeah.
That's what these globetards would do if they went up really, really high and just found out the whole Earth was flat. They'd fucking pass out. They just blank out, bro.
That's funny. Well, I think what I'm gonna start doing is maybe asking, okay, let's do some role reversals. Let's say the whole world, everyone, all the scientists, everything are pointing towards the Earth being flat. And you have discovered that it's actually a globe. Like, let's say in reality it is a globe, but everyone's saying it's flat. And you do measurements and tests, and you can validate the Earth is actually curving. What do you do then? Oh well, I would just like go against mainstream, and I would be the globe earther in the face of all the letters. Okay, great. Welcome to the life of a flat earther in 2025. The whole world is saying, "Oh, we validated that it's not. It's flat." So you can't then appeal to big entities and scientists, big brains that are telling you otherwise. You actually have to appeal to what the Earth is. I'm going to try that out on the next couple globetards that come in here. See what they say. Because like Matthew Learns, for example, he'll say, "Oh no, even if they said it was flat, I wouldn't believe them." Right? Doesn't he say that? I'm pretty sure he says that.
Add to that, CV, the same claims that I saw 4 to 5 years ago when I first started looking into this are the same ones being presented today. There hasn't been any new development on their end. And these people are said to be at the forefront of this discussion. These people have been in the game probably a lot longer than me, most of them. And they've got nothing new to add.
Yeah, the pictures are so fun. It is, yeah. And that's enough. I think we should really just start practicing opposite day. It's something I've always really enjoyed is just flipping things upside down and seeing if they still make sense. Like, okay, here's an example. They have some ancient figure from thousands and thousands of years ago. Don't even know if he truly existed. But when you ask who measured the Earth, it's this guy. So we flip it upside down. Hey, flat earthers, how do you know the Earth is flat? Well, we have this guy from thousands and thousands of years ago. Well, we don't really have much record of him, but he proved it. You think anybody accept that? You think that idea would be mocked or laughed at? I do. What else? Oh, well, what did that guy do? Well, to know that it's flat, he put some sticks in the ground. Like, okay, really?
Have you seen the accolades that are attached to his name?
Nah.
He was smarter than Plato, Aristotle, and Socrates combined.
Oh, really?
He was a librarian, mathematician, geologist. Like he had like 12 different titles ascribed to his name.
And then they depict his cranium as like the size of a watermelon to hold that big brain.
Yeah, that's funny. I just don't think that they would accept that. We should genuinely pick a day, like one day a week, maybe, and do opposite day. And just like, yeah, we have a guy thousands of years ago. He proved it. What do you do? Oh, put some sticks in the ground. He seemed to.
I gotta practice my spazzing. Hold on.
Well, I'm trying to think of what else.
Hey, everybody knows that ships go into the horizon. They don't go over it. Come on.
What about Wednesdays?
Yeah, well, planets are round. Planets are spherical, so the Earth must be.
I'm trying to think of some other good examples, actually.
You can't have clouds on a flat Earth.
Oh yeah, you could do that stuff, that type of stuff. Like, oh yeah, that wouldn't work on a globe. To start making stuff because they don't say anything. Oh yeah, boats, sunsets, that wouldn't work on a flat Earth. Just start saying random stuff like that. Oh, yeah.
Yeah. Do you even know you have feet?
Yeah, exactly. Yeah. Oh yeah. You can't know for sure. You can't know for sure that you have feet, dude.
Like, it would be honestly fun just to like obfuscate, spaz out, and redirect. I could probably go forever. I would, I wouldn't run out of breath.
I've been working on it. I've literally been working on my Glover. So it's basically just giving them a taste of their own medicine and see if they accept it. And I almost guarantee you they would not accept it. And then this highlights the double standards, which I have an issue with. I'm like, I always call out the double standards, bro. You have to have an edge, but we don't. You have to have a model, but we don't.
Oh, you know how you see planes and drones and everything deviating in the inertial reference frame because of Earth's rotation? Well, that's how it will work on a flat stationary. That's how it will work on a flat stationary Earth. Yeah, it work the same. See, because we see Coriolis, that means there isn't any. Yeah.
Your best evidence for a flat Earth is by how much it looks so curved.
Yeah, it looks curved because it's flat, guys.
Oh yeah, we could do that with the horizon. Like, you see that, like the boats disappear thing. Yeah, I know it seems like curvature, but that means it's not. Or like, dude. We'll have to work on our opposite day, but I think we should definitely do that at least once a month. Call it like dose of your own medicine Mondays.
Or just go, oh, there's tons of evidence for Earth being flat. Oh, just buckets, millions of observations and
I already know where you're going with this. Yeah,
can I have one? One what?
Nah. exactly. Like, nah. I don't feel like it.
No, you do it.
You wouldn't accept it anyway.
Can you define accept?
That happened yesterday with what's his face. Man, what's the guy's name? guess it's that irrelevant. I don't remember. And he's like, "Oh yeah, I have evidence, but you just wouldn't accept it." And I'm like, "Dude, I'm trying to explain to him was it Charlie? Yeah, it was Charlie. I'm trying to explain to him the courtroom analogy, and damn, I should have recorded this clip. But you're not there when you're in the courtroom. It doesn't matter what the lawyer that you're opposing thinks. Your Honor, I would present my evidence, but this lawyer over here, he just wouldn't accept it. Okay, it's not his job to accept your evidence. You're supposed to present your evidence to the judge and the jury. No, I have it, but you wouldn't accept it. That doesn't work like that. You need to present your evidence with whatever you have and let the people decide. Whether I accept it or not isn't going to change anything. Absolutely cooked him on that point. Well, he left immediately afterwards. Beautiful. I also really like the poker analogy, which I used as well. It's like, if you're sitting around a table and you're telling everybody you have the winning hand, and then you don't play it, there's a word for that, and it's called bluffing. If you actually have the winning hand, you don't even have to say anything. You could say nothing. And when it comes time to play your cards, you just put them down on the table, lean back in your chair.
Yeah, but you got to show your cards in order to prove that you're bluffing.
Oh, okay, I see what you're saying.
I can make you lay down your cards, and I can have a nothing hand, a 2, a 3, a 7, a queen, and a 6, all different suits. Hand of nothing.
I see what you're saying.
Yep.
Yeah, that's a good point.
I can win that poker hand.
I see what you're saying.
I got a good one. I can relate it to basketball. So basically, Glovers are basically on the sidelines, on the bench, right? And you can call them like coaches, assistant coaches, and they're drawing up plays, right? So they draw up this major play. They're like, okay, this is this. All right, go. And then we're like, okay, go on the basketball court, execute this play. They're like, no, I already drew the play. It's gonna work. We're like, okay, we're like, okay, go put the basketball in your hands and go score on the bucket, right? They're like, you know what? My play, it works in my head. So, it must work in reality since I've spent so much time drawing this play up, So they're just bench players. They're just wannabe, coaches, but none of them are actual basketball players. Get wrecked.
That's a fantastic analogy. That's a really good analogy. Yeah. Doesn't matter how you draw it up. You actually have to go execute it. But you're right. They kind of just stop at the drawing it up. Well, it works for me. Like, okay, dude. All right. Yeah. That's a great analogy, Neil. Shout out to you, bro. Good job.
You know how I can prove the Earth isn't flat, guys? I can just drop a pencil.
Yeah, no, see, that's the type of stuff we could opposite. We could be like, yeah, see, I know it's flat, just drop a pencil. They'd be like, what?
Yeah, if we were on the surface of a cube, we would be equidistant to the center. We know it's flat, bro.
Yeah, I hate debating those guys. Just draw a pencil, because you just immediately go into caucus with those guys. It's very hard to push them off of their idiocy. I mean, you can refute it back to them eloquently, but then they'll just be like, "Well, it doesn't make sense. You just drove a pencil." Go back to like, just a global reset on the pencil. You can just if they start with that, you already know it's a lost endeavor.
Yeah. You know what? Also, I can tell a lot of people will say they'll do the invisible gnomes and this, that, and the other, pulling things down. I gotta take some shots. I actually don't like that because I can already put myself in the shoes of where they're at, and they're not clocking what you're trying to say. Because for them, like some scientists have already validated the gravity idea. So when you're like, no, I think it's invisible gnomes, they're hearing what they want to hear. They're not actually hearing what your point, which may well be a good one, but they're not hearing it like that. They're hearing it the way they want to. That you're just saying some silly thing that's, they're. So I know a lot of people do that though. They're like, oh, it's invisible gnomes. Da, da, da. Like, I don't think that point actually hits as hard as it probably could if they were actually paying attention in good faith, but they're not. They're just hearing invisible gnomes. They're like, oh, this guy, that's why he's a conspiracy theorist. So I don't know. I don't use that one.
They already think your reasoning is bullshit. You give them that,
Yeah.
They're like, oh,
Yeah.
another bullshit.
Exactly. I don't think it actually hits that hard. Because they're just going to hear what they want to hear.
But when you dive into it deeper and then you explain how I could just make up whatever without validating it, and that's exactly what they do with the globe, then it starts to poke into their model. When I say their model, y'all know what I mean.
If you have a good contestant that's actually good faith, maybe you could use that point in depth. But I think if you're talking to your average Joe, it's definitely not going to clock.
Like, all they have is a model. They don't have reality. Like, everything they have is conceptualized into some diagram that doesn't coincide with reality. They try to correlate it, but it doesn't correlate. But I do like the SAT question for triangles. That's a good one.
Yeah, that is a good one. Yeah, hell yeah.
Indio tried to use my curved line and straight line. He said he downloaded it, and then he wanted to try to simplify it. He's like, I can't fucking simplify it.
What do you mean, simplify it?
Have you seen my meme on the difference between a curved line and a straight line? Eye exam?
No, can you post it?
Yeah, but yeah. Like, you want to talk about basics, right? Whenever we say go back to basics, then we tell them to say the ABCs without singing it, right?
ABC.
Anyway, there's my meme on the difference between a curved line and a straight line.
It's funny how that one, for some reason, they can't seem to figure that out.
But yeah, I made that meme because when I would have conversations with people, I would be like, if a line's not curving, then what is it? And they just couldn't figure it out. So it's like, okay, like, which line's a curved line, which line's a straight line? Like, obviously, we need visuals here. Is it kicking everybody?
I'm still here.
Like 6 people left. Man, that's crazy.
Are we still live?
Yes, sir.
Okay. If anybody's on the computer, should copy and paste the link to the current event and just put it in the lobby. Or send it to your homies in your group chat or whatever.
And tweet it.
Retweet it, yeah, put it on Twitter. It's very brain rot as well. So you know it's W. The title is Flat Earth before GTA 6? Yeah, that's a hitter right there. That's a keeter. But for real though, that GTA 6 needs to hurry up. I wonder if we could start like a community over there. There's a way, or maybe it'll be in the game. What if there was what if there was a radio station in the game that was basically like our Discords? That'd be lit, huh? That'd be fire. You know how you go get in a car? Huh?
I thought of that forever. It's just us on the radio station.
That would be so sick, actually. That'd be so sick. Because I don't know if anyone hasn't played the game, but we've been living under a rock. So when you get in a car, you can change the radio station and put on a bunch of different channels. Sometimes they got talk radio, sometimes they got music, rap, this, that, and the other. It would actually be so funny if there was like a talk radio station and it's a bunch of flat earthers. That'd be so fire, dude. I'd actually like to see that. Implementing that would be a little tricky because, you got to add some comedy to it.
Like making a radio station where like the Globers like yelling at the flat earther, "You retarded."
Well, here's the thing. For anybody, I mean, dude, I get it. There's a time and place to be serious and, have this very technical discussion. But it's like, if you want to get in Grand Theft Auto, you gotta add some brain rot. You gotta be a little funny.
Yeah. Well, there has to be a conspiratard radio station because I know in the last ones they had some of them. They briefly talked about and stuff and made fun of the system, etc., make jokes about it. But
dude, that would be the biggest plug of all time, probably. If we can get into not even just 24/7, but if we could get this topic in Flatter and GTA, bruh, that would be so epic.
Yeah, it'd be like a caller. What are you, just a stupid flat earther? And then one of us just like absolutely smacking them.
Like, do you think you're in a movie building right now? What? That could actually be really entertaining. Hopefully they do something like that. I mean, they haven't reached out to me, but if they do, I'll let you know.
Yeah, I think Rockstar is too busy working on the jiggle physics.
Probably. Yeah, probably.
Man, that's the first place I'm going to be at. Running over hose, going to the strip club.
I'm just gonna be driving cars around, listening to the radio station to see if I catch anything conspiratorial. I don't know. They did some funny side missions. Like they had, what do you call it? The Scientology. They had like a Scientology side mission in the game that was pretty interesting. So I don't know. I wouldn't be surprised if they tried to put some effing stuff in there. Hopefully they do.
Well, I think they just make a parody out of it. That's what personally. That's what I think.
That's the whole. That's like part of their MO is everything's a parody. Freaking Facebook is called Life Invader. The Apple phone is the iFruit. I mean, they just flip everything upside down and make it like amusing. Which is, I think they do a good job of it too. This next game is going to be epic, so it's going to be so epic.
Like, what were the mods you were able to do? Like, could people mod the game and like do crazy things? I heard they were doing that because I never played GTA 5 or 4.
What? No, I mean, I've never played it on the computer, so I don't know. You can't really mod stuff on the console. I don't know what.
Yeah, pretty much just computer. Because that's what I like to watch live streamers like play their modded servers. I've seen some crazy stuff, but I don't know if like you can mod radio stations. I would have to look
The
that up.
modded radio station, that would be
Like if we got our own like
a bot. We
modded
put a bot in here, and it just streams directly to the server, like to the PPA server. So that could work. That would be fire. I mean, that would be an interesting mod, though.
Yeah, I'll look into that because then we can just like hop on the GTA instead of hopping on the Discord. Although it can be connected. The radio like could be connected to
Yeah,
Discord.
we basically put a bot in here that's a GTA bot, and then it just streams the whole channel directly through the game. That would be so sick.
That would be fire.
That would be so dope.
Let me investigate and see if it works on GTA 5.
Yeah, but in terms of the console, whatever they put on the game, it's going to be locked in for a while. We'll have to like.
It's a flat Earth server, you crackhead. Yeah, GTA server. This is a flat Earth server.
No, dude, we're saying
GTA
like
bot. Freaking crackhead, dude.
No, we're saying. Have you played Grand Theft Auto before?
Yeah, dude. My life, yes.
Okay, good. So you know how they have like
tell you about
radio
the mods. They
stations,
used to have
talk
like
radio?
real cars.
Yeah, the real car mod. Yeah, I would do that.
Yeah, they had that, dude.
That's
like
the
a
best mod.
McLaren, a Lamborghini, you know, like actual cars.
Yeah. No, what we're saying is like, if they don't, bro, it would be so dope if they had a radio station, like a talk radio station, and there was some Flat Earth content on there.
Oh, a Flat Earth radio mod? Dude, that would be badass.
But like in the future, we could actually have a modded server where one of the radio stations is just this VC. So we have to have like a GTA bot that streams to the game. Or something like that.
Dude, I'm sure someone must have done an Alex Jones mod back in the day.
Oh, yeah.
At InfoWars blasting.
Yeah, that'd be funny. You can see that.
Just turn the radio off.
I mean, even if we can join, if there is a modded server, say it's like one of the biggest modded servers online, and we could somehow get in with one of their admins to say, hey, can we join your server and can you add our Discord channel to the radio station? And then just like how we're in politics, just like how we're in the English Hub, like there's a bunch of viewers, but we're in the game to a different audience.
That'll be, well, it doesn't seem impossible. That seems doable, man. I think we could actually achieve that.
Like, we're like, yo, Drewski, hook us up with your radio show.
Yeah. I think that would be hot. I think people would actually kind of like that. And that's a whole other way to get our content out there.
Like, for all the streamers are going to have custom servers, like Caden Ross, freaking iShow Speed, all those guys.
Oh, we could have a custom server if we wanted to. I mean, because, like, you know, a lot of people just sit here and listen. Might as well just throw up the game and.
Yeah, there's a different audience, right? I mean, if we can get in there somehow and, you know, to a broad group of people, that'd be nice.
I would love to see that.
We have like Flat Earth headquarters all chilling there in people, like people will pull up. We're just telling people pull up to us. Like, hey, what are the Flat Earth? We just like we're our own characters in the game.
Yeah, we're like at the water doing laser tests. I don't know. We could definitely like that'd be a side mission. That'd be a side mission. You pull up at like a laser.
Yeah, you like that shit, huh?
And like they're like, hey man, like what are you doing with that laser? I'm gonna check it out. We're looking 30 miles over there. I mean, it's gonna be in California. We could even have a Black Swan thing in there. I'm telling you, bro.
I just gave a dog bacon for the first time, dude. I got a new best friend, dude. This dog will kill for me.
No.
Dude, bacon to a dog is like crack, man. I'm serious, dude. Just like tuna fish to a cat, man. You give a cat tuna fish, man? That's a wrap, man. You own him. This dog is like grilling me now.
Get over here!
I'm actually grilling bacon on the grill. We're grilling bacon on the grill.
Nice.
On the grill, man. And you have to deal with the freaking grease.
Good idea. Flat grill? Is it a flat grill?
Yeah, spherical freaking grills, man. What you think that's heated with, lava?
That's the best way to cook.
Here's the flat explain lava.
That's what's under the plate.
Can't explain lava, CB. It's a globe.
I guess so. Magma.
All that other evidence, man, but it was the lava that got me. I was like, no curvature? Bet. I'm a flat earther. No lava? God damn it, I'm going back to the globe.
That's actually pretty funny.
I got a dude to say unit to track units today.
What you got to explain that.
Yeah, he was like, mass attracts mass. I'm like, what's mass? He's like, the kilogram. Says, so the kilogram's a unit. So units attract units? He's like, yeah.
Units attract units.
Well done, man. Well done.
Yay!
I thought that was it. I thought he was gonna freaking crash out. But like I turned it around, I got him to stay for another 30 minutes of juicy clips of retardation. Dude, like in the morning, Yoder was saying this. It's like the Howard Stern show in here at like 7 a.m. Eastern, man. You're missing it, CB. It's really like the Howard Stern show.
I gotta wake up earlier then. What time? 7?
7 a.m. Yeah.
God damn.
Dude, they say the craziest stuff. The girls are all over in English Hub. Chicks are like, Harvard. I know where that is. Can I add you as a friend?
Oh wow. Okay. Hey.
Can we call it Butterface Mornings?
Yeah, exactly. Exactly.
And right after Taji Tower.
Oh yeah, hey man. Yeah, Neil, you're gonna get us canceled, no. You gotta save that for FU, dude. We're gonna get us canceled.
What, Butterface?
No, the other one.
What, a Pajit?
Dude, see, we're gonna get us.
Come on, man.
Get us in trouble.
Is that actually a bad word?
See, I didn't think so, but apparently.
Pajit,
we got some. See, oh, dude. Oh man. Yeah.
My home base, dog.
Start home base. That's where we said it last time, and somebody freaked out, bro. Somebody freaked out. They're like, "I'm gonna report you to Discord. I'm gonna get you banned." To me, and you said it. So, dude, I don't know, bro.
I don't even know the word.
You don't even know the word? Yeah. See, I didn't think it was that bad. I mean, apparently you could say nigga, but you can't say freaking whatever, dude. Fuck it. Who cares, dude? We'll just save all the base speech for FU. Go ahead.
I think it's something to do with the class system, the caste system, and like Brahmin and everybody else. The Brahmin are like the upper class, and the Pajits are like just like not the lowest class. That's the Dajits or something like that. Those are the untouchables. Yeah, dog shit. I mean, that sounds about right.
Yo, dude, you're gonna get us so canceled, dude.
That's what I heard him say.
Dajit or something like that.
Oh my god!
Means untouchable.
Say that. That's the more like nice way to say it. I could be like, all right, what about this dumb Hindu? Right? What about this Hindu?
Bro.
Like my friends are brown,
Come on, Neil.
Untouchable. That's brilliant.
I can say that all my friends are brown, right? My best friends are all brown, right? So I've been around them my whole life. So when I say words,
brown guy.
Right? Yeah, basically.
He's a token Oreo.
Yeah, exactly. Yeah,
I know which cautious words not to say around them when they get offended, and one of them is the word I just said. Right? If you say that, they're like, "Yo, can you stop saying that so much?" I'm like, "All right, no problem." So I replaced it with the cheat one, right? And then so what do you want me to do? What do you want me to call them?
Their name?
Indian?
Yeah.
I get censored for that? I just want to know what the right Indian is. Red dot or feather?
Come on.
it's crazy. Yeah, dude, I hope Oldie's not listening right now. He's out to have a stroke.
I'm just trying to get the proper classification. If anything, I'm being intellectually honest.
I liked Untouchable. That sounded good.
Untouchable? We can do that. Let's just get that over.
You know that Dr. Shiva is an untouchable, right?
Yeah, Red Dot is
why they came to America. He tells a story about how he was an untouchable, and that's why they came to America.
And then he got touched.
Gotta make it through MIT somehow.
Oh my god.
Well, Epstein was hanging out there.
How I managed to keep that juice in my mouth, I don't know.
Hey, yo, pause, bro.
Yo, did anybody hear about the attack in Manchester today in England, terrorist attack?
Saw your message.
No way.
So yeah, Muslim man attacks Jewish synagogue in Manchester, first by driving his car into a crowd, jumping out of the car, attacking people with a knife, whilst wearing a suicide belt. Police were on the scene bloody immediately, shot the man dead, and it was later confirmed that the suicide belt wasn't an actual explosive device. It was just there to cause fear and confusion amongst everyone. But yeah, a few people dead. Muslim man attacks Jewish community on English streets. Right.
Dude, I don't. This world that we're living in might as well just be Grand Theft Auto. This is just chaotic and crazy. I don't even know how do I. This is weird. How do I? There's so much going on. I don't even know how to deal with it.
Yeah, man. Every day. But yeah, just in case you guys didn't know, I've put a couple of articles over on FU.
So why is everybody upset? Because it was an attack on Jewish people? Is that it? You're only allowed to attack the natives?
Kind of, yeah.
If they attacked you, they'd be like, cool. It was, a 24-year-old youth instead of saying what they are.
No, it seems to be a Muslim man for sure. I'm just more concerned that the police.
They told people that's the thing. Don't they usually not say anything?
This is what I'm saying. The man looks Muslim. The police were on the scene immediately with guns, by the way, because we don't carry guns that much in the UK. So they were here with guns straight away and shot this Muslim-looking man who didn't have an explosive on him, but drove his car into a crowd and slashed a few people with a knife on a Jewish holy day in the synagogue. So I don't know what's happened, man. I'm just telling you what's on the news. But the police were there fucking fast. I've seen too many squibs and stuff over the last 2 weeks, man, to take anything that I see on the screen as real.
That's what I'm saying.
For the government.
How are we going to know it's real? And then on the opposite side, if it isn't real, then it's clearly just rage bait for the media to get more clicks and to cause more division amongst, people, And why isn't any of this stuff happening in the summer? Why is the summer just a vacation from politics and everything? And then all of a sudden it ramps up. That's all I got to say.
We had massive pro-Palestine. I'm on the wrong fucking server. We had massive pro-Palestine demonstrations in the city of London yesterday. Massive ones. country's burning, guys. Like, seriously.
I never understood it. Like, there's no way, man. Like, there's no way. Like, nothing. If you were gonna do something off the hook, right? And you didn't like the country, why would you just like attack a random Jewish synagogue? Like, what's that gonna do? Has no effect on Israel. They're not like, oh my God, they attacked the synagogue. Let's stop bombing. Let's stop bombing the Gazans. Obviously, they're not gonna do that, right? So what's the point? Revenge? Like, I don't get it. What's the end game? What were they hoping to achieve?
Well, it depends what the motives were. Depending if this man is radically Islamic, if the situation exists as portrayed, then it's just a radical Islamist doing what he's supposed to do, and that's kill Jewish people, get martyrdom, and get straight to heaven.
Well, I mean, he's supposed to kill infidels, and he probably passed about 100 of them on his way there.
Yeah, exactly. He's probably married to one. I don't know, man. I really don't know anymore. So much stuff like CB said is going on all of the time. It's hard to point your finger at anything and say, this is actually what's happening. You can't trust anything that's on the media. The situation exists. I'm just waiting for the reaction to see what happens next.
Well, my main if something's not broadcasted on the media and it's happening, then you know that's the real shit.
Yeah.
Because if they're showing you the stuff that's happening, they want you to see it. Right?
Yeah. Yeah. Interesting enough, I got Sky News Australia on, and in Australia they're being told that in Nigeria thousands upon thousands of Christians are being slaughtered across the country.
Yeah, I saw a news article online about that.
Yeah.
Yeah, you never see it the other way around. Christians come after Muslims.
I think the people
Dude,
in Iraq.
Neil, have you lost your brain? Neil, what were the two things in the Gulf, dude, that happened, and the thing in Afghanistan? Like, what happened there? Oh, dude.
Do you remember Iraq?
On the media. That's what I'm talking about.
Oh, okay.
But yeah, you got me a bit there.
Yeah, that's why they're doing their thing, allegedly.
I had to backtrack a bit.
And I do say allegedly.
Yeah,
I don't know what to believe. I'm just like kind of numbed everything. It's like they want you to react. It's like I don't even know how to react. My hands are up. You keep doing something. Something happens twice in one day, 5 times in a week. Like, am I supposed to react? Like for crying? Like, I don't know, dude. It's just too much. It's too much.
Supposed to vote Republican.
Well, Trump 2028.
You said the stuff was happening there. Like, I was getting my hair cut by this kid from Iraq, right? He just moved here like a couple of years ago. And he's like, yeah, when I was a kid, like, we used to always see tanks coming in, and you tell me like crazy stories of like his brother's getting killed and people like right in front of him getting blown up. And I'm like, wow, that's the life you grew up living.
Go.
Is that whilst he's got a razor blade around your fucking throat?
I mean, luckily I didn't tell him I was half Jewish. So, I mean.
Oh. I didn't know that about you, Neil.
Actually, maybe I did. Actually, I did tell him that. I'm not gonna lie. I did tell him again. I think it's. I don't celebrate the religion, so technically I'm not a real Jew. But I have the cheap Jewish blood in me. Please give me a good deal. How much you want? A low ball.
What do you call a Jewish guy at the gay bar? A Hebrew.
Oh my god.
Three gay guys walk into a bar, and there's only one stool left. How do they sit down?
Oh no.
They flip the stool upside down.
Oh.
Hey,
smacking my Legos.
Okay, back to the topic, man. Yeah, I have to crack down on off-topic shit, man. Sorry, there's gonna be a crackdown.
Sorry, just following your footsteps.
No,
Dude, you
I
got me
know.
cracking up.
Is that what she said?
Somebody made a good point to me that we talk about all sorts of shit. If someone talks about tomato gardening, they get shouted down, which is actually a legit beef. We're being a little selective in like our off-topic permissibility.
So I just
Which
saw
is why we
the
got
stupidest
FU.
thing ever. I shit
What,
you
buddy?
not. I saw a video where scientists are claiming that the Milky Way galaxy is flapping its wings.
Oh, I don't doubt it.
I shit you not. Search it up. It's so fucking stupid.
Doesn't even seem that outlandish compared to the other stuff.
You know, that's kind of tame.
They've got to be fucking blizzards at this point.
Yeah, if you want to mute me and make an example out of it, I'm all for it. I'm down to be the sacrificial lamb. But yeah, note taken. I will.
No, it's not just it's everybody. I'm talking to everybody in this chat.
Yeah, obviously.
We're probably gonna have like some mod meeting or something to go over it. I've been thinking about it for a few days. You know, CB instigated it. It ain't the cheat thing though. That's part of it. But CB said, "I'll take it to the freaking FU." So I mean, I can't complain to him. He fixed it himself. It's everybody else I got a problem with.
Noted.
You know, CB did, right? He's just like a woman. He doesn't get in the accident; he causes the accident. Right? He's looking in the rearview mirror, going, "Did I do that?" And there's a 3-car fucking pile up.
CB is such a woman. Yeah.
Sorry, chat. What?
You're an instigator.
Oh, facts.
Injo's telling us how much of a woman you are, and we agreed. You definitely are.
But how many women I'm in? I'm sorry, I didn't catch that.
You are one.
And with a lot of women? So I didn't actually mean to click that button, my bad.
It's alright, it's for yourself anyway.
Yeah, we know, man.
Oh, damn, that's shot fires.
We know you've been with a lot of women shopping.
Shopping? Hey!
You're like, oh man, maybe this time is the time. And they're telling their friends, I'm taking my gay friend shopping.
Oh my god.
No! God, please, no! No! No!
That's the nightmare fuel right there.
What is going shopping?
A girl thinking you're the gay guy and taking you shopping because, hanging out with you because she thinks you're gay. That's like legit nightmare fuel.
Yeah.
That could happen to me. That would only happen in a nightmare.
It's not happening to me either. Anyway. They have Liberal Enzo that's server muted. You guys want to talk to him? There's also Truth by Proxy, and I have to go soon as well. I'll be in listening mode for a bit.
Unmute him, man.
All right, chat, unmute him. You heard the guy.
Oh, you're mobile or something? Come on, okay.
Yeah, I'm on that mobile right now game.
Rebel Intel. See how this looks. Right, you're free. You're free from bondage. Yeah, you liberal Enzo. Don't mind me, man. I'm just chilling and growing. I swear to God, every time I open up the grill top, this dog gets up. He's like, starting like fall on the ground.
Whose dog is that?
Not mine. Some chick staying here. It's her dog. And she went out, and I'm watching it. So I blackmailed it with bacon. No, he's never had bacon before. Ever. His entire life. He was a street dog in LA, I guess. They just like snatched him off the street. He was just like roaming around. So the thing has like social anxiety disorder. It just like follows you around like everywhere, man. It's like a shadow.
Is it like a Chad dog or like a little like Spitzy?
No, this just kind of, he's a little weird for a dog. He literally just follows you around. He can't be alone.
So he's not like an Oxford German Shepherd or anything.
Oh, it's not. It's like a mutt or something. I don't know what it is. Take a picture.
Clearly, you're the pack leader then.
I am now that I gave him bacon.
Yep, that's why they follow you around.
Well, he was already following me around, but I thought I'd give him a bunch of bacon. Maybe that would like occupy him or satiate him, and it did for about 30 seconds.
My brother's like that. His dog is like that too. I give her steak, and she won't leave me alone.
I should picture the dog in the chat. This dog won't sit down unless you sit. If you're standing, he stands. He's got a freaking, what do you call it? Borderline personality disorder or something. Thinks you're gonna leave him. Goddamn right they're gonna leave you. You blink, I'm out of here. Well, he just hovers. He don't like do anything. Like, you know what I mean? He isn't like touching you or running into you or anything like that. Just it's like a little shadow. It's really strange. But the reason I'm watching him is because if the dog is left alone, he'll scratch the freaking door until he actually broke some shit. You know how you have like the air guard, the guard that the cold you attach to the bottom of your door keeps cold air from coming under the door. You rip that shit right off. Hey, back on topic. What about Flat Earth? Any Globers in here? Let's see. Let's go through the list. So, anybody that's in here that doesn't have a role, you're muted automatically when you come into the chat. Just to tell you. I'm going to go through the list. Anyone that doesn't have a role, I'm going to unmute you one by one, give you a brief interview, see if you want to be
Scarlet King has no rules.
Yeah, but he's like physically server muted. I'm gonna go in Outback order. Chuck E. Cheese or whatever his name is. You can unmute people, right, Sheepdog?
What's that?
You got the ability to unmute people, right? You got gold, right?
Yeah, I'm gold plus.
Yeah, dude. Word. Oh, and I did read those DMs. Just to tell you, all the DMs you sent me, I do read them. I just didn't really respond.
Oh, you responded, dude. That was funny when you were like, you and AV were having that conversation with that Glober. Like, dude, you scrutinize the hell out of Flat Earth, but you won't do that for the globe. And then immediately, like whatever analogy y'all used, I immediately came to that analogy. I'm like, it's the same damn analogy.
Yeah, exactly. I mean, it's really, and the thing is, his scrutiny of Flat Earth, there was nothing to it, right? He didn't even understand the counterpoint, but just as long as it exists, right? This is a tactic they use in politics and in public relations. They just want to create the appearance of a controversy. There doesn't even have to be a controversy. They just want to create the appearance of one, right? Oh my God, there's the counterpoint. Well, that's controversial. I'm not going to arbitrate that. I'll just pretend that doesn't exist anymore, right? And I'll look for. So they try to look. It's like stealing keep using this analogy. Stealing a car radio, right? You look for the unlocked door, the car with the unlocked door to steal their radio. You don't go through the locked door. So any challenge, right? Anything that has a challenge, you're too lazy to arbitrate or analyze the information to see which is true or not. You're looking for the uncontested ones, right? Anything challenged, no, I'm just not gonna think about that. I'm gonna look for the uncontested stuff. And I'll think about that, and I'll just take it at face value. Unless it's Flat Earth, and then I'm gonna look for anything that might go against it. It's so hypocritical.
No, it is. Like, people will literally say the government's lying about everything except the shape of the earth. Moon landing was fake. Everything's fake. They're lying about everything. But they couldn't trick me about the shape of the earth. There's no way that could happen.
Oh, Chuckles was his VC verified. So I'll do the next dude. The Scarlet King. That name seems familiar. What is with this RimWorld shit? You're unmuted, Scarlet King. I don't know why I did that. So if you notice the X has turned into just a complete troll hell. Sheepdog.
Sorry, I thought I was unmuted. Yeah, but that's how it's always been. Like the hierarchy always went 4chan, Reddit, and then X. That was the hierarchy of trolling.
4chan, Reddit, then X. Dude, that's a bad company to be in.
I mean, like, man, it was a lot worse back in 2020, not 2020, 2017, 2018. It was a lot different there. That wasn't a flat earther then either, so I don't even know what flat earth would look like back then.
Well, strangely enough, the Flat Earth subreddit was started in 2012.
Yeah. Like all of that seemed to like coalesce around 2012. Something was going on in 2012.
I should join that. I'm on Reddit quite a bit just for pictures and stuff. But I always ruffle feathers because it's all libtards. I think I have like negative karma points.
But yeah, like I don't go on X that much right now. I'm kind of like taking a break from it because it's just nonstop, all day trolling, and then a lot of the narratives are the same all the way around. I just go on there to check the news real quick, see what's going on.
Well, the interactions with the Gulbers, they're pointless. They literally ignore anything you say to them and just like blah 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 blah, or not on you to death, right? Or start chanting.
Yeah, and I'm convinced that a lot of these Glovers were defeated in the past, and now they have new like fake names, right? Because of like they've upgraded their arguments, but it's the same person.
How many accounts do you think Plant and Destruction has?
Oh, jeez.
Dude, I blocked him. He replied right away with another account named the same thing. Right away. I'm like, do you think I'm not gonna block this one too?
That's Dave, ain't it? That's David. Isn't that David? I forget. I don't know his last name. I remember him, and yeah, isn't that the guy that debated in a 2-on-2 versus I think it was like Zerka and Whitson versus him and Conspiracy Cats.
Maybe.
You know what? Maybe it was Nathan Thompson. Might have been Nathan Thompson. Yeah, Whitson. I don't know. I have a hard time keeping up with the names. It's roughly about 100 of them.
He argued me and said a boat that's in front of the horizon can be hidden by curvature. I'm dead serious, dude. About the RC boats, he said it's hidden by the curvature of the Earth in front of the horizon.
Yeah.
That's a new one. I've never heard that one before.
Well, that's not new. I hear it all the time, especially on X, when I would share that video of you that I overlaid you debating on to give it like, it's the same argument. Like literally, they get argued into a corner, and then you say, well, if the curve's not the thing blocking it, then what's blocking it? Or what was the argument at the end? Like the distance to the horizon or something like that. And they're like, what is that?
Yeah.
But
dude, they try it with sunsets, right? What's blocking the sun? The Earth. Okay, what's that line that's splitting the sun in half? The Earth. So the horizon, right? No, that's not the horizon. What? Yeah, it's horizon until it reaches, like, if you got an image, right? Horizon, water horizon. Then as soon as it gets to the sun, it turns into Earth and not the apparent horizon anymore. And right there, just at the sun, that's the geometric horizon. And all the other parts of the horizon, that's an apparent horizon. It just shows you like how, like, this is why I don't go on X as much, because it's just the dishonesty. They don't believe what they're saying, dude. They just can't. Like I said, it's a lot of this stuff with these guys is just, I have to give the image, the appearance of some controversy when there isn't any. It's just a game they're playing.
At some point, it is. Like, yeah, they're in the beginning. It probably starts out with the Earth can't be flat, and then after a while, you know, at some point they have to admit that like there's a lot of things that they can't refute, and so they're, like you said, they're just saying nuh-uh because it's a game. Like, let me go online and troll the flat earth.
The horizon back and forth, right? Just that back and forth. What's cutting the sun in half? The horizon. So the horizon is geometric. Yes. So why does it move around? Because it's apparent. You know what I mean? And we just do this back and forth, but they just contradict themselves, and they literally have no argument. And they know they have no argument.
Is the horizon in front of the boat or behind the boat? It's behind the boat. So what's cutting off the bottom of the boat? The horizon.
Well, hold on. Why is there a horizon at all? How about that one? You heard me ask them that, right? Why is there a horizon at all? Because there should be no horizon there, right?
Right.
Not on a 1,000-foot lake. There should be zero horizon. This dog sucks at catching food.
No, he's probably like, if you were my friend, you'd give it to me instead of throwing it at me.
No, I was, but I was like, okay, we're going to vary this a little bit. I was having meat on my hand, which I think is like very subservient. And then I was setting it down somewhere, and he was eating it. I'm like, I'll try throwing it. And he's missed it every time. Like, he hits it with his chin. You know, that's the thing, dude. Like, the horizon, geometric versus apparent horizon, that argument is just fucking unassailable on the globe side. And the only thing you can do is what Matt does, right? No, I don't think ships go over the horizon prove the Earth's the globe, and I don't think the horizon proves anything. Like, literally, that is the only honest out. Even though that's not what they really think. He doesn't really think that. if one of his students asked him, "Hey, why does the ship go over the horizon?" He'd be like, "Well, that's because of the curvature of the Earth, right?" He'd say that.
Oh yeah, for sure.
How do you think a horizon makes sense on a flat Earth?
What do you mean? There'd be no horizon on a flat Earth, dude?
No. Well, there would be a horizon. It would just like blur because of atmospheric fraction, right? Like, it would blur out like on a foggy day.
Those aren't the kinds of questions we typically answer. Like, how could you answer? What's your question?
No, it's hypothetical. It's that the horizon on a flat Earth would be blurry and not well defined.
Yeah, exactly.
Well, we know that's not true.
Yeah, like the observation disproves that idea, but how does that make sense?
Because we can have hold on, Elijah, let me answer. Okay, so because we've tested this where it can't be an Earth curved horizon and it's still well defined. Such as our lake that's 1,000 feet long, right? A lake that's 1,000 feet long. Hold on, dude, you got me finished. So a lake that's 1,000 feet long, when the globe horizon should be 2,600 feet away. So that can't be the globe horizon. It's way too close. And it's well defined.
Yeah, but saying that it's not option B doesn't demonstrate that it is option A.
No. It's demonstrating that it's option A is the fact that there's no obstruction, but there's still a definitive horizon because it's not Earth curve, which is B. But A is this is flat and there's a definitive line.
Yeah, why is there a definitive line?
Because
it doesn't even matter why.
It's just the way it is.
It doesn't even matter why. Knowing why doesn't change it one way or another.
Would that be a valid argument for me to make about why the globe Earth has a horizon?
Well, where's that at?
What do you mean? I'm saying it right now.
Yeah, the globe Earth horizon moves around, right?
Yeah, just like the flat Earth horizon. They're equally unexplained.
That means the horizon's apparent. That's not unexplained.
I'm sorry, I missed the flat Earth explanation for it.
Yeah, it's because you have a shallow angle of view. Right? So there's an angle which you cannot see a flat surface. Right?
I'm not sure what that means, because like the further away something gets, smaller in angular size it is. But you can always
No. There's an angle of intersection. The angle of intersection of your line of sight. Right? There's an angle from which you can't see. Right? So if I look at a spot, if I'm 6 feet tall, my eyes are 6 feet tall, and I look at a spot on the ground 6 feet from my feet, that's a 45-degree angle. If I look at a spot 12 feet away from me, away from my feet, that's what is it? Whatever half of 45 is, 22.5 or whatever, right? Degree angle. And a spot 40 feet away is 12.212 or something, right? There's a distance for which that angle is so small, it's unresolvable. We know what that distance is because we know what the angular resolution of the human eye is.
Well, are you talking about like
observer? It's 3.24 miles, and just coincidentally, that's the same place the globe horizon's supposed to be.
No, what?
Ain't that a weird coincidence?
I've seen a lot of things way further away than you said. 3 point what?
The surface of the water. The water surface.
Yeah, I've seen the surface of I've been in a plane where we're 3 kilometers or 5 kilometers up. I can still see the water below me in quite an expansive direction. All sorts of directions.
Okay, I'm talking about the angle. The angle of intersection, where your line of sight intersects the ground. If that's too shallow, like imagine you have a table, right? A giant fucking table. You can lower your eye level enough to the level of the table where you can't see the surface anymore, because you're looking at the table edge on, parallel, right? Parallel to the surface.
Yeah,
angle
you're seeing
0.
all 6. Yeah, if it's a 6 foot table, you'd be seeing all 6 feet in like an arc second of visible angle in front of you, right? That's what you're saying.
No, what I'm saying. Let's start from the angle 0. Angle 0, your line of sight is parallel to the table. How about angle 0.00000001? Okay. Are you going to see the table?
You're going to see a very small amount of table.
No, you will not. Because the angle resolution in the eye is 0.02. You can't resolve angles smaller than that. No, you can't resolve angles smaller than 0.02. So if that angle is smaller than that, you can't resolve it. You can't see the surface. That's why it's called angular resolution.
You can always.
You're breaking up. You're breaking up, dude.
Like,
you're a robot.
whatever kind of magnification you want to use.
Magnification don't change the angular resolution of a camera. Or your eye or
Yes,
anything else. No, it doesn't. It's not even the same formula.
Are you like a camera that can focus 100x? Will take something that's like a arc second wide in your normal vision and project it into a full, arc degree.
This is where it gets into silly
so that
season.
you can actually resolve the details of it.
Okay, no, you're not resolving the details. You're zooming in. So you're taking. Yeah, what you're doing, it's like taking. Say you take an image that's like 512 by 512, and you blow it up to 10,000 by 10,000. Did you get any more detail by blowing it up?
Yeah.
Really?
Well, no. If you zoom in, you do get more detail, though.
Dude, no. Okay. You're not getting more detail. Yeah. You're just making.
If you use a camera and it's all the way zoomed out.
Look, brother.
You take a camera and it's zoomed all the way out. You take
what
a picture,
you're saying is,
and then you zoom all the way in on the center.
What you're saying is true.
You can see more pixels per arc second.
No, look, the space between the pixels, there's no information. So 512 by 512, I blow it up. Now that one pixel is represented by a square that's 256 by 256 pixels. So where did that visual information come from? That's not
you have to
that
actually zoom in with the camera.
I think y'all are talking. I think y'all are talking past. I think y'all might be talking past each other. So when you zoom, if you're zooming in with a camera on something, you're increasing the aperture size.
All you're doing is taking a part of the full one-time zoom, and you're zooming in on a section of it. So you're taking that and you're expanding it. But it's the same visual information.
If you're using digital zoom, yes. But if you're increasing the
on optical, you're actually getting more. You're getting more information. Like it's the same amount of information per square inch.
The only way to get more information is to have a bigger lens. The only way.
Or you can zoom in now.
Bro, listen to this. If what you were saying is true, why don't we have telescopes that are a mile long? All we have to do is increase the focal length, and we would just frickin' have better resolution of frickin' Pluto and Mars and every other thing. We just make a fucking 5 mile long telescope.
Well, that's something that affects it. That sounds like really impractical for being able to view things.
No, they don't do it because it don't work.
Change their alignment.
Okay, they tried that.
Are you saying that zooming in on things doesn't work?
No, back in the 1700s, they tried to make longer telescopes to zoom in on planets, and it don't work.
Yeah, but telescopes clearly work, and they can see things that the naked eye or like a camera can't resolve.
Yeah, they clearly work, dude. That's irrelevant. That's irrelevant. They don't work better by increasing the zoom. In fact, telescopes have fixed zoom. What makes a telescope better is having a bigger diameter lens. That's why the largest, most powerful telescope in the world is 10.2 meters. Okay, they make that.
Yeah. So if you go from like a small, crappy camera,
that color surface texture. That's what they do. In fact, like, dude, do I need to like post in the chat where NASA says angular resolution, the most important equation in astronomy?
Diameter.
Yeah, Ray, like, seriously, tell this kid something, man. He's freaking off the rails.
Yeah, if you wanted to take a picture of the Apollo landing site, you would need a telescope with a 210 meter diameter.
or get closer. Yeah. So, like, I don't even understand the argument, because all I'm saying is you can get
Why not increase the magnification?
Yeah, you could get a better magnification whether you're using a different device or whatever you want to say, like a crappy camera that's only got like 1x zoom or 2x zoom. And then you could go to a full telescope, which gets you like 100x zoom. You can get more information. So it's not about resolution, because even when you zoom in on the horizon with a telescope, it can still be crisp. So it's not like all the information's getting compressed inside an area so small that you can't see it. Because you can resolve the details, just like looking over the Chicago skyline, you can see the crisp line cutting across those buildings, and you can clearly see the buildings, the top of the buildings. So it's not a resolution issue.
Yeah, and we can replicate that on a flat surface, like I just told you.
With that laser example that you sent earlier?
Not with a laser. Small scale on a small lake where you eliminate curvature as a variable.
How do you do that?
You use a distance where the horizon can't be a factor. That the horizon has to be behind the water. Distance-wise.
Yeah,
and I'm talking about the geometric horizon, right? No, I'm talking about, yeah, of course above the surface. Camera's above the surface. Talking about the geometric horizon. So you can calculate the distance it should be.
Well, you can't see the geometric horizon.
We can calculate the distance it should be.
Yeah, but it's not going to be the same as the apparent horizon, obviously.
Is it going to be 2.5 times too close?
It depends on the conditions, of course.
Oh, so the conditions.
Yeah, I mean, you've shown it yourself where the horizons move up and down. They fluctuate, obviously.
They move back and forth in distance.
Sure, that's another way of showing it, of stating it.
Yeah, so this happens on a flat surface.
Well, I mean, that's an assertion.
Sure.
How do you demonstrate that?
1,000-foot lake? 1,000-foot lake?
Mm-hmm.
1,000-foot lake is not a flat surface.
They curve slightly, yes.
How do you know that?
Well, I sent you the reciprocal zenith angles thing. That demonstrates.
I said 1,000-foot lake. Okay, first of all, you didn't even know plumb lines curve. Okay, reciprocal zenith angles are trash because of deflection of the vertical. Right?
Yeah. So why does that vertical deflect on a flat Earth?
It's a deflection of the vertical that has nothing to do with reciprocal zenith angles. It has to do with plumb.
Well, I'm saying in these particular instances, we know what causes deflection. Dude. Yeah, we know what causes deflection of these zenith angles.
Oh,
and we can go in conditions. You do novel testable predictions to see if you can isolate and figure out what the factor is. We've figured out that it's large masses that causes deflection. Yep.
Who dug that hole?
Who figured that out? Mason-Dixon.
Who dug that hole?
To
find the large mass underneath and deflecting. And first of all, you just combine two things, right? Deflection of the vertical is not a zenith angle, because those are two different things. Though they are similarly related. So the first thing you do is you plumb the instrument, right? But you don't. The plumb is not perpendicular to the surface of the Earth. Even in geodetic surveying, it says the level line, the horizontal line, is only valid at the instrument itself.
Yeah, of course. That's what
At
I'm
the instrument.
saying. Reciprocal. Yeah.
So what does the zenith angle get you? You're trying to extend that level line out to the other light.
Yeah, and if the Earth was flat, they would line up.
You're trying to,
perfectly if they were
you
the
just
same.
skip right past that part. That now you're trying to say levels over here as well as at the instrument. No, but level's level there, and the level that's there is different because of the undulations of the geoid. Okay, the
undulations of the geoid.
The geoid is the equipotential surface of gravity.
But you don't
Why don't you
believe
tell me
in
this?
gravity.
Tell me this. Why don't you tell me this? Why don't you tell me this? What's the reference ellipsoid for? If they're measuring curvature, oh my Jesus Christ! You don't know what the reference ellipsoid is? The WGS84 reference ellipsoid. You don't know what that is?
Oh, the WGS84. Yeah.
It's the reference ellipsoid. It's the reference ellipsoid.
Okay.
So they take an abstract mathematical ellipsoid of revolution, which means it's a solid, okay, and they project measurements onto it using something called reduction of the horizontal direction. Okay, so what they do is they apply a formula based on the ellipsoid, and then that changes the azimuth that you're pointed. It rotates it through calculation, and then they record that measurement.
Okay.
Well, they record that reduction. Okay.
Does that give you more accurate measurements or less accurate measurements?
No, it has nothing to do with accurate measurements. It's creating a sphere where one is not measured.
Well, I'm assuming that you're saying that like surveyors do this. Am I correct?
Yeah. That's right.
So surveyors do this, and it causes no difference in the measurements they're getting, or is it a positive? Like it makes it more accurate?
No, no one is measuring reciprocal zenith angles, dude. You're deluded.
Yeah, I sent you a page. I sent you a thing where a guy literally did that.
Yeah, that's a cool story, though. Okay, that's a cool story.
You can do it yourself.
Yeah, that's right. I could. How do I compensate for the geoid? The EGM gravitational model. EGM, I think it's EGM.
If you do it near on a local
surveying,
scale,
it says
doesn't matter.
Palm is not perpendicular to the surface of the Earth. But you have to assume that for reciprocal zenith angles to mean anything.
What? Can you say that again? I didn't understand what that meant.
Palm is not perpendicular to the surface of the Earth.
Okay.
Okay. For reciprocal angles and zenith angles to mean anything, they must be.
Well, I mean, it's like a tangent to the Earth. It's not.
You don't even understand your own fucking argument. This is sad. Go find the people you're parroting and bring them because you don't know what you're talking about. You don't know what you're talking about. Whoever's argument you're parroting, bring them.
Okay, so you don't want to discuss it with me.
You're not competent in this field. You don't know what you're talking about.
I would say you're not competent in this field.
You can say whatever you want. I can cite
a very obviously observed thing, and you say,
"No, they're not. No, they're not. You don't understand it."
Okay, yeah. What's wrong with it?
That they're not observed. You don't understand the fucking answer, dude.
Yeah,
you can keep asking me what's wrong with it, and I'll keep telling you, and you'll keep going. I don't understand.
A deflection in the downward vector is caused by large masses on the surface of the Earth or beneath the surface of the Earth.
It's supposed to be due to curvature. It's supposed to be for reciprocal zenith angles to mean anything, as far as Earth's the sphere, then that plumb line has to be perpendicular to the surface of the Earth, which they're not.
No, if it's a sphere, then that would never even be the case.
You don't even understand the argument. This is fucked up, dude.
If it's a sphere, how the hell could you get a line that doesn't curve, to be perpendicular to the surface of the Earth? It's impossible.
90 degrees from the surface of the Earth, perpendicular. 90 degrees.
Yeah, that would be a tangent.
No. It's a surface normal.
Further and further away.
Zenith is not a tangent, dude.
I'm not saying the zenith. I'm saying the perpendicular. to the
perpendicular is zenith, dude.
So you're really not understanding this? The downward, the vertical.
Vertical is zenith.
From that. Yes,
no.
Down.
The vertical, that plumb line, is not perpendicular to the surface of the Earth.
It might not be perfectly, but it's definitely, in most places, it's within margin of error on the instrument that you wouldn't even be able to tell.
Then how did they tell?
There's a ton of ways that you can experimentally prove this.
No. How did they tell in the first place?
Mason-Dixon. Mason and Dixon figured it out when they were doing a survey of the Appalachian Mountains in the United States.
Okay, that doesn't tell me how. You just named
when they were doing surveys of this line across the United States, they were noticing a deflection when they were getting further and further away from the Chesapeake, and it was slightly skewing their measurements. They were noticing that there were things wrong with it because they had quality checks to confirm that their
how was it skewing their measurements?
Line was actually.
Yeah, tell me how it was skewing their measurements.
Yeah, it was deflecting the vertical very slightly.
Mm-hmm. Versus what?
What?
Versus what? What's the reference?
The reference, they have other reference points that were. Yeah, they have other reference points.
Relative to what?
To the surface of the Earth.
To the surface of the Earth. Are you sure about that?
Certain.
So Mason and Dixon did not use the Clark reference ellipsoid, because that's what it was called back then. It was called the Clark reference ellipsoid.
Okay.
And they also did reduction of the horizontal direction, and they are not measuring these things; they're calculating them, because they're assuming that the vertical is not on the same.
Calculated thing.
Oh my God, dude! You don't understand. Virtually anything.
Like I can measure the angle to a top of a building and then measure the distance between me and the bottom of the building and then calculate how tall the building is.
That's fantastic. That's not what they're doing.
That's a measurement, and I mean, that's pretty much exactly what they're doing.
No.
They're taking real world measurements and then they're confirming. Or they're calculating.
They're taking real world measurements, changing the azimuth. That azimuth that's measured, they're changing it.
Okay.
Why are they changing it, dude? Because they need to tilt the vertical. Because they need to tilt the vertical. It's not for more accurate measurement. Okay, if they measure something and change it, how is that a more accurate measurement?
I mean, if this wasn't actually affecting their calculations, then why the hell would they even make this bizarre fake thing up?
Bizarre fake
doesn't make
thing.
any sense.
No,
yeah, you're saying that it's fake, that gravity doesn't cause any of this shit. So why make all this up?
Gravity doesn't cause any of what shit?
Like a departure from towards the center of the Earth when you're closer to a massive body such as a mountain.
Look, if the Earth is an ellipsoid, you can't point toward the center. It would only point to the center at the poles and the equator.
Why?
Oh my God. Okay, imagine you're at 45 degrees, right? And you have a horizontal line, and then you take zenith there and go perpendicular and draw that and extend that line. It will not intersect the center of the Earth. Because it's not a sphere, it's an ellipsoid.
Do you realize how very slight the obliquity is, right? Why do you think that would notably affect the ability to establish a correct zenith angle? Correct zenith.
Dude, you're just all over the place, dude. You're just like a potpourri of bullshit. Fucking potpourri of nonsense. So, really simply, okay? I'm going to ask you again. What's the reference ellipsoid for? Why? If they're measuring a globe, why do they need a reference ellipsoid? What's it for?
Probably to make their calculations more accurate.
How would a abstract concept reference ellipsoid make their calculations more accurate?
So
they have
if you're
measurements.
trying to build,
They have measurements, dude. But they have measurements.
So you don't want me to answer the question?
Yeah, what they have measurements. Why aren't they just using the measurements?
Yeah, because like if you're trying to build a house and you want to make sure that you're doing it correctly, that you're doing it just the way it's supposed to be done, so that the product comes out correctly. You're going to go back and check these blueprints, these abstract concepts that aren't actually in the real world.
That's right. So I'm not going to go the blueprints.
Accuracy of the measurements.
It doesn't help the accuracy of the measurements. The only thing that helps accuracy of the measurements is measuring correctly. So reading the instrument correctly. There's no calculation involved. You use a tape measure. You read the fucking reading.
What? A theodolite doesn't. It measures angles, not distances.
Yeah. Oh, dude. You're not this stupid. Okay. Can't be this stupid. Whatever they're measuring.
Are you saying that surveyors are using a measuring stick?
Are you saying that you're going to straw man me?
No, I'm asking a question. A straw man.
Yeah, they do use a measuring stick. It's called the rod, dude. Yeah, they do measure with a rod. What do you think they sight in with the freaking theodolite?
Are you talking about the far end? That's not measuring the distance between.
They have a measuring rod. They have a measuring rod, dude, with freaking little heights on them, right?
Yeah, off the ground.
And yeah, so they're measuring, right?
Yeah, they measure the angle from the top of those, from whatever particular position on that measuring rod.
Yep. Yeah, but they are measuring a height, right?
No, they're measuring an angle with the theodolite, and then the rod shows the distance from whatever point they want.
And we're still at what's the reference ellipsoid for? And how does the reference ellipsoid does not increase the accuracy of measurements? You go, look, would they measure? Let's say they didn't have a reference ellipsoid. Would they measure the Earth to be a globe?
Yeah, of course.
Okay, so why do they use it?
To make it more accurate. Well, I don't know why you keep asking the same question.
Because you can't say how that would make it more accurate. You gave a fucking analogy that's not analogous, and it wouldn't. That even wouldn't make house building more accurate. Listen, it wouldn't make house building more accurate.
Looking at the blueprint of a building wouldn't make building the building more accurate.
Building the building, yes. Are you saying you're building a globe? Are you building a globe?
I'm saying
where there isn't one. Yes, yeah, there we got it.
Yes, that's
building a globe where there isn't one. Congratulations.
Okay. So why do you think that reciprocal zenith angles are the way that they are?
They aren't. They aren't, dude.
So you're just
making shit up. Deny what, dude?
You can do it yourself.
Sure I can. Sure I can.
Yeah. You can run a theodolite and go out and do it with a buddy.
Yeah, and I'm sure that's exactly what you did. So you go do it first, then come back.
Will you believe any of the measurements that I take?
Dude, you go do it first and come back.
I've already done it.
No, sure. How many measurements did you do?
How many would it take for you to think that it's accurate?
Okay, shut up then. I'm gonna mute you for lying, dude. If you keep lying, I'll mute you. You've never done shit, dude.
Why do you think I'm lying?
No,
I want to know what your standard of evidence is.
Because you can't tell me what you did. That's why.
I set up a theodolite.
I ask you because
on the other side.
How many measurements did you do? How many measurements did you do?
10 on each side. 10 on each side.
10 on each side. Okay.
Yep.
And what did you get as a result?
I had to actually look back at my notes. I don't remember the angle departure from horizontal.
You're a fucking lying sack of shit. What was your delta?
I just told you I don't remember the number. I'm not great at remembering numbers off the top of my head. I write them down.
What was the distance?
I think it was like 0.3 miles, something like that.
Did you correct for refraction?
We calculated for it, yep.
Did you use a theodolite that already has all those things already in it? In software?
No. My buddy's actually the surveyor, so I'm not so familiar with the particulars of the theodolite.
Your buddy made surveyor?
No. I don't know that guy.
Is he anti-flat earther? Don't tell me it's Jesse. Is it Jesse Patholight?
Is a shoe belt?
No, it's not anybody you know. There's nobody you know.
Yeah, Jesse Patholight.
It's Jesse. We know it's Jesse.
He's not a surveyor.
The surveyor that I worked with? No, his name isn't Jesse.
This never happened. Let's be honest.
So how many measurements of this would it take for you to believe it? Like, I don't understand why you guys don't go out and do it yourself to prove us wrong.
Prove what wrong? You haven't presented any evidence that you're right. You're just chanting the same thing over and over again. This is your whole shtick, dude, that you've been doing all day. Is that you make a claim and then try to reverse the verdict. No, you make a claim and then say, this is what happens, present no evidence of it, and then do a burden of proof reversal.
Sure.
Present evidence that I'm wrong, but I've never presented any evidence that I'm right.
Yeah, why do you think that Rufosky's evidence is not evidence?
It's Jesse? It's Jesse?
Well, that's what I sent to you earlier, yes.
Jesse?
That's not the surveyor I went out with.
Okay, so check this out, dude. I know Jesse, okay? You know the first thing I did when I investigated Flat Earth? Want to know the first thing I looked at? Geodetic surveying. Do you know who I ran into? Jesse. He didn't know shit about surveying. All the things I just talked to you about, he didn't know either. Because he's a fucking end user like you.
Oh, so you
take the instrument. No, you guys don't understand what you're doing, dude. You don't understand what you're doing. You don't understand the field.
Geodetic surveyor?
Yeah, he's an end user. He is licensed to go through the theodolite, write down fucking numbers, enter those numbers in a piece of fucking software, hit print a report, and send it to whoever. He doesn't understand the mathematics underlying it.
Did you do?
Yeah, I do.
Could you explain it to us?
I tried to. Okay.
Like, what's the... Yeah, run me through it.
Okay. Really simply, I'll just start with reduction of the horizontal direction. Okay? So you have a reference ellipsoid. So that means there's going to be a vertical tilt. What's the vertical tilt? Oh, reciprocal zenith angles. I thought they measure them. Well, they don't measure them. They calculate them
sorry to interrupt.
using this thing called reduction of the horizontal direction. Because the plane of the vertical are not parallel. They're tilted relative to each other. So if you tilt this in calculation, you have to rotate the azimuth. Because now the direction of north at that point changed. So you have to rotate the azimuth. You have no idea what I'm talking about, do you?
Sorry, you misunderstood my question. You misunderstood my question. Like, let's say you get a job as a surveyor, and you're told, go lay out this.
Dude, my friend did surveying when he was in high school. My friend did surveying when he was in fucking high school. He hadn't even graduated high school yet. It's not a fucking. It's not an elite skill. Dude, it is. Dude, surveying is semi-skilled labor.
You might want to talk to a doctor about the Tourette's, man. It's pretty bad. But
semi-skilled labor.
You get a
the
job
fact that you're enamored by a run-of-the-mill surveyor says it all. You think that that's some high level of technical skill.
No, I want you to explain something to me. I want to understand your understanding of it. You get a job for a 2,000-foot long building that's 400 foot wide. You're handed this job. What's the first thing that you need to do?
I'm gonna read the specifications and requirements for doing the job, because all that shit is gonna be laid out before you ever break ground. Exactly how they want it surveyed, the software to use, the freaking equipment they want to be used, the level of tolerance, to what order they want closure, right? How many times they want it measured, where the fucking benchmarks are going to be placed, what's the reference benchmark, all that shit is going to be laid out in writing before you ever do anything. Any monkey could walk in and just follow it like a checklist and do it.
Okay.
There is no, like, you think the surveyors walk in on the job and they're like, we're the real engineers here?
Well, I like and I agree with your first step is read the specifications and the plans. What's step 2?
What does that even mean?
Well, I agree with your first step. You want to read the specifications
Check the
and the
schedule?
plans.
Yeah, check the schedule. How often do you have to? How often do you have to survey? Where's the sign-off sheets?
Mm-hmm.
Who do you report to? Like, dude, then you have to go out and do it, right?
Once you get boots on the ground, what?
You measure a flat Earth. That's what
Well, you
do.
find the benchmarks. You find the first benchmark. Good. Well, they would probably call it the central benchmark, right? You'd find that.
Sometimes. Okay. What next?
Who cares? This is irrelevant. This is irrelevant, dude. Okay. It's
sure,
relevant to the
you're
mathematics.
saying that you know this better than like licensed surveyors.
Yeah, the mathematics.
The
mathematics. How it's created in calculation.
Yep.
Dude, listen, you know what you sound like to me? You're like a taxi driver. And because you drive a car around all day, you think you can engineer the internal combustion engine.
Okay.
Okay. Race car drivers, taxi drivers, delivery truck drivers, they know a lot about cars. Obviously, they're in them all day. Right?
So
they have a lot of experience. They have a lot of experience. They have a lot of experience. They have a lot of no, don't interrupt me. They have a lot of experience with cars.
I don't know.
Tons
You
and
interrupt
tons and
everybody
tons.
else.
Tons and tons and tons of experience with cars. Tons. But they don't know how the fucking internal combustion engine works. And Jesse,
sure, and you have
tons and tons of experience with theodolites and has no idea about the underlying mathematics.
Experience with theodolites, and yet you're telling me
I took differential geometry. That's all I need to know. Differential geometry. That's all I need to know.
Okay. Why do you think that's the only thing you need to know? Have you gone out?
Because that's how it was created in the first place. Because the first thing ever published on freaking geodetic surveying is a book called Helmert. Okay, published in the 1800s. That's fucking like something like 1,300 pages of equations, and it says in it that because we can't measure the sphericity of the Earth, we have to proceed from a theory of formation. That the Earth is rotating, and then gravity formed it into a ball, and then they create a reference ellipsoid and map measurements onto the surface of this reference ellipsoid.
Without any measurements.
No, they map the measurements onto the surface of the reference ellipsoid using curved plumb lines.
Yeah, they're doing it the opposite way around. They're not taking
no idea what I'm talking
about. The ellipsoid. You're saying they have the ellipsoid and they force the measurements to match it. Am I correct?
They don't force the measurements to match it. They correct the measurements to match it.
Yeah, which
correct
incorrect. Yeah, they incorrect the measurements so that they match the ellipsoid.
Look, bro, you can map any surface to any other surface.
Kind of.
Proven by Gauss and theorem of Grigium. This is where differential geometry comes into play, dude. You can map any surface to any other surface. I'm not talking about a projection. I'm talking about mapping, a mapping function. Because that's what the globe does. It doesn't do a straight projection. It does what's called a mapping function. That's what the curvature of the plumb line is, right? So what happens is that you have the reference ellipsoid, but you have it tilted vertical relative to the surface of the Earth. It's not perpendicular, but it has to intersect the reference ellipsoid in perpendicular. Well, you can't do that because you have a tilted plumb line. So you have to curve the plumb line to get it to intersect the reference ellipsoid. Now think of it as like this. You have your reference ellipsoid underneath, and then you have your actual physical ground above it. And then you have your theodolite on that physical ground. Now your theodolite is tilted relative to the oh god, dude. You have your theodolite tilted relative to the reference ellipsoid. Okay? Yeah. But it seems that on the surface of the Earth that it's perpendicular.
Yeah, what's the quantity that you're saying that this deflection happens?
It undulates.
Yeah, like what's the extreme?
It depends. Depends on where you are.
The most
because how do you even know it? How do you even know it exists, bro? How do you even know it exists in the first place? That's the real question.
Measure it.
Against what?
Like, you know how well, obviously you know how surveying.
Against what? What are you measuring it against?
You're surveying. You're measuring it against.
What are you? How do you know your vertical is tilted? How do you know if it's a very small thing? How do you know your vertical is tilted?
Well, if it's a very small thing, then you're not going to know it unless you have some kind of external reference.
Well, then how do? That's why I asked you. Then how do they know it?
What's the? Because like it seems like a lot of your hat is hanging on.
Then how do I know? Then how do they know it?
Perfectly straight up and down. It's slightly deflected.
It's worse than that.
But I'm curious, like, how much it is deflected, because you keep saying it's deflected. It's deflected. Like it's
undulating.
Like it's a notable problem. What's the most that is deflected on the surface of the Earth?
Just so 0.71 arc minutes.
So less than a degree.
That's the largest I've seen. That's the largest I've seen. But that's a single point. Okay, yeah. That's just that one single point.
Yeah, so you're talking about
what happens when you measure lots of, what happens when you measure lots of points? It's a cumulative error.
Yeah, it does cause a cumulative error, but
how do you correct it?
Not going to be that far off.
How do you correct it? Well, how do you correct it? How do you correct it?
You probably have a model that more accurately.
Yeah, exactly. Yeah. Really, it's almost like they're measuring the surface of the Earth and mapping it to a reference ellipsoid that they actually measure.
Yeah, you can actually.
Because within this, right, you know that you're going to have negative zenith angles, right? You have to. You have to have negative zenith angles.
What does that even mean?
That means your vertical is tilted so that they diverge instead of converge. They won't converge at the center of the Earth. They'll diverge away. They'll converge somewhere in the sky. It has to be because the gravity, theta Earth, lumpy gravity, the gravity vector is undulating. So you will have locations where their zenith angles converge. They don't tilt away from each other. They converge towards each other.
Oh, okay. I get what you're saying now. So, like, where this happens, correct me if I'm wrong. If you
happens all over the world, happens everywhere.
Sure,
happens everywhere.
Sure, but it's typically around like very large mountain ranges. Do you agree with that?
Nope.
There's
no very large mountain ranges in Australia. There's actually a published paper by Featherstone, who's a very cited author in geodesy. You should maybe read it. It's called Use and Abuse of Deflection of the Vertical. He talks about this very subject. Pardon me?
Is it some kind of peer-reviewed paper or something?
Yes.
Okay.
The conference papers presented at a conference of geodetic surveyors.
Sounds interesting. Yeah, I mean, I know there are subsurface conditions that can cause deflection from the vertical as well, but I'm not seeing like what the big issue is that we're not even talking about an arc minute of deflection. Like, why would this cause such a big problem?
I guess you weren't listening. It's cumulative. You know how we know it's cumulative? Because if we compare the North American datum 1927 to the North American datum of 1983, there's a huge systemic error.
You're talking about the American arc of the parallel?
No.
I'm not familiar with what you're referencing.
The North American datum that was surveyed in 1927.
I thought that was called the American arc parallel.
No.
Maybe I'm misremembering
it. They did a bunch of surveys in North America. This one was for a specific purpose. It's created data.
And they're using these calculations in them. You're saying that these calculations are changing flat Earth measurements to globe Earth measurements. It's forcing the measurements to conform to the ellipsoid.
Yeah.
But if that was the case, wouldn't we be getting like distances between cities?
That's why you curve
really long, because all these issues would
that's
compound
why you
on
curve
each other.
the plumb line. Yeah, no, that's why you curve the plumb line. You're interpolating the error within measurement distances.
Yeah, but these errors would compound, like you're saying. So if you're moving the zenith, and it's
how would you know they compounded? How would you know
that it would compound the error?
How would you? Yeah, there is a compounding error that they have to that they correct by interpolating the error between distances.
Yeah. So it's correcting these errors. It's not causing more issues to come up.
Bro, this is what you don't understand. They're not measuring between. Say we have 100 points. They're not measuring between 0.1 and 100. They're summing. They're summing the whole way.
Yeah. But if you were summing the whole way, you're having compounding errors.
How are you going to know there's a compounding error unless you measure the entire distance? If I have 100 measurement points, how am I going to know if there's a compounded error unless they measure 1 through 100?
Sure, you
right?
don't
1 to 100.
Measure distance.
Oh my god, dude! You guys it's the same fucking gimmick over and over again. Don't ask me what I think about fucking what people can measure and can't measure. I don't care about what they did measure.
Yeah, I think planes do measure distances fairly accurately.
No, we're not going on planes. I still want to know what the reference ellipsoid is for.
You said it.
You don't know.
Why do you keep bringing this up?
You said to make it more accurate because it proves that they don't measure a globe.
That's not what I said.
I know that's not what you... no, you said, why do I keep bringing this up? And I just told you why.
Oh, okay.
It proves they don't measure a globe. Proves they don't measure a globe.
I don't see how that follows.
Okay.
Do you know what the...
It does follow.
What's it called?
Okay.
Because
they wouldn't need it if they measured a globe. It wouldn't be necessary if they measured it or if there's a globe. They wouldn't need it. Doesn't improve anything.
If it wasn't a globe, then they wouldn't need it. They wouldn't do it. If it is a globe, it makes perfect sense.
No. Look.
Why would they introduce something that's completely unnecessary?
So why did you just try to straw man me like crazy? I said, I'm going to say it again. If they measured a globe, they would not need a reference ellipsoid. It would not be necessary.
No, they would.
Why? They just measure the globe.
Yeah, you
just measure what it is.
Yeah, because like you were saying, a very small area, you're not going to notice these errors. But because you're using a very small area, you can't sample. You're not sampling outside of it to see what the particular issue is. Where if you have a large data set that can correct for these errors, then you won't have them. So it makes your small scale projections even more accurate.
How would it make it more accurate? It doesn't exist in reality.
Well, I mean, that's your assertion.
That a reference ellipsoid exists in reality. That a reference ellipsoid, an abstract concept made mathematically in someone's mind, exists in reality.
No, it accurately represents reality.
How do you know that?
Because it's been measured, and if it was incorrect, then it would cause.
They measured the reference ellipsoid, or they measured the Earth. Which one did they measure?
Both.
Both. How did they measure the abstract concept again? What was the instrument? Was it a freaking telekinetic? Was it a telekinetic hat that read minds?
It was. They put it on the ground, and it read the Earth's mind. How did you know? I thought that NASA kept that.
No, it's not the Earth. No, abstract concepts exist in human minds. They don't exist on the Earth.
Yeah. But it accurately represents the Earth. That's why
you just keep saying, you just keep chanting that like a nutcase. Okay, you don't know if
he doesn't get it because if it represented the Earth and the measurements they took were 1-to-1 with the Earth, then they wouldn't be needing to fit it with the reference ellipsoid. Which
you don't understand that the reference ellipsoid came first. The reference ellipsoid came first.
Before they did measurements of the Earth?
You got it.
Yes.
How long do you think we've been surveying for?
Oh my god.
And how long do you think WGS 83 has existed?
That's a red herring because you don't need that for surveying. But if we're talking about the surveying of the United States or whatever, then we'd be talking about that. You're not talking about surveying for thousands of years, though. 'Cause that's not what we were talking about, was it?
No, but if you go out and you do enough surveys and then you're noticing errors across these surveys, then you can create a model that corrects for these errors in the surveys. And then you provide that to the future surveyors.
Yeah.
That their calculations are more accurate. And that's what I'm saying is happening. And you're saying, no, they're only introducing this
you don't get it.
Fudge the numbers to get it flat Earth to be a globe Earth.
Yeah, it's called cherry picking. Fudging the numbers. Do you understand what that is? So they have an abstract concept, and they want the Earth to conform to the abstract concept. In the 1927 datum, so their method was to start in one place called Fort Meade in Kansas. That was their origin of coordinates. They did astrogeodetic surveying for 6 months to get a latitude, longitude position. Then they surveyed out from that point, north, south, east, and west. They created a North American datum. When they did the 1983 survey, they found that there was a difference between the two that had to be systemic. So basically started at the Ohio River Valley, and as you went east, all the markers were meters too far to the right, with that increasing with distance, north-south. And as they went out to California from basically the Ohio River Valley, the distances were expanded instead of contracted. Right? How do you explain that? How do you explain an increasing error as you go toward the west coast, as expanded error, and then the other way it's an increasing contracted error? Meaning one way the markers are too close, the other way they're too far apart. Increasing with distance. From a common spatial reference point. So they chose one location. Fixed.
Okay.
The systemic error exists. It doesn't matter if you don't know about it.
No, I mean,
there may all these errors. It exists, dude. You just don't know about it. You're claiming it doesn't exist because you don't know about it.
So you didn't actually you didn't really want to ask me a question. That was for a rhetorical.
Yeah, it's rhetorical. Yeah, you're right. That's rhetorical. The point is, these errors exist. The reference ellipsoid exists because they don't measure a globe. That's why they exist.
Sure.
That's why they exist.
That's your faith position on it. I mean, if you had any actual real measurements,
if you had it, they wrote it down and said it, dude. It's not my faith position. They wrote it down and said it.
I've been doing a real good job of not interrupting you, but you're like kind of a real asshole about talking over other people.
That's the main point.
So
giving the main point.
Because you have to say some snide-ass comment about somehow I believe that. No, I don't believe that they wrote it down and said it.
Yeah, there are going to be errors in measurements.
No, that they can't measure a globe. That's not what I'm talking about. You're straw manning again, as usual. So they wrote down that they can't measure a sphere, so they have a reference ellipsoid. Because they don't measure a sphere.
They wrote that down.
Helmert wrote it down.
Who? Homer?
Homer, who invented geodesy. He's the inventor.
Homer Simpson?
Helmert.
Oh, the Odyssey?
Frederick Helmert.
The book? The book writer?
No. Frederick Helmert. He wrote Mathematical and Higher Theories of Geodesy.
He said Homer Simpson.
Yeah, he's bricking.
So, I mean, if you had any real measurements of flat Earth, you would be providing those instead of saying this side isn't getting anything correct. You would go out, you would invent some new thing, you would be the talk of the town and be innovating in an industry. And that's why I don't take any of this seriously, because if there was truth to what you're saying, you'd be able to implement it in the real world and demonstrate the truth of your position, where here it's just, I don't understand this. This is false. This is wrong. It's not any positive evidence.
That's an appeal to utility fallacy. Congratulations.
Do you disagree? If your idea was correct, you would be able to take it and implement it in the world and innovate in a meaningful way.
To do what?
If the Earth was flat, like you could create much more accurate maps. Much more accurate maps.
They're already accurate enough for all practical purposes.
But they're based on a globe.
No, they're not. Another freaking Dunning-Kruger fucking moment for you is about to come up.
So if I went to Google Earth and I measured the distance between Sydney and Santiago,
Do you think Google Earth's a globe?
It would give me an accurate enough
Google Earth's a cylinder. You know that, right? Google Earth's a cylinder.
No, it uses the Haversine formula. You're absolutely incorrect.
Google Earth is a cylinder. No.
If it was a cylinder, I could go to the North Pole and to the South Pole, and they would be the same distance between lines of latitude. That's at or lines of longitude. It's absolutely incorrect. No, it uses
Google Earth uses
the Haversine formula.
Google it.
You're absolutely
when you get home,
wrong.
Google it. When you get home, Google what Google Earth uses.
I know that it uses the Haversine formula. You're dead wrong about this.
Okay. You know that Google Earth as an app uses the Haversine formula?
Yes.
Okay. Can you show me the code?
Because I can do it myself.
Can you show me the code? It
gives me the same answer that Google Earth does.
Can you show me the code?
Hold on.
You can do the Haversine formula yourself.
I googled it for you, Indio. Does Google Earth use the Haversine formula? Answer is no. Google Earth does not primarily use the Haversine formula for distance calculations. It does say it uses Vincent's formula and other more complex algorithms for the Earth's oblate spheroid shape.
There you go. It uses an oblate spheroid, not a cylinder.
Okay, Google Earth is a cylinder because it's a Mercator. It's a universal transverse Mercator, which is a cylinder. Okay, they wrap around
You can easily disprove this yourself. Just go to the North or the South Pole, do one line of longitude 40 degrees apart.
If you would let me finish,
longitude,
they wrap.
And then do that the same thing in the South.
They wrap the cylinder around the ball, dude.
Oh,
okay,
so it's a cylinder wrapped around a ball.
That's right.
Just a ball.
That's right. So Archimedes proved that these are surface series equivalent. Or no, it wasn't Archimedes? Was it Archimedes?
All right, I gotta go. Have a good one, guys.
I also said, before you leave though, does Google Earth use a cylinder? Yes, Google Earth uses a simple cylindrical projection, also known as plate carré, for its imagery base, which is essentially a cylindrical map of the Earth.
For its imagery, yes.
Yeah, so you don't understand what a coordinate system. So the latitude longitude coordinate system is a celestial sphere, not an Earth sphere. This is why you're confused. This is why you're confused, dude. You think latitude and longitude's on the ground. That's your problem.
Yeah, it says it's a 2D cylindrical projection.
I love it. He tried to leave and I gotcha. He's like, "Oh, I gotta go now." Like, shut up. Yeah, that was a good couple hours of explaining that you're assuming the shape of the Earth. That was a good India.
Dude, we talk about whack-a-mole gish gallop nonsense right there, boys.
I especially love the part about the surveyors, because the only surveyors that are worth their salt are the ones who can certify a survey. Everybody else is just amateurs.
Yes, get the government-approved surveying. It's like the government cheese. Got to be good for you because it says USDA on it.
I was dead when the guy said, "Yeah, it's both." It's complete contradiction of logic.
Look, here's the funny thing is, that dude, he's obviously a globe zealot, right? So even though he got corrected at least 20 times, he's going to go debate another flat earther and say the stuff he knows is wrong anyway.
Just another brick in the wall.
See, you notice how, like, I said, yeah, we measure short distance. We measure a distance where we can eliminate curvature as a variable. How can you measure curvature as a variable? Well, because it's before the horizon. Well, I disproved that with reciprocal zenith angles. That's the conversation he actually wanted to have. Okay? He wanted to get off that horizon shit as fast as humanly possible. Because I've talked to this guy before, or I've heard him before. He's full of shit. He's just full of shit. He just thinks he can just say, we measure reciprocal zenith angles over and over and over and over again, as if somehow just chanting it gives it validity. But it's also called positive reciprocal zenith angles, meaning that the angle measured is greater than 90 degrees, right? You have diverging angles. So if you take the 90 degrees at one theodolite and the 90 degrees at the other theodolite and you sight them in, they'll end up tilted, and that difference will be greater than 180 when you sum the two theodolite readings. But it's necessary, if this is true, with their lumpy gravity, that you're going to have negative angles too. You're going to have angles measured that are less than 180 degrees. So what do you do with those measurements? Oh, you just pretend they don't exist. You just pretend they don't exist, dude.
I love how he doesn't want to give up the ghost and where he's getting his information from. Like, you literally search up on Google reciprocal zenith angles, and the only thing that comes up is, like, anti-flat earthers, right? It's like the first three things. It's like McToon, Jesse Pathelite, Roofy.
Well, that's the thing. That reciprocal zenith angle thing started with Jesse Kozlowski. It's literally like one of the when I first actually looked in the flat Earth, actively pursued looking into it. That was one of the very first things I found was his video about reciprocal zenith angles. The anti-flat earther. If I wasn't convinced by him then, I didn't know nothing. I'm sure as hell ain't gonna be convinced now. Because they're lying by omission. They're even contradicting geodetic surveying themselves. Geodetic surveying says that the level line it's only perpendicular to gravity at the point of the instrument, but then it also says that gravity is not perpendicular to the surface of the Earth. It also says that the plumb line's curve. So they have to go against their own rhetoric, right? That's written down in the books to even argue that. What was that dude's name?
You weren't paying attention? Because I wasn't.
Dude, I kick ass and don't take names.
That's what you spoke with him?
Yeah, what was the name? Yeah, I was talking.
Mac England. But with I, not with E.
He was in here this morning too.
Yeah.
Doing the same thing he did. Saying I can't present evidence because I'm in the car. My dog ate it. My dog ate the evidence.
Yeah, I asked him about, we spoke about refraction. What about that water behind the oil rigs? He said that's photons. That ocean.
Photons.
Photons, yeah. So when you observe something, you see photons. To know. Yep.
Oh yeah, Elijah, you're listening. Thanks for letting me hear that guy. I know you wanted to talk to him, but I started with him this morning and he had to go. I wanted a piece of him.
No, not really. I said all I wanted. My input was all I wanted. I just hate when somehow people don't understand or act like they don't understand what you're saying.
He's just fascinated.
Looks like we have a new guy. Welcome, the number one.
Your dog come in here? Oh, the dog. Oh, I didn't know this one come in.
Sounds like you're playing with the dog, Indio. Your hot miking is to let you know.
I swallowed dirt. Guess God made dirt, and dirt don't hurt.
I got it. I got it. I got it. So.
Information is posted in the chat, so you can look at that.
Looks like we got Tanner05 that just joined the chat. So I'm gonna have to get back to work here in just like 5, well, actually now 3 more minutes, but. Does Tanner have any roles?
Yeah, he's VC verified, baby.
Yo, Tanner, I just unmuted you, bro. Oh, you're never mind. You're VC verified. What's up, Tanner05? Welcome to the night shift.
What's up?
Well, nothing much, man. Just kicking it like Bruce Lee. Chilling with the Flat Earth family. What you up to, man?
Just playing Destiny 2.
Why are you playing that game? You should be playing Lost Ark.
Never heard that game.
That's the best game ever, bro. Or Warframe. Either one of those.
No, Destiny 2 is better than Warframe. Come on now.
Alright, I might have to get rid of you just simply because of that. No, I'm just kidding.
Wow. Warframe is just too broken. There's no, good balancing in there.
Dude, it's all about the OP, bro. All about the OP. I got a scythe in there that just kills everything in like one swipe. So freaking awesome.
It's just too broken.
Yeah, I know. I have just like a 8-year-old account, so can't get rid of it. Anyway, I'm gonna have to be getting back to work, but Drace is here, and he'll help you with all your globe troubles. You know, you can cry on his shoulder if you need to or whatever. Just kidding.
Yeah, I won't be staying very long, but yeah, please go on ahead. Tell me all your problems.
Or Timbo. Timbo's here. He's from Australia. Somewhere. Anyways, I got a jet. But I'll be listening.
So, what are your ideas about the shape of the Earth? So, Tanner, is the Earth a sphere or is it flat? What are your ideas?
I don't know. I just came here to listen because I was bored. I'm just more like in the middle, you know?
So you just don't know. You didn't get educated like the rest of us. You didn't hear the globe model like everybody else.
I didn't hear you. Sorry, my audio is a little low.
So you didn't believe in the globe model at all?
I did as a kid, of course.
What made you question the globe model?
Guess I don't like circles.
So you don't like circles, and that's why the globe... What?
Well, it's just like not natural, you know? It doesn't feel natural.
Yeah, I don't... That's a naturalist fallacy. That's not logical. Do you have any logical arguments for this?
No, that's why I come here to listen, you know? Just to like get talking points.
It's all good. It's all good. I highly recommend listening and getting a feel for the room just to understand what's happening and how things operate.
Okay.
So, is there anything that makes you think that the globe could be true?
I guess there's been like a lot of, you know, like everybody is backing. It was proven before, like, right?
How so?
Well, like there was an experiment done by people where they shined a light, and I don't know how far they were, but like the light didn't go through the hole. This was like made by flat earthers.
Oh.
And then like the light didn't go through the hole.
You're talking about the Jeranism and the flashlight thing where they burnt out the laser and didn't use the laser, and the flashlight isn't powerful enough to reach the other end?
I'm not sure. I don't remember what it was about.
Yeah. That's essentially
all I know, like that was like that basic premise.
When you have a flashlight, which is not a very powerful light source, and it's traveling through two holes. Whenever it goes through a hole, the light diffracts, and so it becomes even less powerful. And so when you're trying to shine a flashlight that far, it's never going to reach the other end. So that's a very inconclusive argument.
So it's hard enough to go through like one hole, but it's like impossible to go through two.
Well, if you just use the laser, it would be no problem, but you would still always have diffraction at the hole, which would decrease the intensity of the laser. However, what we have done is we have used many laser tests and infrared photography to show that the horizon isn't where it's supposed to be in a globe model. So we have falsified that idea. Have you seen any of those tests?
No, I haven't.
Okay, so let's. Have you seen any observations or anything that put the globe into doubt?
Like, what do you mean?
Like, for instance, seeing way too far, considering the globe geometry.
I think I see pretty fine.
So on the globe, if you were 1 foot off the surface of the globe, the distance to the horizon would be 1.22 miles away. However, if you look in live stream voice text chat, Heretic has just posted a meme for you where we can.
Oh, I'm on Xbox right now. I can't see anything.
No worries. I'll just describe it for you. We're seeing platforms, oil platforms, over 10 or around 10 miles away, even though the horizon should only be 1.22 miles away. So that's 10 times further than the geometry. And so if we calculate the globe size based on that horizon distance, if we assume it's just 10 miles away, even though it looks like it's even further than the furthest oil rig, which is 9.41 miles away, and we can see an island that's even 29 miles away. It's pretty far away. Let me double check that. So yeah, it's 29 miles away. And so if the globe was just at the horizon at 10 miles away, then the size of the globe would be 256,000 miles, which is far in radius, which is far bigger than what they claim. It's so gigantic that all of the known land of the Earth would just be a tiny little flat spot on that globe. So why are we seeing 10 times further than the geometry would allow?
And what did Drace just say? What did Drace just say?
Huh? I don't know.
Exactly. Just as I thought.
I'm just in here listening to people. You know? I'm just on Xbox, you know, grinding Shirochi.
You're not even doing that, mate.
You're on Xbox, just hanging out with us. Are you playing a game right now?
Yeah, I'm on Destiny 2.
How'd you find this server on Xbox?
Huh? No. Okay, so there's integration with Discord on Xbox. You don't have to connect your phone or anything. So I'm in the Discord on my phone. But since like I have my Xbox connected to Discord, I can just go over to like my parties and chats section of my UI, and then go to Discord, and I can click on a Discord and join a channel without like even having my Discord turned on.
Yeah, but how did you find this server from Discord? How did you find this server, friend?
They're a friend.
So, what was your friend's experience here?
Well, it was like a couple of years back, but you know, he would just talk a little bit, I guess. I don't know what he did, but he just showed me.
Took you that long to get here?
Well, no, I would always come in like some, you know, I've been in here before, but I just never really talked.
Oh, cool.
When did you join?
So what Drace was trying to tell you is that, okay, so have you ever heard the idea that when a boat sails away from you in the ocean, it disappears bottom first, and then the mast, and then the top of the mast, and then it disappears?
No, not really, but I get what you're saying.
Yeah, so that's the idea. So what's it disappear behind? Right, the horizon. What's it disappear behind?
I don't understand the question.
So if a ship sails away from you and disappears bottom first, right?
Correct.
It appears to be sinking down. What's it disappearing
Like starboard?
behind?
Like what side? Like not starboard side. Like hold on, I don't even
sailing
know.
away. The backside is the port side.
Stern.
Right.
Stern.
I'm not a sailor. I don't know.
There we go. Bow, stern, port.
Yeah, so the globe claim is that a boat will sail away from you, and because the surface of the Earth is curved, it's like going over a hill of water, right? So just like a hill, you disappear like feet first, then the legs, then your hips, then your body, then your head, right? In that order. So this is what they say a boat does. But that horizon is supposed to be like the edge of the Earth, right? The edge of the globe Earth, as far as you can see. After that point, the Earth is curving down and away from you, and you can't see that. This is the idea. So if the horizon is too far, right, farther than what the globe Earth model predicts, which Trace told you, is like 1.22 times the square root of the observer's height in feet. So for 1 mile, that's for a 1 foot elevation, the horizon should be 1.22 miles away. This observation, and many others like this, show the horizon is 10 times farther than what the globe Earth model predicts. Okay. So if it's 10 times farther and we used, okay, what's this horizon distance? What size ball does this match? That ball would be what they claim the orbital distance of the moon is. And the circumference of the Earth would be 1.6 million miles. And the thing is that people don't get, like, okay, so it's just a bigger ball. Well, everything, the entire cosmology, distances on Earth that are calculated, they're all based upon this radius value. And if that radius value is wrong, it's all wrong. Right? You can't have a different radius value. Because, like, if you try to look up what's the distance from New York to London, it'll calculate that based upon the radius of the Earth using spherical trigonometry. But if the radius is wrong, then that can't be the correct distance. So why if this horizon is the physical edge of a ball, and we can see past that, it can't be the edge of a ball. You understand? So we make observations that you can see way too far. Okay, not just a little bit too far, way too far. Orders of magnitude. It's not like, oh, I saw 10 miles farther. We're seeing, so like the longest distance photo is 275 miles. Okay, so think about that. If you were to drive 275 miles, how long would that take you?
Depends on the traffic.
Well, assuming no traffic, straight line, flat road, whatever. Right? So probably like 8 hours of driving.
Probably about 4 or 6 hours. Definitely not 8 though.
So if you drove 8 hours and you didn't go over the curvature of the Earth, what would you say about that? 6 hours, 4 hours. So think about you drove away from somebody. You're on a salt flat, and the salt flat is 275 miles long. You drove along that, and they could see you the entire time. Would you think the Earth is a ball?
I don't know. Probably not. I don't know.
So we have these observations, multiple observations of seeing at distances that are way too far. We have there's laser measurement tests. There's radio communication of 10,000 miles before satellites existed. So in 1918, during World War II, in Australia, they were picking up radio broadcasts from Germany. So they're like, wow, that's kind of strange. If the Earth's a ball, how are we picking up radio broadcasts in Germany? Well, we're at war. We don't give a shit if the Earth's a ball. We're going to make an antenna, and we're going to talk to Australia from the United Kingdom. And that's what they did. Okay, so 10,000 miles. You got to think. the circumference of the Earth is supposed to be 25,000 miles. So 10,000 miles away, you're like on the other side of the ball. So how are they talking from like? It's like talking to the South Pole from the North Pole. Like, how's that possible? You got a giant ball in your way, right? Radio waves bounce off the ground; they don't go through it. So how are they talking to somebody on the other side of the ball? So it's things like this. There's like multiple instances: seeing too far, radio waves, microwave, infrared, like you name it. There's all sorts of methods that you can use to test it, and every single one of them indicate that the Earth is not a ball and that it's actually flat.
Yeah.
So here's the fact, right? The surface of the Earth is mostly water, right? They say 70% water. So if the water does not have a curve to it, can the Earth be a ball?
I don't know.
You think you can have a ball that's 70% flat? That wouldn't be a ball, right? That would be something weird.
I guess so, yeah. Would be weird.
Yeah, it would be a weird ass shape, like a freaking half an egg or something. But this is what we're confronted with, right? So they say that the Earth is this, that, and the other thing. But when you go out and test it, in reality, it's not that. And then you come back inside, you watch TV, and they're like, oh, you watch the news, they show a spinning ball in the background, they show some space pictures and a bunch of other stuff, and you're like, yeah, that's interesting. Let me go outside and test what I just saw on TV, and it's not that. And, so this is why flat earthers exist, because we're actually observing reality. And instead of being told, oh, it's just a ball that's too big to see. The Earth is just a big optical illusion. You're not really seeing what you think you're seeing. If you were special, you could get in a big, giant rocket dick and fly to space and see the Earth as a ball. Yeah, that's a cool story, bro.
But what about the people who say that since the other planets are, globes?
Other than what? When you say other planets, other than what? What are you talking about?
So, like, other planets, like, are globes.
Well.
So,
Earth
like,
isn't
what about people that
isn't
say,
a planet, and why would you associate them? Why would you associate the Earth with those things in the sky? What's the common factor? What's like? Why would you think that? Oh, where I am is the same as what's in the sky. Why would you think that?
Also, they admit they destroyed the technology to take the rocket dicks beyond low Earth orbit, and in low Earth orbit, the horizon appears flat.
So there's like this association people have. They go, oh, like, because they're told this is due to just repetition, right? That, oh, we look in the sky and we see a bunch of circles, therefore the Earth must be a circle too. Because you don't actually see spheres. But even if you did see spheres, it wouldn't even matter. Because there's nothing to indicate. If you take out, it's like how we tell things are the same, right? To put them in the same category of things, right? Oh, I want to say that Earth is one of those things. Okay, so what we do as human beings, we observe the same thing. Now, if I take a telescope and I look at one of these dots in the sky and I go, okay, let me look around on Earth to see if I see the same thing, and you don't.
Yeah.
You've never looked at a planet and be like, hey, that's just like Earth. Or you've never looked at Earth and been like, oh, that's just like a planet. No, you don't. Nobody thinks that way. Or nobody, like, there's no obvious similarities between the two. So it's a misassociation. It doesn't logically follow that because you see spheres in the sky, the Earth is also a sphere. No more than if you see just trees, you're also a tree. Right? That doesn't make any sense. We don't think Earth is a disk floating in space. Okay? There is no outer space vacuum. That is a horseshit story.
What would you say to the people who come into the Discord and say that you're just spreading disinformation?
I'll ask them what part was disinformation.
Like they say that you saying like, none of it's real.
I didn't say it. I didn't say that. Didn't say what was real.
I was just like saying like a globe, like it's not a globe. Like they came in the Discord and they were saying like it is a globe.
Okay.
It just like.
I mean,
telling the truth is misinformation now?
No, disinformation. Like, what if they came into the Discord and they were saying you're spreading disinformation?
Yeah, I'd say, yeah.
So, because disinformation is...
I'd say be specific. What specifically did I say that was disinformation? I'd say be specific.
Hyper-specific.
It's nothing I just said.
Disinformation is like information with the intent to mislead people. So, like hoaxes or propaganda. That's what disinformation is.
So disinformation can be true?
No. Misinformation is when you don't know that it's not true.
Yeah, but you have you have to now show that it was false information intended to mislead when that has none of that has been shown. Everything we have told you is verifiable in reality.
Everything.
Well, no, that's what I was asking. Like, if somebody came into the Discord and then said that to you, what would you respond with?
Yeah, I'd ask them for a specific example of the disinformation, and then when they tried to give a specific example, I'd give affirmative evidence that what I said is absolutely 100% correct. Like, for instance, the photo I talked about, it's a world record. It's in the Guinness Book of World Records. You can go look it up. The wireless transmission I talked about, there's literally a plaque in Australia about it on a rock, carved in brass on a rock, because it was officially done by the government because back then Australia was still a British Commonwealth, right? They were part of the British Empire, and troops had to go to to fight in the trenches in Europe, and like if you wanted to communicate any other way, you'd have to sail a ship all the way to goddamn Australia, say, hey, we need more troops. And they'd have to sail a ship all the way back to the United Kingdom. It was a lot more efficient to just go, hey, let's just talk to Australia and say, hey, we need more troops. Send more troops here. So the records are official teletypes that were in between the defense minister of the United Kingdom and the defense minister of Australia. So everything I say can be backed up. Period. We don't say things. That's the one thing about this place. We don't say things we can't prove. Okay? We're like, I think you would call it like, we're empiricists, like super empiricists. Okay? We like, our position is claims are not evidence, right? So the claim that Earth is a planet, that's not evidence Earth is a planet. Claims that you can go to outer space, that's not evidence you can go to outer space. Claims that the Earth's a globe, that's not evidence it's a globe. So we go with evidence. We don't go with claims. And evidence that could be has to be testable, verifiable, and repeatable. Right? So claims that like I can't do or nobody can do, right? Oh, just go to space and look at the ball. Well, first of all, only 27 people even claim to have done that. So that's a very small club, right? And no one can test or verify any of that stuff. You have to just trust the people claiming to have done it. It's analogous to a bunch of people saying, we saw Bigfoot, we saw the Loch Ness Monster, we saw, you can't prove it.
How would you
just have to believe it.
Just a second. Even claims that the Earth is flat, none of us took as, oh, that's just true just because someone said that. We went and tested it and found out that our previous belief was false.
So we're testing the globe model and make specific predictions. It says, if this, then that, right? And that's how science works, right? You have a model, and then you test it to try and falsify it. And then if you can't falsify it, it becomes, that's evidence that it's likely true, right? So we go out and we do observations that actually falsify the globe. I've personally done my own observations. I've watched ships sail from Boston Harbor that never disappeared over anything. Right? They're supposed to go over the edge of a ball. I've seen it. Watch the ship go from 6 miles away, sail out to 30 miles. If you look at the globe math, like what does the globe predict to happen? Says that at like 15 miles away, I shouldn't see the ship anymore. But I've seen it 30 miles away with the naked eye. It should be 420 feet under the curve. That's a 42-story building. It's not like it's a little bit. It's like if I can't, and the thing is, it isn't like, oh, the ship was sticking up over the curb, because there's no ships that are 42 stories high. They've never built a ship that high, that's that tall. So it can't be that. So, like, just by the process of elimination, what do you have to eliminate? Can't be the ship, can't be the distance, can't be anything else. It has to be that the gold model is not correct.
So what if, like, I don't know, like if there's like a community like leader, I guess, if there is like who's like if you were to like pool together money, right, and then like one person, like you're the community leader, went to space, like just hypothetically, and he said, oh, it is a globe. How would that affect you personally?
I wouldn't give a shit.
Yeah, that would be a tough one.
Yeah. There's like,
like
so what am I? So what are you saying? That if some other person goes to the so-called region called outer space, and looks at the Earth and says he saw a ball. Now I'm just gonna go. Oh yeah, I'm gonna believe you, and I'm gonna disbelieve my own experience.
That's what I'm like, you're a community leader, like if there is one.
There's no such thing as a community leader, and it wouldn't matter, because that's an appeal to authority. The basis of the whole premise is a logical fallacy. Okay, if community leader does X, therefore X is true. No, that's not how it works.
How do the words of one man change the results of thousands of experiments and measurements?
In the experience of everybody on Earth that's ever lived. You understand that everybody on Earth that's ever lived has never perceived living on a ball. You've never gone outside and been like, man, this looks like a giant ball. You're never like, man, it really feels like I'm spinning. Like, nobody's ever done that. Okay, so you like, if you're like, oh, I'm gonna go by the anecdotal experience. What about them?
We're going to the sky again?
Yeah, I mean, we can go back there, but Earth isn't in the sky. See, this is part of the mental conditioning, right? So this is part of the mental conditioning, that somehow you can determine what the Earth is by looking away from the Earth. Think about that for a second. That's like trying to figure out what's wrong with your house by looking at your neighbor's house.
Well, I've done that where they got this similar house, and I was like, "Dude, how did you do that plumbing again?"
Well, it's like how some species evolve the same way, like, and they have similar features. Like, so you would expect planets to like mostly be a ball.
Evolution, oh boy.
Well, I mean, body morphology, like that whole field of science is getting turned on its head. I mean, this is new so-called science in the last 5 years, but it has nothing to do with like genetics or heredity. So if you go, there's a biologist named Michael Levin. He's been on Joe Rogan and a bunch of other stuff. He's done experiments which demonstrate that body morphology, meaning the shape of a body of a living creature, is not from the genetic code. It is not hereditary.
What do you mean? Explain.
They don't know where it comes from.
How so?
They don't know where it comes from. They did experiments with
when you say like
body morphology, the shape of a body.
Yeah.
Right? Toes, hooves, tails, heads, that shit. The shape of your body. Because you said these species
I believe the results
same, right?
of one man.
It's not a man, it's a team of people. It's a team of people.
So if this entire Discord, if we all went to space, right, and then it came up that
you can't go to a place that doesn't exist. You might as well say if we went to Narnia and saw a talking lion.
Okay, so okay, I didn't have that information before. So
you're begging the question of the thing in question.
Mm-hmm.
You need to prove your globe first, then outer space, before we're going to be able to go there.
Well, how about you?
Okay.
When were you in outer space?
Yeah, how many times have you been to space?
That's my new question in this case.
Never. How many people do you know have been to space? That you know personally?
Like I know personally? It's a good question.
It is a good question.
Okay, how about somebody you know personally that knows somebody else personally? Third person. We'll get 2 people removed. And I can do this on and on, right? You're going to have to get like to 5 or 6 people removed till you even know. We're talking in the last 70 years, there's 600 people that claim...
When you say no personally,
At
like
that
just
point,
men, or like
you're as far removed as every single person on my country.
Okay, in the last 70 years, there's 600 people that claim to have been to space. You know how many people have lived and died in that time period? Probably 90 billion people. Okay, so this small little fraction of people, this small, tiny, infinitesimal, to the frickin' 8th decimal point amount of people, we're going to base our entire view of reality based upon what these very small fraction of people say.
That's crazy, but
more people claim to have seen Bigfoot than claim to have been to space.
Way more.
More people claim to have seen aliens and the Loch Ness Monster and fairies and ghosts. I mean, you can just name it, right? So
anything.
Yeah, anything.
It's a very, 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 very exceedingly small club of people that are like dictating people's views of existential views of reality, which is like, to me, that's insane.
There's more people catching a wave right now.
That's Catholic. There's more people face planting in the bathtub right now. Okay.
Yeah, it's probably 100,000 of them face planted in the bathtub.
Yeah, and essentially what you're doing is you're appealing to the future. Sometime in the future, maybe we could go to space and see my delusion. But the problem is they've been promising colonies on the moon since 1978. And we have no commercial space travel. We cannot go outside low Earth orbit because they admit they destroyed.
We do have commercial space travel.
No, they destroyed that technology. So-called commercial space travel today is just traveling high up into the air, still below the clouds, not high enough to go even to the ISS, and which is, by the way, considered still to be in low Earth orbit, and they admit they cannot go beyond that.
Because it would be super expensive to go beyond that.
No, because they destroyed all the shielding technology and they would be lethal and kill anyone who tried.
It takes an incredible amount of money to reach escape velocity on Earth and then come back.
It's not that. It's not that. They admit it. I can give you the video from NASA themselves where they tell you that they don't have the shielding technology to be able to go beyond low Earth orbit. It would kill those who tried.
What if I told you this, right? That you can go to Middle Earth if you run around if you spend a bunch of money, run around the world and arrange crystals in a certain way, and that 600 other people have done it before. Would you sit there and spend a boatloads of money to do that?
Well, it's Middle Earth.
Exactly. What is it?
Exactly. Space is Middle Earth, dude. It's a story. It's a fairy tale you saw on TV.
So you're saying we live in a Truman Show?
No, I wouldn't call it that. I actually don't like that movie. But
there is a lot of truth in that movie. I'll give you that. I mean,
yeah, I guess probably that's why I don't like it. It's going to do too much truth.
A little too much, right? Yeah. What's that saying from the movie? Something about your reality is what you perceive it to be. Yeah.
So in your actual experience of life and experience of everyone you've ever met, your family, your friends, your relatives, everyone going back to the dawn of time, they've only experienced the Earth. They've never been anywhere else. But starting 80 years ago, they started telling people, well, we can go outside the Earth. There's an outside out there somewhere that we can go out to. And then we can turn around and we can look back at the Earth and we can see the whole thing.
No. Just give us millions, billions.
You're crazy.
Yeah, just give us money.
You're crazy. I'm not giving you any money. That's crazy talk.
So, no one had that idea previously. I mean,
right.
The idea is that people had the only way you're leaving this planet is in a fucking casket. Right?
Right. That's the only way you're getting out of this place, man.
So what do you believe is outside of Earth?
I don't think that question has any actual meaning. There's no outside. Because it goes on the premise that like there's something enclosing the Earth, that the Earth is embedded in something that's larger than it. Right? Some space, right? There's a space and then Earth is inside this space. I don't think of it like that. I think there's Earth and then everything is within the Earth. Not as in underground, but within this realm of existence. And that there is no outside. There's no outside you can go to. There's no looking back. There's no astral projection. There's no hookers on Mars. Like all that shit's fairy tales.
Oh man, you're killing me.
I mean, I wanted to you've seen Total Recall, right?
Oh yeah.
Oh yeah. I want the three-titted hooker.
And the three-titted hooker. I just watched it. Maybe
that might be kind of useless though, because I only have 2 arms. So the third boob is gonna get lonely.
It's yeah, that was a shocking scene. Even now, it still holds its fantasy. It still holds its fantasy.
Okay, so let me just sum this up, right? So on one hand, you have the globe Earth claim and a bunch of stuff on TV and in books and claims and like the tradition of somebody's telling another person and then telling another person and then telling another person, and everybody just believing it. Nobody has any firsthand personal experience of any of it. And they have to believe in the claims of strangers. And then on the other hand, this is what we say. Go out and test the globe model. Go test their claims. And you're going to go out and find out that what they're saying is a bunch of bullshit. And I know that's hard to, it might be hard to believe or hard to swallow. Maybe. In light of the last 2 years, probably not as hard to swallow as it used to be. But I mean, you don't have to believe us. We're not asking you to believe anything we say. You can just go out and test it yourself. You don't have to rely on us one iota. You don't have to rely on any other human being. You can just go test it yourself. There's dozens of curve calculators on the internet which will tell you how much curvature there should be, what's the drop of the horizon, what the horizon distance is, what the horizon dip is. All these numbers, you don't even have to know any math. They're all made by Globers, so it isn't our calculator. It isn't like flat Earth math or whatever you would call it, right?
No, it's not that.
And you can just go out and do a test. You just need a large body of water, a mirror, you can just go to the ocean and watch a ship like I did, right? There's a website called marinetraffic.com. You can go on that. It tells you the position of boats. You can go out there and you can observe a boat and draw your own conclusions. Right? Or you can just rely on the television set, let them tell you what the fucking universe is all about and why you're here for no particular fucking purpose. You're just a random fucking clump of fucking atoms, right? That was randomly started from nothing, 90 billion years ago. You could go believe in that. I mean, I don't personally care. But if you want to believe in that, to me, it's utter nonsense. It just is. It's just utter nonsense.
Well, I always tell people, man, you gotta go learn the globe, man. Learn what they're telling you about the globe. And everything about it, man. Spin, rotation, circumference, diameter.
Yeah, that's actually a good point, man.
Yeah. And I always bring that up. It's just like, dude, go out, check it out. You live on this supposed globe, man. Go check it out. Let me know what you got.
We don't want to convince you of any new belief. We're not here selling a new religion or a new cosmic view. We just want you to test the world for yourself so you know for yourself. And then you can come to a logical conclusion instead of having to take everything on faith and being lost in that belief system.
And Tanner, man, you got the crazy hiss coming out of your mic, man. I don't know what's up. You have a hiss in your microphone.
Yeah, he's on the old Xbox.
No, I'm on Series X.
It's a super hiss, man. I don't know what it is, but check it out. Figure it out.
Yeah.
Like, is it coming in and out?
Yeah. No, it's just like when you speak, you can hear like
Even
a
when you
background
don't
hiss.
Even when you don't.
Oh yeah.
Okay, so what it is there's
turn your
noise threshold.
Turn your sensitivity down or up or whatever.
It's not bad.
Just a tiny bit.
Yeah. Anyway, I'm just letting you know that
I can deal with it. I mean, I've dealt with worse.
It's fine. I'm just saying, for down the road, man. If you want better audio, check that hiss out.
Yeah, he's an audio
nothing to
guy.
do with audio. It's just a fan. Like when I go over here, can you hear it?
Yeah, I can still hear you.
Yeah, I can tell it's a fan now, though. Like, yeah.
All right, it's a fan.
Discord just has different audio to Xbox. So if you were talking to me on an Xbox, you wouldn't be able to hear it.
Okay, cool, man. Well, welcome to the server, man. Welcome to Earth. That's where you live. And you can check it out, man. Don't believe us. Thanks for dropping in, though, man.
Yeah, so, I mean, like, everyone in here, we used to think the Earth was a globe. We used to be all into space stuff. I mean, I still watch space stuff. I mean, but to me, now I look at it properly, right? There's no possibility this is ever going to happen. It's fiction. The same way that there's no possibility that I'm going to Narnia or Mordor or any of those places, right? Like, they're just fantasy places. They're works of fiction.
It becomes a comedic fiction because the more you understand physics and the more you understand the contradictions within their claims, the funnier it gets.
Yeah, so I mean, almost all flat earthers thought flat Earth was ridiculous and tried to like debunk it, right? They tried to like debunk the flat Earth. And to debunk the flat Earth, you got to learn what the globe model is. And most people, they don't know it at all, like at all. They don't even know why they believe it. They don't know what the radius is. They don't know what the circumference is. They don't know how like it derived the distance to the planets or the moon or how or their size is.
Light. I mean, there's so many little things you need to know about this globe claim that you got to just check it out yourself, man. Don't believe us. Thanks for dropping.
Let me tell you something. I've debated probably thousands of people in this Discord, Globers of all education.
This was a debate. I was just coming here on the middle of the line.
No, I'm not. I'm just giving. I'm not saying we're debating. I'm just telling you something.
You always have to debate like on the other side.
From PhD level down to ninth graders, that whole range. PhDs in physics, astrophysics, cosmology, all the way down to. And do you want to know how I win every debate? And I'm not kidding. Win every debate. I just ask for their evidence. That's all I have to do. All I have to do is go, what's the evidence for that? And it's over. And it's literally over at that point because they don't have any evidence.
I got calculations, though.
They got calculations. They got stories. They got freaking
fallacies.
Witnesses, right?
Witnesses. We got a bunch of smart people.
So the Coriolis, I always use this as an example, the Coriolis effect, right? It's supposed to be when you shoot a gun, there's a Coriolis effect that the Earth rotates out from underneath the bullet. Go, okay, what's the evidence for this? Nothing. There's no experiments, there's no demonstrations, there's nothing. Crickets. It's a bunch of equations on a piece of paper that a bullet should do this if the Earth was spinning. But when you actually look for the evidence to support that idea, it doesn't exist. Doesn't exist in any form anywhere.
I watched a guy shoot a .50 caliber straight up, and then he ran inside of a concrete shed, and a bullet landed right next to the shed, man. Yeah, it took like about a minute, man, for that thing to come back down too.
Yeah, there's one of those on YouTube where he shoots a .50 cal straight up and fucking.
It takes a while to go back, but it does come right back. And they were running.
Well, of course.
Okay, let's get the hell out of here.
People can't even prove simple things like, okay, prove the Earth is rotating.
Well, it's like if you like if you like everything like what comes up has to come down. Because a bullet can't reach escape velocity.
Okay, that wasn't the point of the experiment. We were talking about Coriolis effect.
When does helium come down?
When does helium come down? When it's exhausted its gas properties inside of a container?
See, I'm not a
when you say
science major.
escape, when you say reach escape velocity, do you even know what you're saying?
Exactly.
Mm-hmm.
Do you know what the equation for escape velocity?
I do.
The velocity.
Could you remind me?
Well, yeah, I'm gonna tell you. So the equation is what the equation means. Okay, equation is the velocity it takes to escape to infinity. To infinity, not just like off the surface of the Earth, but to infinity.
Where does the infinity come from?
What do you mean?
Just where does it? Like, how does that?
That's because you have to be going a certain velocity to reach some distance, right?
Mm-hmm.
So, given the gravity of the given Newton's universal law of gravitation, there's the mass of two objects, and when does the force exerted by the rocket when is it greater than the pull of gravity? Right. So when you take off, the gravitational pull is going to slow down your rocket. Right. That's why you have to constantly accelerate. But when you have to accelerate, there's a point where a velocity that you can reach where in any normal period of time, the Earth is not going to suck you back into it. Now imagine a universe where it's just you and the Earth. Right. If you fire the rocket till you reach so-called escape velocity and shut the rocket off, will you get pulled back to the Earth? Eventually. Because you're going to attract the Earth, and the Earth is going to attract you, so eventually you're just going to keep slowing down, and eventually, billions of years, trillions of years, however many years, you'll fall back into the Earth. So they have an equation to figure out how fast you have to go so that there's no way that basically takes an infinite amount of time for the Earth to pull you back to it. That's the escape velocity to infinity. But the infinity is a distance. But, the heliocentric bullshit, space and time are the same fucking thing, so that doesn't matter. They're just interchangeable. But the so-called escape velocity of the Earth is, 27,000 miles per hour or something?
Not sure.
25. 25 will get you there.
But but the point is, we're talking about mathematics, right? So what's your evidence escape velocity exists even in the first place? Like in reality, in the reality. Look, let me tell you some facts. Nobody's ever observed an orbit. No one's ever observed the Earth rotating, causing day and night. So these things, these are ideas, these are concepts in our heads. But no one's actually ever observed this.
That's true.
Okay, you could say, we watch the orbits of the moons of Jupiter. No, you don't. You see the so-called moons of Jupiter going across the face of the moon, then they disappear. Then sometime later, they go across the face of the moon again, or face of Jupiter again. Then they disappear. You don't actually see an orbit. No one's ever seen an orbit of anything, ever.
Yeah, man, we've never seen an orbit. Nobody here's ever been to space. Nobody here's ever checked out the Earth from a vantage point where you can, hey, look, check out the ball, man. Check it out. No, it's never happened. It's never going to happen.
So the other thing we do is we distinguish knowledge from belief, right? So, we believe things, right? You believe there's orbits. You believe escape velocity is a thing. You believe there's things in space. People believe these things. They have no knowledge of these things. So there's a belief in orbits, but there's no knowledge of an orbit, which is a totally different thing, right? So there's a belief the Earth's a globe by, let's say it's, 90% of the population of the world. Probably ain't, but I'll just say that just for ha-has. But nobody knows it. There's only a very small people that claim the knowledge, right? So the people that say they went to the moon claim they have knowledge, have been far enough away from the Earth to see it as a ball. Those small 27 people, those are the only people with the so-called knowledge that the Earth's a ball. Everybody else are just believers. Everybody. Your teachers, professors, people that work on satellites. We've had some in here. Had a guy worked on satellite, thinks he smashed a satellite into a comet and flew it back to Earth. He's a real guy. He worked at NASA. I looked his shit up. He exists. But when I asked him, how do you know where the satellite is? He says, they tell us. Who's they? Who tells you where it is? Oh, the NASA Deep Space Network tells us where it is. So you don't know where it is. You get something on your screen that says, yeah, it's here. It's facing this way. It's oriented that way. It's going this speed, and it's this far away.
Well, isn't that the same thing with the ship website?
When I
you were talking about?
Sorry, I wanted just to.
Yeah, but I can also see the ship, right? I can see the ship.
Yeah, but you can see the satellite as well.
No, you can't. Satellites are way too small to see with a telescope.
Like if you had binoculars. Or not, sorry, not binoculars. I just, had a brain there and playing Crucible and trying to focus on two different things. Telescope.
Telescope.
Yes.
They're too small to see.
The ISS, supposedly, it should be big enough to see.
Yeah.
But that has problems because it's too big.
Yeah. There's many problems with it.
The ISS is like 5 times too big or something like that for its elevation and size.
Yep.
Because the observation I just told you about, seeing 275 miles, that's like the orbit of the ISS. But what can you see from 275 miles? It's so far away you can barely see a 12,000-foot mountain. But you think you can see a 300-foot frickin' tin can the same distance away? Think about it, dude.
It's kind of
that's so. Hold on, let me say one more thing. Think about this. We could go into reality and test this shit, and then compare it to what they show us, and nothing matches up. It's really that simple.
Yeah, let me give you a physical example. Like if you take a piece of hair from your head and you look at it real close, you can see it. But the further away you move it, eventually it becomes indiscernible. And then even if you got a telescope, the further away you move it, eventually it becomes indiscernible.
Reality is right in front of you. You can go check it out, man. Don't believe us. I don't know if you live near the ocean or whatever, mountains, deserts. Yeah, you can check it out. Reality.
I can't right now.
Excuse me?
I can't right now.
No, not right this minute. No. But tomorrow, next day, this weekend, whatever.
Yeah, the Earth ain't going nowhere, man. It's really not a hurry.
Yeah, the Earth's just sitting there, man. Just sitting there nice and still for you to go check out.
Have you ever tried looking at the other side? Like
we were already on the other side.
No, where you're not now.
Did we drill a hole?
Yeah, we're not now because all the other side was false.
Well, yeah. But whenever you're people that debate, if you really want to be good at debates. Right, I'm not. Me personally, I'm not. I'm never good at debates.
Me either, man. That's not my wheelhouse either, man. For sure.
Look, if you hung around here, you'd find out that just about every flat earther on this Discord knows the globe model better than the people that come and defend the globe.
100%.
Yeah,
we know it inside out, upside down, backwards.
That's why Flat Earth Dude said you should learn the globe model, because the more you learn about it, when you really understand what it is, you're like, this is a bunch of horse shit.
This is crazy talk shit, man.
Because the claims get more and more absurd the deeper you dig.
Yeah.
Do you know how fast?
So how did you get into the Flat Earth?
Just a second before we answer.
Go ahead, Trace.
The deeper you dig, the more contradictory it becomes because it's more compartmentalized in different fields. So you end up with the extremes of each field contradicting each other, but they're all accepted as the holy truth as a whole.
The high scientist minds of the world have set the parameters of what we can go out and check in reality. I mean, we can measure it. We can, go out, check out water, how it behaves. Water's cool. Because last time I checked, man, it doesn't stick to a ball, man.
Water just makes up like whatever it's in.
It does definitely go level 100% every time. I mean, it'll fill the container. Yeah, absolutely.
Okay, so I'll give you a globe absurdity. In the globe model, level is curved.
No, get out of here. Did they?
Yeah. Yep. Also, in the globe model, a plumb line is also curved.
Oh my goodness.
So I came up with this 2 days ago. It's pretty funny. So now when you level a building, you're actually making it curved. You're not flat.
There you go. Absurdity. So yeah, there's some humor in it. Once you get on the other side, you go, "Oh my goodness, those people are saying the universe is expanding at 95 million miles a second." Well, my question is, what is it expanding into? Got any evidence for that? I didn't think so. Okay.
Metaspace. It's expanding into metaspace, and then we just keep adding like, what's that spacing? And that space expanding too, right? So then we have metaspace. And it's metaspace all the way down from there.
Yeah, but then you get astrophysicists saying, like Eric Lerner from the Lawrenceville Plasma Physics, saying the universe is not expanding at all. So you have them.
Where do you guys live by chance?
So you
Southern California.
Have to just take
I'm in SoCal.
Whatever you like.
Yeah, Southern California.
So, have you ever went to a place where there's not as much like light pollution?
Yeah, I do camping out in the desert here. It's called the Mojave. It's kind of big. Check it out.
And like you've looked up at the night sky.
Oh, thousands
without the light pollution.
Yes, thousands of times.
And you're saying like
for me,
like that's not there.
No, those lights are there, baby.
It's there. Why would
the sun's there, the moon's there.
Because you just said like the other planets just don't exist.
Well,
no one said that at all.
Your idea,
they're not what. Listen, there's a story on what they are. Like you have this story. Oh, the planets are spheres. There's actually no evidence for that.
Yeah, you have a story that says the spheres are this big, they're like this, and these are spheres, and they're this
they're
far
rocks.
away.
You can land a robot on it.
Yeah, they have all these stories that you believe, and when you look at the stars, you interpret what you see through these stories.
They're just stories, man. It's just like, Harry Potter. It's no different, man. It's just a story, bro.
So think about it like this, man. So what you basically just did is you pulled up, you're like, my car's a Honda. I'm like, no, that's a Ford. And you're like, so what are you saying, my car's fake?
I don't understand the comparison.
It's an interesting analogy, man.
Because we said there's stories about the stars and the planets are wrong, and you interpreted it as us saying they're fake or that they don't exist.
Well, when you said they're wrong, I just quite didn't understand what you were meaning, so I just assumed you were saying they don't exist.
We all
can see them.
The same things, bro.
We all see the same
things, but the globe just doesn't fit the things everyone.
So I'll give you a story. So that when you look up in the night sky with no light pollution and you see that rift, right, where it seems like there's a bunch of shit all in the middle. What do you think that is? The stars. When you look up at the stars and you see.
You ever seen the Milky Way? Let me ask you that first, man.
Yeah, the Milky Way. Right? Where there's a bunch of stars in the middle?
There's like this big band
not
of lights. It's a big band of lights, man. It covers about, what, like
You're talking about going outside the light pollution. You've never seen that?
That's what I was asking.
Yeah, I've been out there, man.
You're asking us about things you've never observed.
Correct.
Yes, that's what I was asking.
Yeah, that's what he's asking.
Okay. Yep. Oh, you can't.
Well, I'm not old enough to go anywhere I please, so that is my bad.
Okay, that's okay, man.
Can't go outside.
No, there's too much light pollution here.
Hey, I'll tell you what, man. I've seen guys with Canon cameras, man. They got a setting in there, man. You can tweak it, and you can, do a time lapse of the sky, and you can see the Milky Way. Even with, he did it in Los Angeles, for fuck's sake, man. I was like, holy shit! The guy got the Milky Way.
Well, it's bringing it up because that's actually not the Milky Way anymore.
Yeah, that's what I would have.
What?
No, it's not the Milky Way anymore. Now it's the Milky Way swallowing up a dwarf galaxy, and that's the gas.
Yeah, you're seeing the other galaxy that's being swallowed up there.
Fuck?
The Milky Way is not there, according to.
You're seeing the Galaxy S21 Ultra.
Yeah.
Yeah. So, wow, they don't call it the Milky Way anymore.
So there's an example, like
changing, bro. You got to keep up.
Well, so that's what I was saying at the illustrated point, right? So there's a story, and there's a story that band that we saw in the sky was the Milky Way, and they've been telling that story for about 200 fucking years.
Right.
Hey, there's no use crying over spilt Milky Ways, bro.
Yeah, and now that story has changed. And just because the story has changed doesn't mean that we don't all observe the same thing, or that the original story was correct, or even that this story is correct, because it's probably not either. So, this is where we're at. We're at there's a bunch of people, they're spinning yarns.
There's a bunch of people telling stories, and we're like, wait a minute, man. What evidence you got for that story, bro? What do you got? I appreciate it. Thanks.
Bunch of Baron von Munchausen's, man. That's all they are.
Von Munchausen, yeah.
Baron von Carpet Muncher, homie.
Hey, Tanner, let me ask you, man. You ever seen the movie Back to the Future? Wasn't there?
I have, but it was a little long. It was a long while ago.
Yeah, okay, cool, man.
Hey, Tanner, you ever seen Black Swan, man, on weed?
I haven't, no.
He's on Xbox. He can't see the chat.
Latter-day Saints, man.
What up, G?
What's up, dude, man? I'm like, dude, I know that. Dude.
No, weed's illegal where I'm from.
That sucks to be you, bro.
All right, I told you I'm
okay with it. I don't really like, taking stuff that puts me out of my own mind.
Yeah, don't do that, man.
Yeah,
I know you don't want to do that.
Take in some Globe, man, and you'll be fine. Take some Globe.
Globe's the best quality Globe you could ever
rules, dude, man. You got to get some Globe, bro. Globe is.
If you want to get really fucked up, take some Globe, man.
Dude, you guys want to rock the world? You got to get some Globe, bro.
No, NASA space crack is the best.
Wait. I tried the NASA space crack, but the 2022 strain wasn't that good. Yeah. It was weak. But hey, they're stepping up their game this year, man. I heard 2023, man. They launch rockets every other day now. I don't know if you guys noticed, but
I find it odd you just said I don't like shit that puts me out of my mind. Right?
Right.
But you believe in the globe, which is completely a mental construct.
How is it a mental construct?
Because you've never experienced it.
You've never experienced the globe, period.
So, when you think of Earth, right, you're not going based upon a memory or, what you're observing. You have to go into your imagination. Because you're either going to experience a thing, right? You're going to remember a thing, or you're going to imagine a thing. You only got three choices.
I like
so. Since it can't be the first two, it has to be the third one.
He could remember an animation, which is pretty.
Or a horse. Have you ever?
Yeah, you can remember someone else's imagination.
I love the analogy of a horse, man. If I told you, hey, man, horses are real, and you're like, yeah, no shit, Sherlock. And I'm like, now if I showed you a picture of a horse, would you be like, hey, man, 100%, that's a horse? Right? You get there's 100% comparison.
I don't understand what you're trying to get at.
Versus, dude, you've never seen the globe with your own two eyes. Okay, that's my point. You've never
even though I walk on the Earth.
You walk on the Earth. No shit.
It's not a globe.
You only experience a flat, stationary Earth. That's your local experience. Even a physicist will agree that the Earth appears locally flat and stationary, and they extrapolate that it's actually moving and that it's actually curving.
Like if you have like a ball, like just a ball, you know, like a circular ball,
like a baseball,
and then
soccer ball, a golf ball,
anything to that, yeah.
Yeah.
And then you let's say it's just huge, like humongous, right? It takes up the entire state of California.
A ball too big to see. Yes, we know.
It takes the entire state of California. It's still a ball, right? It's still a ball. And then, so you go to California where the ball's at, and and then you look at the surface of the ball, like where you're at, and you can't tell that it's a ball, looking like that. It'll look flat, and you put your hand there.
Sorry. Your premise is pretty flawed. If that ball was just the side of that state, you would actually be able to discern that it's obviously a ball.
No, you're at the ball. You drive
you
up
made
to
the
the
ball too small, my friend. The ball that we're looking at is actually a radius of 3,959 miles, and we have used that ball, not your tiny little ball that doesn't exist in reality.
It was a
Neither does the other ball.
So, do you know
we understand your argument that we're on a ball that's too big to see, right?
No, I'm just saying you can't discern the curves by just looking straight at it. It'll look flat.
You can.
That's level, great. Man. Even if we take that as true, so what's the evidence of the ball that it looks so flat? I mean,
no, when you're close up, it's going to look flat because you're looking at just one thing. You're right on the ball. You can't see everything. You can't see the whole ball because you're right at it. You only see that, and you can feel it too, but it feels flat because it's so big.
Yeah. So have you ever been far enough away where you saw a ball? Have you ever seen the Earth as a ball? Have you been? It's your constraint, right? If you're too close, you can't see it as a ball, but if you go far away, you can't see it. Have you ever been far enough away where you see it as a ball?
I haven't, no.
Okay. Of course. So, like I said, it's in your imagination. It's not an experience that you've had. You can conceptualize and imagine a situation in which the Earth that you're walking around on would transform magically into a ball, that if you were far enough away from it, yeah, you can construct that idea in your head. But that's just a mental construction. It's not reality.
You have been listening to excerpts from the 24/7 Flat Earth Discord Live YouTube channel. If you would like to join the discussion, simply type in your address bar discord.gg/flatearth. Thanks so much for listening.
lines. I thought they were curved. I thought it was like a toroidal field, right? It's like, oh yeah, they're curving, but essentially, like at your local point, you can just treat it as a straight line. I'm like, oh, so what? Like perpendicular to the surface, and it's like, yeah. So and I said, so a flat Earth model, and it spazzed out and like pumped out all this like 10-page thing against the flat Earth model. It says is archaic and blah blah blah. Like just went through the whole wiki thing, trying to debunk it. And I said, oh, slow down. I didn't say the flat Earth model. I said a flat Earth model. And it said, oh, my apologies. Yes, you're correct. It uses a flat Earth model. That's a good way to look at it. It's just like, come on, bro. Paid not to see, paid not to hear, paid not to speak. I like it.
To Popeye and Shake. Wait, can you guys hear me?
Yep.
Okay. Oh. Shake says, hey, how's it going? And Popeye just, Shake, come off mute, brother.
You're next. Wait, are we? Is it glitching? Is Discord glitching right now?
I thought it was just me. Yeah.
Discord keeps getting worse.
Like the more features they add, the more like processes or computer resources it takes to use it.
Yeah, they messed up the screen share feature as well. It was working so well. Now it's trash. I might have to drop out and rejoin.
Yeah, probably.
Hey, what's up, dude? Welcome to the channel.
Oh, thank you.
Yeah, I knew you were there because I could hear you breathing.
Goodbye.
What?
Me?
How did you hear me? I put you on mute. Did you think a mute button was going to stop me from hearing you? Yes.
Are you meaning me? I might be breathing.
No. You got a mic.
No, it was okay. Yeah, I don't know why he ran from that. It just like
Run.
Mars. Yeah, man, he instant transmission out of here. Hey, let's talk to Shake. Shake, come off mute or we're gonna get the rocks.
Get the rocks. Yeah. Abdul? Yeah. Get the rocks. Get the rocks.
So welcome to Miguel.
Okay.
Shake, what up?
What do you mean?
Have you talked to flat earthers before?
How much?
Yo, somebody teed up, talk to him.
Hello. Who is
Miguel, say hello.
Miguel. Welcome aboard.
Also, Denial. Welcome.
Yo, what's up? I can talk if you want. Any Globers in here?
Yeah, Denial sent me a DM, said he's ready to debate.
Let's go.
Also, Miguel sent me a private message and said, hey guys, I want to debate. So we have Denial and Miguel. We're ready to go.
Welcome to the server, guys. Unmute your mics and let's hear your globe evidence. I've just been interacting with someone wondering why we should see curvature over 21 miles. Does anyone here wonder why we should see curvature over 21 miles if Earth was a globe with a radius of 3959 miles?
Welcome to 24/7 Flat Earth Discord.
Hello.
How's it going? What brings you here?
I'm sorry for not answering the first question. My English is not that good. Why I'm here? Why do you think the globe is on Earth? The globe is on fire. I'm sorry.
Okay.
Well, we have hundreds of long-distance observations showing that the Earth can't be a sphere with a radius of 3959 miles.
He left right after he finished talking. People are weird.
Two quick
How
wins, Kiwi.
unfortunate.
Yeah, Kiwi with 2 quick wins.
Let's go for a hat trick.
But my English not so good. It's alright. We understand broken English.
Welcome.
Hello to any globe earthers out there. Please feel free to unmute and we can discuss the lack of curvature
The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology.
Welcome to 24/7 Flat Earth Discord. Please try to remain civilized and cordial. Gravity is not a force.
Hmm?
think I'm gonna go to.
Yeah. Or maybe I'll go make fruit salad first.
Isn't it?
If you don't want any, then we can have it when we wake up. No, it's up to you.
I think I'm gonna.
Okay.
You're hot micing, DJ.
Ah, cheers. Thanks.
Hello and welcome to 24/7 Flat Earth. Welcome, welcome. Flat Earth 24/7. Please open your mic and let's discuss the globe or Flat Earth.
Wonder if we'll see Timbo again. Been thinking about that guy.
I haven't seen him around in a while. It's been a minute. Yeah, I haven't seen him in a round. Yeah.
Last I heard, he was getting his plumbing license, I think.
Nice.
Yeah. I think we've seen the last of him.
Yeah, it'd be like that sometimes. Ebbs and flows with some people in here, including myself.
No gano es pequeño shot. Mira, amigo, lo que yo te digo. No spinning ball, no curve to see. El horizonte siempre está así.
Where's the curve? We search and search. Agua nivelada desde playa church. No motion felt, the ground is still. Las estrellas giran como quieren will.
Flat Earth 101, ven conmigo. No es complicado, ya lo digo. Mira el mar tan sin curvar. La línea recta no va a cambiar.
Gas needs walls, can't press on none. Vacío arriba, solo se hace sun. Planes fly straight sin bajar. La bola que enseña no se puede probar.
Flat Earth 101, come and see.
La tierra es plana, tierra y mar así.
Don't
just trust what you've been told. Busca la verdad, déjala unfold. No spin, no ball, escucha mi voz. Mira el mundo con tus ojos, not with gloss. Tienes la mente, tienes la view. Flat Earth 101, dependent to. Flat Earth 101, dependent to why. Flat Earth 101, nada que hide. Step outside, look at the sun. Bienvenido, amigo, class has begun. Gas needs walls, can't press on none. Vacío arriba, eso no se son. Planes fly straight sin bajar. La bola que enseña no se puede probar. Flat Earth 101, come and see. La tierra es plana, tierra y mar así. Don't just trust what you've been told. Busca la verdad, déjala unfold. No spin, no ball, escucha mi voz. Mira el mundo con tus ojos, not with gloss. Tienes la mente, tienes la view. Flat Earth 101, dependent to. Flat Earth 101, dependent to why. Flat Earth 101, nada que hide. Step outside, look at the sun. Bienvenido, amigo, class has begun.
Yo, what did I do? Man, I was just trying to listen to music together with you, my flat earthers fellow.
What?
Oh, this server is so boring.
Welcome, Bricks. How's it going?
Goodbye.
Well, then, get out of here.
He was trying to mess with the music bots. I text muted him. He didn't like it.
Equal, man.
What's happening, people now?
Was it good?
People are weird.
People seem to notice everywhere that the flat Earth, anti-flat Earth scene has just kind of gone quiet. I wonder if the anti-flatties are at a conference or something.
Mahaba.
Over fences said government shutdown.
Hey, DJ, you around?
Yo.
Yeah, so I was on Angels of Light's live stream this morning. I was listening while I was in both rooms. I was in here live stream, and he had one of his acolytes come in talking about refraction, right? Like, and he didn't know exactly what type of refraction but he was trying to explain to angels, like, there's something you're not taking into consideration. One solar observation that angels did. He did like a long exposure time lapse of the sunset, right? And he's like, yeah, the sun changed angular size. This kid was like saying, oh yeah, well, due to, he was talking about what like atmospheric refraction. It was like, it was funny, man. It was like very similar conversation, like with the infighting. So it was kind of interesting. But yeah,
I've heard.
He didn't understand what the guy was talking.
Yeah, did he do the whole script thing with the whole? It's not.
Yeah,
it's not refraction.
Yeah, the Snell's law. Yeah.
Yeah. I've heard him. He completely. Gee, I wonder where he got that from. That's funny. I heard him do that before, dude. Like they had the ultimate opportunity to absolutely smash that physicist, or not even a physicist. And instead of just showing him a long distance observation that was more than 8 to 10% beyond where the curvature of the Earth should be, like where the horizon should be, he just did the script. It's not refraction. It's because it's not two mediums. And I was like, oh my God, you just totally just screwed up. You could have just had the best gotcha at this guy. And because he said it would be not possible to explain with refraction any observation that is showing a horizon beyond 8 to 15% beyond where it should be on a globe. He said that would be impossible to explain that with refraction. And instead of saying, okay, well, here's an observation where it's thousands of percent beyond, he just did that whole script thing with it's not Snell's law, so it's not refraction, and just completely screwed up a golden opportunity to absolutely own that section of the debate.
Oh yeah, no, the guy would have probably been like really, really swayed, just based on his understanding. But yeah, so like it was a similar thing, and the guy who was bringing it up was so like cocky and arrogant in his just like delivery style. He was trying to be his ass, but he just couldn't do it. So it just turned into this like really uncomfortable kind of deja vu, where the two are getting conflated.
Yep. Probably. Yeah. Oh man.
Yeah. One of these days, I mean, we got to get on. Have a conversation.
I'm so sorry. Sorry.
Yeah. All right. It doesn't sound like you're sorry.
Which channel? Which channel should I send him to?
Oh, vegans are better. Send him there. It's like the bog of eternal stench.
But yeah, that annoys me when that happens. And if the Globe knows what they're talking about,
explain it so well. I think you explain it so well that if my buddy from,
your microphone's intermittently cutting out.
Oh, okay.
But yeah, no, I hear what you're saying anyway. Yeah, no, I'd like to have a chat with him about that. But yeah. Oh man.
Maybe interview
Yeah, John, you're cutting out like 80% of what you're saying. It's just not coming through.
I'm surprised they're actually shutting NASA down with the government now that they're an intelligence, counterintelligence, and national security agency by executive order. You'd think they're too important to shut down, that they'd all be considered mission essential personnel. I guess we were wrong about that.
Yeah, we're going to war.
It really is funny watching all the Globe copies going out there saying, yeah, we always knew NASA was intelligence. Of course, they were. That's why they had the space program in the first place. We all knew that.
Yeah, but they've proved themselves not very good at spying. Mm-hmm.
I mean, look at Don Pettit, master spy, right?
You know what I find really weird is that here in Poland, if you go outside on a clear night, right, for years, we've been going out and you can stargaze and you'll see little things flying across the sky that look like little stars going across the sky. They'll be moving in all different directions. And every single time we go out there, even if it's just for 20, 30 minutes, we'll see dozens and dozens of them every single time for years without fail. And now, all of a sudden, they're all gone, completely gone. There's not one left up there. We've sat out there like we put the blow-up bed out on the yard and laid out there for like 4 hours or something the other night. We did it like 3 or 4 nights in a row. Not one. Like, they're all gone. People saying they're satellites previously. Where have they gone? It's weird that NASA's funding's been cut, and now all of a sudden, all of these little things flying across the sky have disappeared completely, right? Clear night after clear night. We have not seen one. It's freaking weird. Were they some kind of surveillance things? Some surveillance drones or something like that? Because people, if they're saying they're satellites, they can't just be gone all of a sudden.
It's like, no, please come back. That was normal.
They were there for years, every single time without fail. and they're completely gone. We've had some of the clearest nights and not one. Like, doesn't make any sense.
And it is absolutely true. Like if you take night vision goggles and look up at the night sky, you see all kinds of weird crap.
Oh yeah, we're still seeing weird crap in the sky, like seeing stars disappear. Saw 4 stars disappear, and seeing stars like they'll flash a few times a bit, and then they'll disappear. Like flash really really bright, and then flash again, and then a smaller flash, and then it's just gone. And just seeing weird shit in the sky.
I really need to compile some documents that I went through recently. So I mentioned this earlier today. The U.S. after World War II had taken German V-2 rockets and were firing them off in the White Sands missile range in New Mexico. And one of the most famous ones was called Project Hermes. And I don't know if these stories originated in Hermes or if it was Hermes plus other projects or other projects related to it, but they absolutely were experiencing funny business with V-2 rockets, and they launched them up into the upper reaches of the air. I mean, we're talking like 1 million feet altitude. And something just kept fussing with all of their electronics over and over again. It was almost like there was some kind of, I hate to sound like a kook, but almost like there's some kind of intelligence that was up there that was messing with them. And a lot of the scientists and doctors seemed very concerned about this and mystified. Like, you know, they would go up there and measure this amount of radiation. And so then they would come back and like affix the shielding to the rocket and then go send it up with the instruments. And then, oh no, their radiation was like twice as much. So they're like, well, that's weird. So they double shield it and then send it back up again. And then the radiation was 4 times as much in the same place. And like, what is going on? Electronic circuitry would, for no reason, like turn off and on. Telemetry data would report one orientation when the missile was facing another direction. It was just like kooky stuff like you would read about in Bermuda Triangle stories.
Yeah, that's interesting, man.
Yeah, and like these green orbs. These green orbs up there was a thing. Like this, I think actually was the impetus behind Project Grudge and Sign and all those Air Force projects to study these unknown phenomena. These things would detect and these green orbs up there, and then people would track them on the ground and looking up near the V-2 rockets where they were launching into the blackness. There would be these green orbs in the vicinity of these V-2 rockets. What the hell are those? And all that was in the documentation I had. Things that make you go, I mean, you know, anytime anybody sets out on an expedition or an adventure, there are all these tales of the unknown. And, you know, it just plays with people's natural psychology to try and make sense of things that they don't understand and then fill in the gaps with fiction. So I'm sure there's an element to that. You know, everything from krakens out in the far reaches of the ocean to, you know, Yeti and the Pacific Northwest in the redwood forest running around. And it's not to say that these things aren't there and there isn't an element of truth to this. And perhaps the truth is even far scarier than these silly urban myths. But, you know, we don't know what's happening. And I wonder if there's still a lot of unknown, weird, spooky stuff going on today.
Yeah, there is. So, sometimes.
Oh yeah, I was just going to say, traditional pilots have crazy stories of freaking UFOs and crap like that, and on their normal conventional flights.
Yep. Yeah, I've seen too many videos of weird things in the sky flying around. That, you know, I have no idea what it is, but there's some crazy shit going on up there that it's very difficult for anyone to explain. And even with things here on the Earth, like you were just saying a minute ago, like sometimes while we're working, we just put on something that's easy to listen to in the background. So we'll put on that. It's a podcast called Sasquatch Chronicles, and there's thousands of episodes, or well over 1,000 episodes, and it's like police officers and army people.
Testing. Cut out there, DJ. Maybe it's me. I'm going to relog.
No, it's not you. No.
Testing. Hello.
We hear you loud and clear.
Wonderful. Thank you.
You're welcome. How are you?
Donka.
Doing great.
That's nice to hear. So why do you think the Earth is flat?
Well, first off, it's what we experience. I never experienced Earth curvature in my life. I never felt the Earth spin. I never had anything to compare the globe to know that the pictures that they show me on TV, the pictures they show me on the internet, are what Earth should look like. I don't know. I have to trust and accept that based on face value. So what I experience to be true is not what I'm told is true. It begins with that.
Yeah, I think you didn't experience that what you said. I think that's because of the gravity. You don't feel the Earth like moving. I don't know if that's right.
They say it moves so slowly that you can't feel it. Well, so how do you know it's moving at all?
I think because from the spaceship, or from the rockets, like when an astronaut is going up there, like if you get what I want to say.
Yeah.
I think, and you don't experience or you can't see it because you are on the planet, and because of the gravity you don't experience it. But when you would fly out in the space with a rocket, you could see that the Earth is moving.
That may be the case.
You come back
none
when
of us are ever going to be able to. Oh, hey, T-Dub.
Hey.
I'm sorry, can you...
It's the same, yeah. Come back and tell us when you've done that, and then you can appeal to it.
Master Yoda, could you please repeat that?
Yeah, he was saying that if you have to go to outer space to know that the Earth is a globe, then why don't you go do that? Why don't you be an astronaut and you go check? Because none of us can, and I would say none of us ever will.
But I think, look, let's think about this. I would go there now, like I would be an astronaut and fly out there, and then I come back and I would go back here and tell you the Earth is a globe. But the question what I have, don't think that you will believe me. So I think
No, I wouldn't.
Well, if you had you would have to have evidence. This right? You would act with and not have any evidence. Did it have zero data? Right? I mean,
But aren't
that
there
correct?
pictures from the
that?
Earth?
Yeah, there
Or
are
I'm
pictures, whatever they are. You don't know what Earth should look like to know if those pictures are true.
Okay, so if I would fly out there now, I'm in the space, and I would take some pictures, you would just say that pictures are not true. Or
No. I'm saying you can't do that, but you're speaking only hypothetically, aren't you, right now?
yes, I am.
Okay, so hypothetical proof?
Hypothetical proof?
Yeah, is your proof of the globe just hypothetical?
Oh, sorry. Yeah, yes.
Yeah, you understand what I mean. So that's the conundrum, right? Now, we have in our community measurements. That's right, we have measurements of the Earth. And what we've measured does not reveal a globe, not one bit. It's flat. So if an astronaut goes up into space and comes down and says it's a globe, I'm going to look at my measurements and say, well, how's that possible? How is it possible, Mr. Astronaut, that you are experiencing a globe when I've measured the Earth to be flat?
I think, but if the Earth would be flat, where would be the water? Like, if the Earth would be flat, I think it must have like an edge, and like, wait, like where the water would go. If you get what I want to say.
You mean a shoreline for a containment?
Yes, right. Because I think if it would be flat, it would just like when it comes to the edge, just like wait.
Well,
like
so here's
just
the
slow
thing.
down.
Flat Earth is not a space planet. It's not a pizza flying around